Some of the world's largest enterprises are running their mission-critical workloads on Oracle's next-generation cloud platform called Oracle Cloud Infrastructure. And today, I am really excited to tell you more about it. In this lesson, you will see a general overview of what you can do in OCI. Let's get started. To keep things simple, let us break them down into 7 major categories: core infrastructure, database services, data and AI, analytics, governance and administration, developer services, and application services. But first, the foundation of any cloud platform is the global footprint of regions. We have many generally available regions in the world, along with multi-cloud support with Microsoft Azure and a differentiated hybrid offering called Dedicated Region Cloud at Customer. We have building blocks on top of this global footprint, the 7 categories we just mentioned. At the very bottom, we have the core primitives: compute, storage, and networking. Compute services cover virtual machines, bare metal servers, containers, a managed Kubernetes service, and a managed VMware service. These services are primarily for performing calculations, executing logic, and running applications. Cloud storage includes disks attached to virtual machines, file storage, object storage, archive storage, and data migration services. OCI offers a complete range of storage services for you to store, access, govern, and analyze your structured or unstructured data. Networking features let you set up software-defined private networks in Oracle Cloud. OCI provides the broadest and deepest set of networking services with the highest reliability, most security features, and highest performance. Then we have database services. We have multiple flavors of database services, both Oracle and open source. We are the only cloud that runs autonomous databases and multiple flavors of it, including OLTP, OLAP, and JSON. And then you can run databases in virtual machines, bare metal servers, or even Exadata in the cloud. You can also run open source databases such as MySQL and NoSQL in the Oracle Cloud Infrastructure. Data and AI services. We have a managed Apache Spark service called Dataflow, a managed service for tracking data artifacts across OCI called Data Catalog, and a managed service for data ingestion and ETL called Data Integration. We also have a managed data science platform for machine learning models and training. We also have a managed Apache Kafka service for event streaming use cases. Then we have governance and administration services. These services include security, identity, and observability and management. We have unique features like compartments that make it operationally easier to manage large and complex environments. Security is integrated into every aspect of OCI, whether it's automatic detection or remediation, what we typically refer as cloud security posture management, robust network protection, or encryption by default. We have an integrated observability and management platform with features like logging analytics, and application performance management, and much more. Then we have a bunch of developer services. We have a managed low-code service called Apex, several other developer services, and a managed Terraform service called Resource Manager. For analytics, we have a managed analytics service called Oracle Analytics Cloud that integrates with various third-party solutions. Under application services, we have a managed serverless offering called Functions, an API gateway, and an events service to help you create microservices and event-driven architectures. We have a comprehensive connected SaaS suite across your entire business: finance, human resources, supply chain, manufacturing, advertising, sales, customer service, and marketing, all running on OCI. That's a long list, and these 7 categories and the services mentioned represent just a small fraction of more than 80 services currently available in OCI. Fortunately, it is quick and easy to try out a new service using our industry-leading free tier account. We are the first cloud to offer a server for just a penny per core hour. Whether you are starting with Oracle Cloud Infrastructure or migrating your entire data center to it, we can support you in your journey to the cloud. In this lesson, we will cover the core constructs of OCI's physical architecture, starting with regions. Region is a localized geographic area comprising of one or more availability domains. Availability domains are one or more fault-tolerant data centers located within a region but connected to each other by a low latency, high bandwidth network. Fault domains is a grouping of hardware and infrastructure within an availability domain to provide anti-affinity. So think about these as logical data centers. We looked at it in the previous lesson. Today OCI has a massive geographic footprint around the world with multiple regions across the world. And we also have a multi-cloud partnership with Microsoft Azure, and we have a differentiated hybrid cloud offering called Dedicated Region Cloud at Customer. But before we dive into the physical architecture, let us look at how do you choose a region. First thing is choosing a region. You choose a region closest to your users for lowest latency and highest performance. So that's a key criteria. The second key criteria is data residency and compliance requirements. Many countries have strict data residency requirements and you have to comply to them, and so you choose a region based on these compliance requirements. The third key criteria is service availability. New cloud services are made available based on regional demand, at times regulatory compliance reasons, and resource availability, and several other factors. Keep these three criteria in mind when choosing a region. So let's look at each of these in a little bit more detail. Availability domain. Availability domains are isolated from each other, fault tolerant, and very unlikely to fail simultaneously. Because availability domains do not share physical infrastructure such as power or cooling or the internal network, a failure that impacts one availability domain is unlikely to impact the availability of others. So as you can see in this graphic here, a particular region has 3 availability domains. One availability domain has some kind of an outage, is not available, but the other 2 availability domains are still up and running. We talked about fault domains a little bit earlier. What are fault domains? Think about each availability domain has 3 fault domains. So think about fault domains as logical data centers within availability domains. So as you can see in the picture here, we have 3 availability domains and each of them has 3 fault domains. So the idea is you put the resources in different fault domains and they don't share single point of hardware failure like physical servers, physical rack, top of rack switches, or power distribution units. You can get high availability by leveraging fault domains. We also leverage fault domains for our own services. So in any region, resources in at most one fault domain are being actively changed at any point in time. This means that availability problems caused by change procedures are isolated at the fault domain level. And moreover, you can control the placement of your compute or database instances to fault domain at instance launch time. So you can specify which fault domain you want to use. So what is the general guidance? The general guidance is we have these constructs like fault domains and availability domains to help you avoid single points of failure. We do that on our own. So we make sure that the servers, the top of rack switch, all are redundant. So you don't have hardware failures, or we try to minimize those hardware failures as much as possible. You need to do the same when you are designing your own architecture. So let's look at an example. You have a region, you have an availability domain, and as we said, one AD has 3 fault domains. So you see those fault domains here. So first thing you do is when you create an application, you create this software-defined virtual network. And then let's say it's a very simple application. You have an application tier, you have a database tier. So first thing you could do is you could run multiple copies of your application. So you have an application tier which is replicated across fault domains. And then you have a database which is also replicated across fault domains. Why do you do that? Well, it gives you that extra layer of redundancy. So something happens to a fault domain, your application is still up and running. Now, to take it to the next step, you could replicate the same design in another availability domain. So you could have 2 copies of your application running, and you can have 2 copies of your database running. Now, one thing which will come up is how do you make sure your data is synchronized between these copies? And so you could use various technologies like Oracle Data Guard to make sure that your primary and standby, the data is kept in sync here. And so that you can design your application, your architectures like these to avoid single points of failure. Even for regions where we have a single availability domain, you could still leverage fault domain construct to achieve high availability and avoid single points of failure. Let's summarize what we learned in this lesson. So we looked at region comprises of availability domains comprise of fault domains. So let's look at the inside out view. So first let's start with fault domain. Fault domain provide protection against failure within an availability domain. Availability domain themselves provide protection from entire availability domain failures, particularly in a multi-AD region. And then you have this concept of region pair, where in every country we operate, or most of the countries we operate, we have at least 2 data centers. So you could use the second data center for disaster recovery or backup, or it also helps you to comply with data residency and compliance requirements. And then not only this, we also have SLAs on availability, management, and performance. To recap, we looked at the physical architecture of OCI with regions, which are geo locations. We looked at availability domains, and then every availability domain has 3 fault domains. So use these architectural constructs to design your applications which are highly available and avoid single points of failure.
Hello and welcome. In this demonstration, I am going to show you how you can create an Oracle Cloud Infrastructure free tier account. So let's get started. Before I show you the process of creating the free tier account, let me take you to oracle.com/cloud/free. And here you can see what's included with Oracle Cloud free tier. So there are basically 2 key things. First, there is something known as always free cloud services. So these are the services that you can use for an unlimited time, and you can see the examples over here. Then there is a 30-day free trial where you get free credits. As you can see, here I am getting $300, and you can check the list of all eligible services. Now let's look at how we can create a free tier account. So here you can see I am inside oracle.com/cloud/free. So I can click on start for free. So now I'll be redirected to the sign up page where I need to select the country. I'll also be providing my first name and the last name. And I also need to provide the email address. So this email address that you provide here is going to become the tenancy administrator. And then I will validate that I am a human. So the validation is successful. I'll click on verify my email. Now if I go back to the mailbox, I can see that I have received an email. Let me verify it. So once the verification is successful, you will be redirected to this page where you need to provide the information with respect to the password, your company name, which is optional, and you also need to provide your cloud account name. And you can see the cloud account name. You have to select the home region and click on continue. Now in the next page, you need to provide your address information. So I will provide my address. I'll also provide my phone number and click on continue. Now we have to add the payment verification method. We can use credit card as well as debit card here. So I will use credit card. And for privacy purposes, I will basically cut this video. So you see that the payment verification is now successful. Let me click on start my free trial. You will also be charged a fee that is going to be reversed. So that's just for verification purposes. And you can see the message that it is currently setting up your account. So once this is done, you can sign in to the OCI console. Alright, so let me open up a browser and go to cloud.oracle.com. I'll provide the cloud account name, OCI Arc Associate. Here you can see that the identity domain is default. So I will provide the username and the password. And then I will click on sign in. So as you can see, I am inside the OCI console. And you also get a message that your account is currently being set up and some features will be unavailable. And in some time your account will be set up. So this marks the end of this demonstration. Hello and welcome. In this demonstration, I will walk you through the OCI console. So let's get started. Let me first log in to cloud.oracle.com. So the very first thing that I need to specify is the cloud account name. In my case, it is OCI Arc Associate. So I'll click on next. Now I need to select an identity domain. So I have two identity domains. The first one is default, and then there is a sandbox identity domain. So I will select default. I'll click on next. I'll specify the username and the password here. And this user is the tenancy administrator. So let me click on sign in. You are inside the OCI console. And the very first thing that I want to show you is how to select a region. So if you click here, you see that the home region for my tenancy is US West or Phoenix. Now in case I want to subscribe to a new region, I can click on Manage Regions. I'll see the list of all the infrastructure regions. To subscribe to a region, I simply need to click on Subscribe. Now let me return back. Let me click on Hamburger menu. And let me go to a particular service category. And you can see here there are different service categories. For example, compute, storage, networking, database, analytics, developer. You see observability and management, billing, marketplace, OCI classic services. So let me go to networking. When I click on networking, I see all the services related to networking over here. For example, I'm able to see virtual cloud networks, load balancers, DNS management, IP management. So this is how you can click on the service category and browse to a particular service. The next thing that I want to show you is the search bar. So this is the search bar, and here you can search for resources, services, documentation, as well as marketplace. For example, I want to create a virtual cloud network. So I'll just type virtual cloud network, and you see under resources, you get to see this. Under services, you are able to see virtual cloud networks, and you can also see the documentation as well as the marketplace. Now the next thing that I want to show you is you can also use Cloud Shell. So if you just click on this button, so once this is done, you will be able to interact with your OCI resources programmatically. And we can see that this is done. So using this, you can interact with your OCI resources programmatically. And as you can see here, your Cloud Shell machine comes with 5 GB of storage for your home directory. Then you have this announcements where OCI alerts you of any operational events that is going to impact your service or your environment. And you can also create an announcement subscription. To visit the support center and create a support request, you can click on this question mark, and as you can see here, you can visit the support center, you can post a question to the forum, you can chat with us, and you can create a support request as well as raise a request limit increase. This is where you can change the language. So you can customize the language as per your requirement. And then here you find the profile information, things like identity domain. You can see that I'm currently using default identity domain. Then you see the tenancy information, OCI Arc Associate, the signed in user details. So if I go to the console settings, here I can customize the session ideal timeout. So I can click on custom number of minutes and specify any number between 5 and 60. And you can also select the profile that best describes your Oracle Cloud work and interest. For example, I have specified Cloud Architect. So I can click on Save Changes. The final thing that I want to show you is with respect to billing and cost management. So if I click on the hamburger menu, I can go to billing and cost management. Under cost management, I can click on budgets. So it's a good practice to use budgets. It helps us track costs in our tenancy. So before you go ahead and consume any services, you can create a budget that is going to set up alerts for you. And in case your spending exceeds certain limit, it is also going to notify you. So I'll click on create budget. I will give it a name, demo budget, and the scope of the budget is on compartment. I can select the target compartment or the root compartment. I can specify which day of the month to begin budget processing. So for me, the first is fine. And what's the budget? Let me specify 1,000 Singapore dollars. Now you can select either the actual spend or the forecast spend. Let me select actual spend. And then what is the threshold type? Is it going to be a percentage of budget or is it going to be absolute amount? Now let me make here 75%. So I am setting 75% of the budget as the threshold type. And then I can specify the email recipients. So I can specify OCI Arc associate@gmail.com. And what is the email message that you want to send? Let me click on create. So this is how you create a budget. This marks the end of this demonstration.
Welcome to an introduction lesson on OCI Identity and Access Management. This is the first lesson in this module, and in this lesson we are going to quickly look at the high level concepts which OCI Identity and Access Management deals with, and in subsequent lessons we are going to dive deeper. So let's get started. At a very high level, IAM stands for Identity and Access Management, and the whole idea is to give you fine-grained access control. The concept is that the user is assigned one or more predetermined roles, and each role comes with a set of permissions. So you also hear this term called role-based access control or fine-grained access control, and that's basically what is implied there. And there are two concepts Identity and Access Management really deals with. One is authentication, also referred to as auth-n. And auth-n basically has to deal with identity or who someone is, and making sure that a person or a device is who or what they claim to be. So that's pretty much what auth and authentication is. And then authorization, also referred to as auth-z, has to deal with permissions or what someone is allowed to do. So once you're authenticated, what kind of permissions do you have? What kind of access control do you have, right? So very simple terms, when you go to a website, let's say it's a banking account you have to authenticate yourself by providing a username and a password. And then the website knows that you are who you claim to be and you are inside the system. Once you are inside the system, let's say it's a banking application, there are certain things you are allowed to do. You can transfer money, etc. And there are certain things you are not allowed to do. You cannot transfer beyond a certain amount every day. But then a bank manager has more access and they can change your access permissions, etc. So that's a very simple way to think about authentication and authorization. Now, in case of OCI, there are several concepts. And in this module, we will deal with many of these individual lessons. Things like users, groups, identity domains, principals, dynamic groups, compartments, etc. At a very high level, identity domain is a way for us to segregate users. So let's say you have a set of users for production, set of users for development. You could separate them using this logical container called identity domain. So you could do that. There is another concept called compartments, and that's the fundamental building blocks. Basically, your resources, you can logically isolate them and secure them using this concept called compartments. So these are kind of, again, logical containers, and so on and so forth. We'll look into many of these in subsequent lessons. Again, at a very high level, how does this role-based access control work? Well, you have users, and we group these users in what are referred to as groups. And think about group as a collection of users who have the same requirements or similar requirements. So you have storage users, you could group them as storage users group, or you have administrators, you could group them as administrators. And then you write these things called policies for these groups, and policies basically give access to these groups and the users in those groups to individual resources. So the whole idea, again, remember, it's role-based access control. You want to give granular permission to these users, and you do that using the concepts of groups and policies. And for the users, authentication happens through various mechanisms, including username, passwords, API signing keys, etc. And then for policies, for authorization, we do that in OCI using policies, and these are done in kind of a syntax which is easy to understand, kind of human readable syntax. So we'll again look into all these in subsequent lessons, but this is how the whole identity access management, authentication and authorization works. One last thing I want to touch in this particular lesson is every resource which you create in OCI is an object. So you see block storage, buckets, object storage, compute instance, containers, all are these objects, because for us, we need to identify these objects and we need to kind of work on these objects, right? Otherwise, we cannot give granular permissions to users on these objects. So how do we identify these resources? Well, every resource has a unique identifier, which is called OCID, abbreviation for Oracle Cloud ID. And it's a unique Oracle assigned identifier. So you don't have to assign this or change it or update it. And it follows a particular syntax. And the syntax is shown here. It starts with OCID1, and then there's a dot, a period, there's a resource type, there is a realm, there's a region, there's something for future use, and then there's a unique ID. So this is kind of a long string. OCID1 basically is kind of stands for the first version or version 1 for Oracle Cloud Identifier. Resource type is different kind of resources you have, whether it's block volumes, your tenancy, your compartment, or any kind of resource you have. And then realm is basically a set of regions that share the same characteristics. So there is a region for commercial, it's OC1. There is a region for government, OC2, and also has implications on like the domain name, etc. A region used to be a 3-character code. Now it's a longer string. So you have a region there, and then there's this unique ID, which is how the resources are kind of identified. So this is the fully qualified string, and this string is used, for example, when you are dealing with CLI. You have to provide the string. That's how we are able to identify a particular object, or a particular resource. So you can see here, tenancy, which is your account, has this particular OCID, and because this is across regions, so you don't see a region reference here. This is the string. The last part is the string, which is the unique identifier. OCID1 is here. Tenancy is the resource type. OC1 is the commercial realm. And if you look at something like block volume, because it's a regional service, you can see that there is OCID1, volume is the block volume, OC1 is the commercial realm. There's a region here, EU Frankfurt 1, and then there is the unique identifier. So this is how we kind of identify these resources. This is useful if you're working on the console. You probably would never kind of use it. But if you're using CLI, for example, you would be required to provide the OCIDs, which you can get from the console or by calling the CLI, and then you would use these in your day-to-day activities. Welcome to this lesson on OCI identity domains. So first, let's look at what is an identity domain. An identity domain simply represents a user population in OCI and the associated configurations and security settings. Think of identity domain as a container for managing users, roles, federation, single sign-on, and many more advanced capabilities like MFA. So as the graphic is showing here, within the OCI Identity and Access Management Service, you have this concept of identity domain, which is kind of a container, or think of it as a metadata using which you can segregate and separate your users and manage them accordingly. Now, why would you do that? Well, there are several use cases for doing that. Imagine you have a development environment and you have a production environment and you want to keep the identities separate. So you could use a construct like identity domains to do that. Imagine you have employees and non-employees and you want to manage identities, both identities in a single identity as a service solution. So using identity domain types, you could actually do that. So that brings me to the different SKUs which are available with identity domains. So the first SKU which is available is the free identity domain. Now, when you provision an OCI account, every account by default includes an identity domain. It's called a default identity domain, and this allows customers to manage access to all the OCI resources. So if they don't want to create anything additional, they could always use the free default identity domain. The second kind of identity domain is the Oracle Apps Premium. And the idea here is if you're using any of the Oracle SaaS applications or any PaaS or GBU applications, you could manage the identities for those applications using this identity domain type. Now, not just that, if you're also using any kind of on-premises applications like JD Edwards, PeopleSoft, Oracle Linux, Oracle Database, you could actually use those on-premises environments and manage the identities in the cloud using Oracle Apps Premium identity domain type. And there are limits, as is the case with every SKU, but that's the primary use case. The third domain type is the premium domain type. This is our highest SKU. And in this one, you could use Oracle apps or you could use non-Oracle apps. So it extends beyond just Oracle apps, which is the case with Oracle Apps Premium here. I mean, the name kind of signifies that. And then also, like Oracle Apps Premium, this particular SKU also supports hybrid scenarios. So anything you're running on premises, those scenarios we talked about are also supported. And the final domain type is what is called as external user. And the idea here is you would use this for consumer and non-employee use cases. So if you have contractors, you want to give them access, or if you have a consumer application which can scale to millions of users, you want to manage their identities, you would use something like an external user domain type. And you can see it supports features like social login, self-service, password management, etc., right? It also has support for some of the hybrid features. Now, as we discussed, when you provision your account, you get a default identity domain, but you can choose to create additional identity domains. And it's also possible to change your domain type from free to Oracle Apps, etc. And there are restrictions on those, so you should read up documentation. Welcome to this demo on OCI identity domains. In this demo, we are going to take a quick look at what identity domains look like. So the first thing I do here is I log into my account, and this is the name of my account. I click next here, and it will bring me to the login screen. And the first thing you notice here is it telling me that I have a default domain. As you recall from the theory lesson, when you provision your OCI account, you are given a default identity domain, which is called default, and it's available for free. And if you hover over this information box here, you can see the description for identity domain. It's a container for managing users and groups and SSO and federation and advanced capabilities. So I would provide my credentials here. And then hit on sign in. And you would see that as I sign into my account, you can see identity domain in action. So first thing I'm going to do is click on the burger menu here and click on identity and security and click on domains here. So first thing you notice here within, you have different columns with different features and sub features. And within identity, you see things like overview, domains, network sources, policies, compartments, etc., right? you no longer see things like users, groups, etc. Available as part of the menu here. So if you click on domains, as we discussed, it's a container, and the container has all these capabilities where you manage your users, your groups, etc. So you can see here that by default, I have an identity domain which is called default, and you can see here in parentheses it says this is my current domain. And if I click on this, I can see it's active. You can see various features. So I can manage my users here. I can manage my groups here. Dynamic groups can be managed here, and there are more advanced capabilities like applications, reports, security, etc. If I click on security, it brings up lots of advanced capabilities like MFA. How do I change my MFA settings, OAuth, federation? How do I set up identity providers and adaptive security, and so on and so forth, right? In this particular course, we're not going to deal or touch many of these features. In more other advanced courses, we will look into these. So if I go back to my domain type, I can see here that there are a lot more capabilities. I can run some reports. I can configure MFA. I can configure SSO, etc. I can also change my domain type. So if I click here, it gives me an option to change from the default free domain type to premium, Oracle Apps Premium, or external user. I believe external user is not allowed, so if you click on it, not let me proceed. But others, you could change. Let me go back and try to create another domain and show you how easy it is to create a domain. So why would I do that? Well, let's say I have a use case where I have a sandbox which I want to manage for development purposes, and I want to give users access to that sandbox. Once the work is done, I could delete the whole sandbox and all the associated identities. So I click on create domain here, and I can give it a name. Let's say call it sandbox. Call it sandbox domain. It's a free domain, so I'll use that. And then I need to create a domain administrator. Now I could choose not to do that, but let's do that. Provide my name here. And I need to provide my email ID, and then I click create domain here. And you would see that within a few minutes, my domain would be created here. And this is my secondary domain. So I could create domains like these, and you should always read up on the limits, etc. And once the domain is created, I could add users. Like you see here, the various users which are available. I have various groups which are available. So I could create my users, groups, my dynamic groups, etc. Now, one thing quickly I'll note here is policies sit outside domains. So the idea is you can write policies independent of the domains, and domain is a resource. So when you create multiple domains, you would write your policies accordingly, where you reference the domain name. And in another lesson, we will look into how you would do that. And you would see here within less than a minute, my sandbox identity domain is created. So that's how simple it is to use these domains. A couple of quick things I just want to point out is on the documentation page, you can see the difference between all the SKUs. As we mentioned, there's free, there is Oracle Apps Premium, there is Premium, and there is external user. There's also something called Oracle Apps, but this is internal to kind of Oracle SaaS applications which we are running, so you don't see that in the console. And as you scroll down, you can see all the different kind of features, capabilities, and the premium SKU is the highest SKU. So you will see most of the features are available in the premium SKU, but you should definitely take a look here and see what different features are available. And you scroll down, you can see limits, etc., how many domains you can create, your API rate limits, etc. Another resource to use are the FAQs. So if you scroll here on this particular URL, you can see FAQs for identity domains and other IAM features. A couple of things I just want to call out is things like, can I mix employee, non-employees in a single identity domain? No, idea is to keep them separate, right? And you can read more about them. Who has access to an identity domain? Anyone who is part of the administrators group has access to identity domain. Right here, there's an important point I want to point out is identity domains are resources. So they are created inside of a compartment, and access to manage these domains is tied to the compartment permissions. So not necessarily everybody, you have to give access to the identity domains. You can restrict access by putting them within separate compartments. In our case, when we created identity domain, we put them in the root compartment, but I could have decided to scope it in another compartment. So that was a quick demo on identity domains, how to create one, what different kind of features are available, and some quick FAQs on it. In this particular lesson, we are going to look at OCI IAM authentication, or also referred to as Auth-N. So before we get into details, let's first define what is a principal. A principal is an IAM entity that is allowed to interact with OCI resources. So as you can see here, a principal can be users. So these are the IAM users in the system, or principals can be resources or services themselves. A good example here is instance principal, where you designate an instance, a compute instance, as a principal. And what it does is the instance principal lets instances and the applications running on those instances make API calls against other OCI services. So when you think about principal, think about users, and users can be human beings, as well as the services themselves can be principals. And we'll look into these in detail in subsequent lessons. Now, there's also concept of a group. A group is a collection of users who all need the same type of access to a particular set of resources. So this can be, you can have users who create networks and many users who create networks, and you could put all of them in a network user group. Similarly, you can have a set of users who administer networks or manage networks, and you could put them in the network admin group. So there itself you can create two different sets of users because they have different set of needs. Network users are just updating the networks, where the network admins are determining things like your CIDR blocks, etc. Right? So you get an idea of what kind of needs users have, and you can group them together. Now, the authentication in OCI is done by three different mechanisms. The first one is the simplest and the one you would be familiar with, and that's using username password. So you provide your username as a user, you get a unique username, you get a password, and then you provide this, and then the system authenticates you, meaning you get access to OCI resources. Second kind of authentication mechanism is by using the API signing keys. As we talked about, when you call the OCI CLI, or you call the APIs, or you're using the SDK, etc. When you write your applications, those applications are also those APIs also need to be authenticated, and for that authentication to happen, because it's no more a human who is trying to log into the system, you can use API signing keys for authentication. And as you can see here, this is the public key which you provide, and the private key is something which your application has access to, and this is how the authentication happens. The third, as you see here, it's the RSA key pair, the public key and the private key, and that's how the authentication happens. The third mechanism to do authentication is by using auth tokens, and as you can see an example here, these are Oracle generated token strings. Every user can generate up to 2 auth tokens. These auth tokens don't expire, and you can use them to authenticate third-party APIs. So for example, if you are using Docker containers and you want to push your images to the Docker Hub, because that doesn't understand OCI signature-based authentication, you could generate an auth token and use that with third-party APIs, in this case, the Docker registry. In this particular demo, we are going to look at how you can create users, groups, and in a subsequent demo, we are going to look at how you can authorize these users to perform certain actions. So let's get started. In a previous demo, we created a domain called Sandbox. As you recall, when you create an OCI account, you get a default identity domain, which is a free domain, but you can create secondary identity domains. So in this case, we have gone ahead and created an identity domain which is called Sandbox. So we're going to use that particular domain. Now, as you scroll here, you can see users, groups, etc. listed on the left-hand side. If I click on users, you can see today I'm logged in as an admin. So this is the only user which is available. And for the groups, you can see that there is all domain users and there is also a domain administrator. So any user you create could either go as a domain user or could go as a domain administrator. So let me go ahead and create a user here. It's pretty straightforward to create. Let's say first name is John Doe, and for my email, I already have an email ID which I use for another course. So I will use that email ID as the username, or you could decide to use username as something else. So that seems a little bit more convenient. So let me do that. And my username I would refer to as john.doe. And then right here, I could put this particular user as a domain user, or I could put the user as a domain administrator. So let me skip this for now and let me just click create here. And what will happen now is this particular user is created and I can assign this user to a group. We'll create a group in a second. But right now, the email ID I provided, this particular user would get a notification saying that an account, I have been provisioned as a user in this particular account and I need to activate my account. So before we do that, let's go ahead and create a group here. So click on create. The two groups exist here. Let me go ahead and create a network admin group. So this group is called network admin, and this is the group for network admins for the sandbox domain. And I'll create this particular group here. And then what I'll do is I'll assign users to this particular group. I'll assign John Doe to this particular group here. And it's pretty straightforward here until this point, right? So now what I need to do is I need to log in as this particular user and see what kind of what the experience looks like. So in my email ID, I get this email saying that my account is ready and I can activate my account. So let me just log out from my other email ID here. And actually I can sign out now, close this tab, and I click on activate your account here. And this is now John Doe who is trying to sign in. So first thing you see here is identity domain now is sandbox. It's no more default because this particular user belongs to a sandbox domain, not the default domain. And the username is john.doe and it's asking me to pick a new password. And I can set, as you can see here, it gives me some restrictions on the password policy. It must have 12 characters, lowercase, uppercase, you can read here. And I can customize this experience. Now in this particular course, we are not going to touch on some of these capabilities, but you can customize your password policies, etc. using the identity domains. So I don't want to save this and I click on continue to sign in. And now this is my tenancy. I'm signing in as, and now you can see here, it's asking me to sign in to a domain and I click sandbox here, click next, and then it's going to ask me for my username and password again. Click sign in. And now I would be able to sign into my account. Don't want to save this password. And you can see here that if I click on identity and security and I click on domains, I'm not able to see. If I click on sandbox, I can see the users here and groups, and you can see that these permissions are not allowed for me, right? And you might wonder and say why this is happening. The reason this is happening is, remember, this particular user is part of network admin group. He's not part of a domain administrators group. So this particular user doesn't have the authorization to look at users, groups, or perform any of these activities. In the next lesson, we are going to write some policies for this particular user and give him some access so he can perform some actions. A couple of things I just quickly want to show on here is, if I click on this on the right hand side menu, I can see click on my profile and it brings up various other capabilities which we talked about earlier. So there are things like API signing keys, there are auth tokens, etc. So I can generate an auth token here. There's, I can add an API signing key here, and there are lots of other capabilities like my request, etc., which come over from Oracle Identity Cloud Services. Now, in this particular course, but in a subsequent more advanced course, we are going to look into a bunch of these details. Auth stands for authorization. And let's see how you can do authorization in OCI. So in very simple terms, authorization basically means that you are giving some granular permissions to your end users. So it deals with things like what kind of permissions do you have. You also hear a term called role-based access control, and it's the same term with a different naming. In case of OCI, authorization is done through IAM policy, Identity and Access Management Policy. And this particular lesson, we are going to look at these policies in greater details. So the way you write these policy is as shown on the screen. The syntax is as shown here. It always starts with allow subjects to do something. So there's a keyword here, actions, in a location. So there's a placement here. And you can make these policies conditional by adding a where condition. So remember, those are the 4 key aspects of IAM policies: subjects, actions, placement, and conditions. Placement we will review in another lesson on compartments. Condition, we have a couple of other lessons where we talk about conditional policies. In this particular lesson, we are going to deal with subjects and actions. So let's get started. One other thing to keep in mind before we go further is these policies are designed to always start with allow something. So by default, everything is denied by default. So we follow the security principle of least privilege, which means that we only provide the minimum needed permissions for an end user to perform his or her activities. So keep that in mind. There is no deny policy because by default everything is denied. So then you start with allow and you allow certain permissions to be given. So what are these keywords and how do they operate? Well, the first one is the subjects clause, and this is kind of your principal actor. And the way you define these subjects are 2 or 3 different ways. First way you define it is by a membership in an identity registered group. So you group users together depending on their role requirements or geographical requirements, or whichever way you want to do them, the grouping. You group these together, like you have a group of administrators, and you can use that as in a subject clause. You are not only limited to go with a name, you can also go with an ID. And in this case, you can say group ID, you follow that with an OSIT, the unique identifier. So this is the first way you can do it. Again, remember, policies you don't write on users, you write these policies on groups, and groups are nothing but a collection of users. The second way you write these subjects is for a particular service. So you could say allow service object storage to do something. Why would you do that? Hold that thought for a second. We will actually go and look that in documentation. You could also use a subject clause with something like any dash user, means anybody who is part of that account could actually do something. And again, there are use cases where you would use a subject like that. And then if you have more than one groups, you don't have to write multiple policies. What you could do is you could chain them by the kind. So you could say group Alice, Bob, Richard, admins. You could group them together and write a single policy which applies to multiple groups. So let's look at why you would use a service name here in a group. But before we do that, you can also write policies for dynamic groups. And dynamic group basically would be used when you are calling a particular service from another service, like compute instance is calling object storage. The way that happens is it's not a human anymore. It's one service calling another service. So you create a dynamic group and you write policies which grant that particular service, let's say compute, some permissions to do something with, let's say, logging or object storage. And again, we have a lesson on this later on in the course where we talk about what dynamic groups are. And then we also do a demo on dynamic groups. So let's quickly look at why you would use a service name within a subject clause. So right here, I'm in the OCI documentation, and you can see these things as referred to as service permissions. And you can read this text here, but the whole idea is you would write a policy like allow service object storage to manage object family in an account, in a tenancy, or you could do it in a particular compartment. Why would you do that? Well, in this case, the particular feature we are talking about is object storage replication. So you can replicate object storage objects buckets from one region to another region. And because object storage is a regional service, you must authorize the object storage service for each region to carry out replication on your behalf. Remember, it's not a human which is doing it, the service is doing this, right? So what is being shown here is you are authorizing object storage in the Phoenix region to manage object family in your tenancy. So you write a policy like this. So this is an example where you would use, instead of using allow group here, you would use allow service to do something on your behalf. All right. So one other thing which you have to keep in mind when we talk about subject clause is this concept of identity domains. Now, this is identity domain is a container to separate your users and groups. As you can see here, we again have a lesson on this where we talk about identity domains and do a demo. But when you write your subjects in the subject clause, you have to prefix them with an identity domain as is shown here. And if you don't do it, every tenancy comes with a default identity domain. So suppose you miss this particular domain here, you kind of don't put it in your subject clause, it will go to the default identity domain. But let's say you have multiple identity domains, it is required that you prefix your group or dynamic groups with identity domains here, because as you can see in the graphic here, users, groups, and dynamic groups are part of identity domain. That's the container. So important thing to keep in mind as you're writing these subjects clause. Now let's quickly look at actions clause. Now, actions clause, basically the whole idea of authorization is to give you granular permissions. And behind the scene, there are permissions, and these are API operations behind that. But it can become very granular if we have to ask you to write policies on API operations, etc. So what we do is we bundle them into convenient kind of verb and resource pairs. And using this way, it's in a plain English kind of syntax, and much easier to manage, much easier to understand. So what are these four different verbs we have? Well, it's inspect, read, use, and manage. And as you go down this hierarchy, the access level increases. So inspect has the least access and manage has the most access. So you can see here the description. Inspect, basically you can enumerate and monitor, but you don't get anything beyond that. Read is basically able to access but not alter resources. Use is you can use this permission to modify pre-existing resources. And manage, basically you can do anything on the resource. And we'll look into the resource in just a second. Let's first quickly look at the verb here. And if I have to give an example, when you say inspect objects, you can learn details about objects stored in buckets, like the quantity, the object exists, etc., without getting access to the object itself. When you write a verb like read objects, you are reading the contents of the object, whatever is contained in the object. When you say something like re-encrypt objects, you're basically re-encrypting the object using a different key version. So this is an example of use verb keyword. And when you say create objects, of course, you are creating object, you can delete objects, etc. So these are the four different verb levels we have, and these are consistent for all resources within OCI. So we have kind of bundled all these permissions behind the scenes to give you this kind of easy to understand, easy to use syntax. Now let's look at the second part of this actions clause, which is basically the resource type. We just looked at the verb inspect, read, use, and manage. So what are the resources? Well, again, to keep things simple, everything is a resource in OCI. You could use something like all-resources. That gives you access to every resource within OCI, right? So you don't have to worry about a new service getting added or missing out a particular service or a feature. You don't have to do that. And then we have these, so this is the highest level of resources available. And then we have these aggregate resource type and individual resource type. And the idea here is each of the resource type, we group them into a family. Like compute has many features and components, and storage has many features and components, and database, and so on and so forth. So instead of dealing with these individual resource types one at a time, you can deal with them at an aggregate level. So you have database dash family, and you could actually write a policy at that level. If you are not comfortable with that, you want to go more granular, you could go to the granular level here, like being shown here, and so on and so forth. You can see instance family, object family, volume family, etc. Now, important thing to keep in mind is some resource types don't have an aggregate resource type, and identity itself doesn't have an aggregate resource type. So when you're dealing with identity, you have to write policies on individual resource types. Let me quickly again jump to the documentation and show you this in a little bit more detail. So I'm in the OCI documentation page here, and again, if you look at the core services, if I click on networking, you can see there is an aggregate resource type, which is virtual network family. So you could write a policy at this level. But if you want to go granular, you could write policies at individual resource types. So manage VCN, use VCN, read VCN, you could do it here, or you could do it here at the aggregate level. And the same compute, you have aggregate resource type, individual resource types down below. If you click on block volume, you have aggregate resource type and individual resource types. Same is the case with database. You click here, you can see all the details. Now, the one I wanted to show you is identity. Now, when you look at identity, there is no aggregate resource types. If you're dealing with identity and you want to write some policies against these components, you have to write policies against the individual resource types. So keep that in mind. It's going to be useful when you are creating a group of administrators and giving them permissions for them to able to write policies or able to create compartments, etc. So remember that you're dealing at the individual resource types, not at the aggregate resource types. Welcome back. As we saw in the theory lesson, authentication has to deal with identity or who someone is, while authorization, also referred to as auth-C, has to do with permissions or what someone is allowed to do. In this particular demo, let's quickly look at how authorization is done in OCI. As we saw earlier, we have the default identity domain, which gets created automatically when you create an account with OCI. And we created another identity domain called sandbox. If we click on it, we see that we also created an user referred to as John Doe. Now let's quickly go ahead and give some permissions to John Doe, because today the user exists, but he has no permissions. So he's not allowed to do anything in OCI. So let me just quickly go ahead and create a group here and name this group OS admin. And this is a group for object storage administrators, and I will add John Doe to this particular group. Until now, we just added John to a group, but we haven't written a policy against that group. And remember, policy is what is the mechanism through which we do authorization in OCI. So if I quickly log in as John Doe here, I want to quickly show you this in action. So if I log in as John Doe, you would see that John is not allowed to do anything in this particular account. So that's the tenancy name. We'll choose the sandbox identity domain because that's where the user exists. And sign in. And now you will see that signed in as John Doe in the identity domain called sandbox. And if I come here and I click on storage, for example, and I want to create a bucket, I will not be allowed to do that. So if I click here, I can see the root compartment, but it gives me an error saying I'm not authorized to perform this request. And the same is true for any other service. If I click on virtual cloud network, you can see the same error message or a similar error message saying authorization failed. and you can go ahead against any other service and you would get the same error. So what it means is I don't have any permission to do any activity in this account right now. So if I quickly switch back to the administrator for this domain, we just created a group called OS Object Storage Admin Group, but we haven't written a policy against it. And if you remember, policies are written outside the identity domain. So if I click on policies here, we can quickly go ahead and create a policy. So let's go ahead and do that. We will say that this is an object storage policy. And there is a nice policy builder using which I could create a policy. So if I click on account management here, it gives me option to pick an identity domain. I can pick a particular group or a dynamic group, and I can also pick a location to scope policy out, whether the policy is applicable to the root tenancy or it is applicable to a particular compartment. So I could use this policy builder. It's a nice way. If I'm not too familiar with the syntax, it makes it much easier. But let's manually create this. Let's remove these policy statements right now and just quickly write this policy. And this policy here says that allow group sandbox. This is my identity domain, OS admin. So this is the group we just created to manage object family, meaning users can create objects, can create buckets, upload objects in this particular compartment, sandbox dash compartment. So my scope is only limited to this particular compartment. And I click create here, and now this policy is created. And what this policy is let me do will allow this particular group, OS admin group, and all its members to work with object storage family, object storage resources. So if I switch back to John Doe's screen here, just quickly refresh the screen. Now, first thing you notice here is I see this compartment which was not visible here. So if I just stay on the root level, you can see that I still cannot do anything. It says authorization failed. But if I click on sandbox compartment, that error message will go away. So if I just refresh this screen. All right, I'm in a virtual cloud network, so I'm in the wrong place. So let me just click on buckets here. And since we wrote the policy against the sandbox compartment just for object storage, in the previous screen, you saw we were in virtual cloud network. There's no policy against that. So of course I couldn't do anything. So if I go back to root here, you would see the same error. I cannot create a bucket in the root compartment at the tenancy level because I don't have authorization for that. But I can do that on the scope of the sandbox compartment. So if I click on create bucket here, just give a random name, click create, I should be able to create a bucket here. And the default behavior is it's a private bucket. So I can see that visibility is private, but I'm able to create the bucket here because now I have the permissions to operate on object storage and its resources in this particular compartment. So hopefully this was a quick demo where we took a user, we added the user to a group, and then we wrote a policy against that particular group. And in the policy, the resource and the verb we said could manage all the resources for object storage, and we scoped it to this particular compartment. So you could work on object storage for this particular compartment. You could, in a similar way, you could write more advanced policies against every service, and you can go very granular. So hopefully this was a quick demo on how authorization is done in OCI. Common IAM policies. So as you can see here, this is a very simple setup. We have an OCI region. Within a region, we have availability domains. These are physical data centers. And within an availability domain, we have a virtual cloud network, which is a logical construct. We have one subnet inside that. And then we have a compute instance running here. And the compute instance has a boot volume where we keep the operating system. And it has data volumes. Collectively, these are part of a service called block volume. Just think about remote storage. So instead of local storage here, there's a remote storage, and boot and block are part of the block volume service. And then for the compute instance, the physical network interface card is virtualized, and the virtual network interface card or the representation of that is kept inside the virtual network. And that's how the compute instance is instantiated. It depends on virtual cloud network, and it also depends on the block volume services. So there is a control plane dependency. Now, this is a setup which you would see in other lessons as well. But the point I want to include here is that there are specific policies you need to write in order for this setup to work. So what are these specific policies? Because in reality, or in practice, there would be different teams working on each of these areas. There might be a team which is managing the networks, there's a team which might be managing compute instances, and there might be a completely different team managing storage. So at least you'll have three different teams, in some cases even more. So how does this whole thing work? So, well, let's say network is something which all the companies, organizations are very careful not to give access to many users or many administrators. So typically you would have a network admin group, and these folks would manage your cloud network. So as you can see here, you would write a policy saying allow group network admins to manage virtual network family in this tenancy, meaning this account. You could even lock it down to a particular compartment, but in this case, it's a little bit more relaxed. It says tenancy. And then, as you see down here, there are users who are launching these compute instances. So what kind of policies do they need? Well, the first policy they need is to manage the instance family, meaning the compute instance family. So you need to give that permission to these administrators, compute administrators. The second policy is allowing these administrators to use the volume family, meaning if they have to attach and detach block volumes, which invariably they would be doing for the compute instance, because that's where the storage is, the remote storage, you need the second policy. And then the third policy is allowing these administrators to use the virtual network family, meaning again, the compute instances depend on the virtual cloud network, because that's where the network interface card is. And remember, this is where all the traffic comes in for the storage and network. So this is the bare minimum set of policies you would write. And again, some of these verbs can be changed. So you might not give manage permission here. You might have two different set of users, admins, as well as actual users. But this is just a quick representation of how you would write these common policies. If you go to our website, you would see a bunch of these policies listed here, common policies. And there is a long list of policies which are available, or examples which are available. And the two we just quickly looked at, you can see here network admins manage a cloud network, and this is the policy we looked at. And then if you look at the other policy, we said let users launch compute instances, and you can see all the policies listed here, and it gives you more detail. The first statement here lets them manage instance images. The second, this statement here lets them attach, detach volumes. If you don't need it, you can delete these policies, and so on and so forth. In this page has a lot of common policies, which you definitely should take a look depending on your specific use case. Examples are provided here, so it can help you get started quickly. Compartments are unique feature within OCI, so let's spend some time learning about them. So as you can see here, when you open an account with OCI, you have this thing which is your account, which is also referred to as tenancy, and it's also sometimes referred to as root compartment, as you can see here. Now within this root compartment, you can go ahead and create more compartments. Like you can see a network compartment here which has network resources, and you see a storage compartment which has some storage resources. So what exactly are these compartments? Well, think about compartments as logical entities where you would keep a collection of related resources. So this is number one, a logical construct. It's a logical concept, as you can see here, the dotted lines. So it's not a physical thing. It's not a physical data center. You can create these compartments, and then you can keep related resources, like you have virtual cloud network or load balancer kept here, storage kept here. And these doesn't have to be service specific. You could have compartments for regions. You could have compartments for your projects, your applications, whichever way you want to organize. The whole idea is to isolate and control access. We will see how that is done. So remember those two things. It's a logical construct. And then second thing is, it's the whole idea to do this is to isolate and control access to resources. Now, the root compartment, as you can see here, nothing prevents us from keeping all cloud resources in the root compartment. But the best practice is to create dedicated compartments Why? Again, the idea is to isolate resources and control access to those resources. So let's look at some of the characteristics. The first thing to keep in mind is each resource belongs to a single compartment. So as you can see here, this virtual machine can go to compartment A, but then at the same time, it cannot go to compartment B. It belongs, every resource, each resource belongs to just a single compartment. How do we control access to the compartment? We talked about this. You have concept of users, which are grouped in these things called groups, and then you write policies against these groups. Basically gives them authorization, and the users plus the groups plus the policies basically gives access to the compartment. So you could say that this particular compartment can be accessed by these two sets of users which belong to this particular group, and this is how you would provide access to specific resources existing within a specific compartment. Now, how does the resources interact? Because look at all the concept we just discussed until now, it looks like everything has to be just in one compartment, right? Because they might have interdependencies. These resources might be interdependent. Like in this case, the virtual machine needs a virtual cloud network. So do they have to go to the same compartment? And the answer is no. The resources in different compartments can interact with each other. And this is fantastic because you could further isolate resources. So your virtual network can be in a completely different compartment, and your virtual machine can be a different compartment, and they can still interact with each other. Now, there is also this concept of moving resources. So as you can see in this picture, resources can be moved from one compartment to another. So you can see here virtual machine existed in compartment A, and now we can move it to compartment B. So that's possible as well. One additional concept to grasp is this idea that the resources from multiple regions can be in the same compartment. So when you create a compartment, it's a logical concept, but it's also global. So what that means is when you create a compartment, let's say in your home region, which might be Phoenix, you feel that the compartment is only in Phoenix, but the same compartment exists in every other region you can subscribe to. And so the next question which would arise is, how do you restrict access? Well, you can restrict access to users based on the region. There is a way to write policies to do that. But the compartment concept is a global concept, and you can spin up resources in multiple regions worldwide, but use the same compartment. As you can see here, this compartment A exists across multiple regions because compartments are a global concept. There is also concept of nested compartments, and compartments can be 6 levels deep. They can have 6 different levels of nesting, and we will see in subsequent lessons when you write your policies, there is implication of where you attach these policies, because when you have compartments like these, you could write policies for the root compartment, or you could write policies for each of these sub compartments, children compartment, and where you attach it defines who can then delete it, modify it, etc. So you could really create some advanced hierarchies in compartment. And the reason we have the concept of nested compartments is because you might have this kind of nested environment where you have a geographical region, and you might have sub-regions, you might have projects, might have sub-projects. So remember that compartments let you do the same thing in a logical way. Now, last thing here is you can set quotas and budgets on compartment. So you're putting all these resources in compartments. So you could set a quota saying that this particular compartment cannot have these kind of virtual machines, these shapes of virtual machine, because they're more expensive or whatnot. You could also set a budget on a compartment saying that this particular compartment, the budget is, let's say, $100,000. And if it exceeds that budget, you get notified. So this is again some way to control your cost and usage. There are options available in OCI to do so, to set quotas and budgets on compartment. Compartments are the primary building blocks for you to organize your cloud resources. You use compartments to organize and isolate your resources. When your tenancy is provisioned, there is something called a root compartment, which is automatically provisioned for you. So if you can see the view here, if I click on this compartment called OCI Arc Associate, it says this is the root compartment of the tenancy. So you don't have to create it. It automatically gets created when your tenancy is provisioned. Now this particular root compartment can hold all your cloud resources, but it's not a good best practice to do that. We saw that in the theory lesson. You should create separate compartments, because the whole idea of compartments are to logically isolate your resources so you can better manage them and you can secure them, etc. Now, a couple of things to keep in mind. Compartments obviously are logical resources. They're not physical. They can span multiple regions, and the relationship between resource and compartment is one-to-one, meaning a single resource can go in a single compartment, but one compartment can hold multiple resources. So one-to-many relation between compartment and resources. When you write policies, you always specify the compartment name, because that's kind of the logical resource where placeholder where the resource lives, and that's true when you call the OCI CLI. You always have to specify the compartment, otherwise we don't know where the resource exists. And compartments can act as a filter, where you can filter out resources depending on the compartment OCID or the name. And there is something called a tenancy explorer, where you can see a list of all the resources which exist within a compartment. So we'll look into all of these, but let's quickly go through some of these here in a little bit more detail. So you can see this is the root compartment, and within the root compartment, I can see the child compartments as 3 compartments here. Remember, all the compartments you create subsequently once your tenancy is provisioned are called the child compartments. So you can see there are 3 here. I could create more. And I can actually create a hierarchy here. And the hierarchy means I can create a child compartment within, let's say, the networking compartment or the sandbox dash compartment. I could create another child compartment, and so on and so forth. I could create hierarchy which can be up to 6 levels deep. Why would you do that? Well, let's say you have an organization, you want to mimic your organizational hierarchy. So you can have like a North America region, you can have a Europe region, Asia region, and within that you can have different business units. So you could create your compartments like that, and quite flexible design. So you could decide whichever way you want to do that. Now let's go ahead quickly and create a compartment here. So first thing I need to do is give it a name. Let's say I'm creating a compartment for compute resources. So I'll specify the name here. I can decide where to create this compartment. So for now, like I said, I could create it as a child compartment within, let's say, networking, or I could create it under the root compartment, which is what I'm going to do here. And I could put some tags here. There's also something called a security zone. And security zone, as you can see here, is a logical group of compartments. When you create and update resources in a security zone, all operations are validated against the policies you define in the security zone. So think about this as a more secure compartment, and you can specify that as you know, when you're creating a compartment, you can specify that it's a security zone, and you write policies accordingly there. So we are not going to touch on that for now. So just let's go ahead and create a compartment here, and you would see within a few seconds that my compute compartment gets created. And if I click here, I can see it has no child compartment. There is nothing, I can add tags here, etc. Now, let me quickly go to, so I can see a list of compartments here. Let me quickly show you how I can see within these compartments to see what kind of resources exist. So if I click on governance and administration here, you would see that under governance, I have a link for tenancy explorer. And what this does, it, as the name specifies, it lets me explore my tenancy and all the compartments I have here. So remember, we talked about compartments can act as filters. I can see the list of compartments on the left hand side. And if I click on sandbox dash compartment, or if I click on compute compartment, which we just created, you can see that there are no resources which are found in this compartment. But if I click on some other compartment, I can see a bunch of resources, buckets, route tables, VCN, etc. If I click on the root compartment, I can see a whole set of resources. And if I scroll here, there are many more resources which exist in this particular compartment here. So if I scroll here, you can see that there are more resources which exist here. So if you again recall, we could put everything in the root compartment. It's not a best practice to do that. It should create separate compartments to logically isolate your resources. So hopefully this was a quick demo on how you can create a compartment and you can view all the resources which exist within a compartment. In the next demo, we are going to look at some of the quota policies, how you can set quotas on compartment, because one of the most important things you need to do as an administrator is to make sure that allocate quotas on your compartment so your users can create resources, but you don't exceed whatever the quotas you set for those compartments. So compartment quotas and budget. Compartment quotas is a mechanism for you to control resource consumption within your individual compartments. Let me just pull up the documentation page because I want to clarify a couple of things here. So one thing which you might have a question on is how are compartment quotas related to service limits? The biggest difference here is that the service limits are set by Oracle and compartment quotas are set by administrators using policies that allow them to allocate resources with a high level of flexibility. So think about this as another mechanism which is given by Oracle for you to control resource consumption. So you can do that on a more granular level. Now, how do we set these compartment quotas? Well, we write a policy, but these policies are a little bit different than the policies you have been using for writing the generic IAM policies you have been using. Now, there are three types of quota policies, which are statements which are available. One is the set. It sets the maximum number of cloud resources that can be used. The next one is unset. It resets the quota back to the default service limits. And there is something called zero, which removes access to a cloud resource for a compartment. It's very handy because let's say you have a bare metal machine, service limits enabled for you, but you don't want your users to create these bare metal machines because these have 52 cores and they're quite expensive. So if you want to prevent that scenario, you could zero out any kind of bare metal provisioning. So your users cannot create any machines which are bare metal. So let me quickly go ahead and create a quota and show this functionality in action. Now, before I do that, let me just bring up limits, quotas, and usage. And if I click on this, and for example, it showing me compute here, you can see that I have various quotas which I can see here. So if I click on my sandbox compartment, you can see that most of these service limits are zero for me. Let me just pull up and see the service limit which is available. So if I scroll further down, I can see here that the cores for standard A1 based virtual machine instances, I have 4 cores which are available. And these are the cores because they have kind of a resource name. So standard -A1 -core -count, and this is 4 for me. And you might say, why is this the case? Because this is a free trial account, and now it's changed to an always free account. And in always free, we give you 4 cores of A1 Ampere processor for an unlimited period of time. So that's why I have 4 cores which are available. Everything else is kind of zeroed out. So let's go ahead and even zero out that particular number of cores for a particular compartment. So I will click on a quota policy here. I'll say this is compute quota policy. And give it a description. And I'll write a quota policy here. And what this is saying is set compute core. So we are going to make it 0. And this quota, and then this is the number of cores we just saw in the previous screen. We want to make that, set that to 0 in this particular compartment. So what this will do now is anyone who has access to this particular compartment will not be able to create any compute instances, but anybody who has access to other compartments would still continue to be able to provision compute instances. So let's create this quota policy. And now if I go to my compute instance and I'm logged in as the same administrator, in a typical situation, this would be set by an administrator, and then a user would come in and would create instances. So if I click on instance here and I bring up my root compartment, so you can see that this is the root compartment. If I click on create instance, I can see here, let me just click on edit, make sure, let me just change my shape, go to Ampere, select this shape, and you can see here always free eligible kind of comes up, right? So select shape, Oracle Linux 8 is fine. I'm basically using this one core machine for the A1 processor, and remember I have 4 cores which are available to me. So I click on create here, and I don't want SSH keys, and everything goes fine. I am able to provision an instance, right? But remember, I'm in the root compartment where there is no quota policy. Now let me bring up to the sandbox compartment where we have created a quota policy. So we do the same thing, give a random name. Let this show up here. Click on edit. And it's already picked up the A1 processor here, the Ampere processor. So I have it here, so that's fine. And I don't need SSH, etc. So let me just go ahead and create an instance. And you would see that now it errors out saying that the following compartment quotas were exceeded, standard A1 core regional count exceeded by 1, because we zeroed it out, and now it's saying that I cannot create an instance in that particular compartment because of that quota policy. So let's quickly go back to the quota policies and just delete that. And I want to show you that it should be, it should revert back to the original state. So I deleted that quota policy. If I go back to my compute screen, click on instances and bring up my sandbox compartment, do the same thing. All right, also already picked up. Let me change from AMD, Ampere, and click create. And now you should be able to create an instance without any problem because my quota policy is deleted. So this is how simple it is to set quotas. I definitely recommend using this because this is a really nice way for you to control the resource consumption. Now let me show you one last thing here before we wrap up this particular demo, and that's how to set up budgets on compartment. Now it's again a nice feature where you can set your budgets on your compartment so you know how much resource consumption is happening, and this is for situations where you want resources to be provisioned in a compartment, but you want some kind of visibility, oversight to see that it's not exceeding a particular budget you have. So you can specify a budget here, and let's say we want to do it for the sandbox compartment. And you can choose a target compartment here. It could be root, or it could be the compartment we just created. Let's say compute, or in this case we are doing for sandbox, a sandbox compartment. Actually, there's a budget which already exists for that. So let's just quickly change it to compute. All right. And then it says how much is, when do we want to start the budget processing, and what is the budget amount. In this case, it's kind of a different currency, but let's say we say it's $100. And now I can set a rule here saying that if I exceed that $100, you should send me an email, send me an alert. And I could do it based on an absolute amount, or I could do it on a percentage of the budget. In this case, I would say when it's reaching 90% of this budget, send me an email. And I could specify my email ID here, and I could create a budget. And it's as simple as that. And when so this starts automatically tracking the resource consumption, and as soon as I hit those thresholds, it would alert me saying that I exceeded that budget. So it's a nice feature, again, something to use, so you have that visibility over your resource consumption. So these are two quick features available for resource consumption, one quota policy, where you can set a quota policy on a compartment with a max limit, or you could make it zero. You could zero out, so resources cannot be created. And then the second feature is budget, using which you can again get an oversight on resource consumption happening within your compartment. It's an important concept to understand while working with OCI compartments, particularly nested compartments. So the principle of inheritance says that compartments inherit any policies from their parent compartment. So when you created an account in the first place, OCI gave you a built-in policy. You didn't have to write this. It comes with a new account, which is for the administrators, and it says allow group administrators to manage all resources in tenancy. So think of this as a super user. You cannot disable this policy. You cannot delete this policy. You can of course have multiple administrators, but this policy is an absolute must. You cannot remove it. Now, because of policy inheritance, the administrators group can also do anything in any of these compartments in the tenancy. So that's what gives them the super user or the super admin capability, and they could create resources, delete resources in any of the compartments in that particular tenancy. So how does this work in a real life situation, right? In this case, you have tenancy here, which is the root compartment, and then you have three levels of compartments which are nested: A, B, and C, just to keep them simple, the naming there. Now, the policies that apply to resources in compartment A also apply to resources in compartment B and C. So if you write a policy, let's say, in this case, policy A, which says that allow group network admins to manage virtual network family in compartment A, what this would mean is the network admins can create virtual cloud networks in compartment A, but they could also create in B and C, because it flows downstream your policies which you write. So the network admins can manage not just in A, but they can also manage B and virtual network family in compartments B and C. So that's as simple as the quick example of policy inheritance, and that's the reason when you create the administrators, they can manage anything because they basically have the manage all resources policy, which gives them the capability to manage any resource in any of the compartments downstream from the root compartment. Now, there's also this concept of attachment. When you create a policy, you have to put it somewhere. Yeah, you attach it. You either attach it to a compartment or you attach it to a tenancy. Now, where you attach it controls who can then modify it or delete it, right? Makes sense. So if you attach it to the root compartment, also referred to as tenancy. Now, if you do that, anyone with access to manage policies in the tenancy can then change or delete it. Anyone who has access only to a child compartment cannot modify or delete that policy because that policy is upstream to that particular user. We have this concept of internal and external, right? So this thing is upstream to the user who is in the child compartment, so they cannot delete or modify it. Now, if you attach it to the child compartment, then anyone who has access to managing the policy in that child compartment can change or delete it. So let's look at an example here really quickly. So same setup as earlier. You have a root compartment, and then we have three levels of nesting here: A, B, and C. And we can write policies at each of the layer here. So if you want to create a policy to allow network admins to manage VCNs in compartment C, do you always have to write this policy in compartment C? And the answer is no. You could write in C like here. It's very simple, right? It's sort of a good practice to keep policies in that particular compartment because it keeps it much cleaner. So you could write a policy here which provides this group the ability to manage virtual network family in compartment C. So you could do that. You could also write the same policy in compartment B, and because of the policy principle of inheritance, if you write here, you can still manage networks in C, right? Because C is directly inherited from B. So you could do that. Now you could also write in A, and the same principle of inheritance applies. But now just look at this small difference where when you write this policy, you have to provide a complete path. So remember this rule that when you write these kind of policies, the path, this particular compartment doesn't know that C exists. because it can only see compartment B, its immediate child. It cannot see sort of two-level children down the line. So you have to provide a complete path. In this case, you provide the complete path by saying something like the compartment name colon child compartment name. And the same logic would apply if you write in the root compartment. You have to provide a full path here. So you have to say A colon B colon C. If you don't do that, if you just write this policy here, it would error out because root compartment can only see compartment A. It doesn't know anything about B and C. So let's quickly take a look at a demo and we can see how this works in real life. Alright, so I'm logged in here as OCI admin and I'll write some policies really quickly. So if I go to my identity and security, first thing is let me show you compartments. So if I click on compartments here, I can see that these are the compartments which exist. So there is the root compartment and then there are children compartment. Now I also created beforehand this sort of a tiered compartment structure. So there is compartment A and then it has a child B and then the child B has a child C. So you can see child compartments here. So I have created this hierarchy just to show you the example we talked about earlier. So if I am in the root compartment and if I go ahead and write a policy, so I'll click policies here, and as you will see here, when I do that, it asks me where do I want to write the policy. So if I am in the root policy, I'm in the root compartment, and I want to create a policy. Let us say this is just test policy attachment, and I would write allow group OCI admin group to manage virtual network family in compartment C. Let's say if I do that, it would say that compartment C specified in the policy statement does not exist under the current compartment hierarchy because it doesn't know that there is something called compartment C which exists. If I say compartment A, it again would create this in compartment A, and you would be able to it will give this policy group access to manage virtual network family in compartment A, and you would not be able to create create virtual networks in compartment C. So the correct way to do this is say A colon B colon C, and when we do that, now it has a complete path here. So this policy works, and now when you do that, you could come here and you could create a virtual network in compartment C, or you could write these policies. If you click here, right, you could do the same thing in compartment A, but when you write a policy here, you will have to provide the full path as well, which is B colon C. If you just say in compartment, right, manage virtual network family in compartment C, it will not let you do that. So this is just a quick example of how the hierarchy works. And as you can see here, when you write a policy, you could decide where to attach it. So if I go back to my root compartment, you can see that all the policies are listed here. If I go to my sandbox compartment, which we have been using for a lot of demos, you can see there is no policy here. But I could write a policy and I could just put it right here. And if in this particular example, this user OCI, because he is the admin user, he has access to managing policies in the whole tenancy. But in reality, his permissions would be limited to this particular compartment. And so this particular user would not be able to delete policies or change policies upstream. So if there are policies written here, this particular user should not be able to see these policies. He would be able to only bring up and see policies written in the compartment they are assigned to. Earlier in one of our lessons, we looked at how you write policies, and this is the syntax you follow. Allow subjects to do something, actions in placement. Placement is basically your compartments or tenancy, and where you can write some advanced policies by putting these conditions where you use a keyword like where condition, and the condition is evaluated to true, false, or not applicable. So we saw this in one of our earlier lessons. Now, why would you use conditions? Condition clause enables more complicated, more advanced, and fine-grained access control. Broadly, a condition evaluates to true, false, or not applicable. So, how do you write these conditional policies? You use variables when adding conditions to a policy. Now, these variables are hierarchically named, prefixed accordingly with either request or target followed by a period, and we'll look at some of the examples. So what is this request and target? Request is used for attributes about the request itself. So for example, you are using a particular user and a particular user ID to make a request, the person who is the human being who is making the request. So you would use a syntax like request dot user dot id. This is the OSID for the user, should contain the OSID of the user who made the request, right? So that you prefix this variable with the request keyword. In case of target, it basically use the target for attributes about the resource target of interest. So an update user request may include target.user.id or target.user.name. So this is the target of which whose name you want to update. So it's as simple as that. Request is for the attribute making the request. Target is for the attribute about the target. It's very sort of intuitive accordingly, right? Now, how do you write these conditions? So we looked at variables. There are single conditions and there are multiple conditions. So how do you write these? So syntax for a single condition is you have variable can be equal to a value or not equal to a value. Not equal to, so equal or not equal either returns true or false. And as you can see here, not equal written like this inverts the result, right? So you could always write equal to something or you could write not equal to something. So that's for single condition. For multiple conditions, you use these two keywords, any and all. What do they mean? Basically, any means a condition set that starts with any is a disjunctive. Basically, the way to think is a logical or. So set of subconditions, any condition within those curly braces that results in true means that the condition is true. So it's a logical or. In case of all, it's a condition set that starts with all is conjunctive, which basically means that it's a logical and. And what that means is every condition within the curly braces must be true for the condition to be true. So remember that all is a logical and any is a logical or. Again, very intuitive, sort of, easy to understand. Now, you can also, the type of values which you use, you could decide. We looked at, variable equal to not equal to value, right? So what kind of values you could use? You could use string values. So for example, as you can see here, you have, somebody's email ID, somebody's OSID. And when you use the string, you always use single quotation marks around the value, right? So you can see here, these are within the single quotation marks. You can also do pattern matching. So you could say, for example, a pattern here matches strings that starts with the word HR, and anything beyond that is wildcard, and so on and so forth. Right? You can have different kind of string matching. So it's rather advanced and lets you write more advanced conditions, the kind of values you could use. So what are some of the examples? Let's look at these really quickly, and I'll show you a quick demo as well. So one of the things which comes up all the time is the concept of compartments as global, and as your users can subscribe to multiple regions worldwide. So the question which comes up all the time is how do you make sure that to limit specific users to specific cloud regions? And you would write a policy like this as shown here, where you would say these admins, Phoenix admins, can manage resources only if the request region is Phoenix. If they go beyond Phoenix, it will result in false this policy evaluation, and they would not be able to manage or create resources outside their designated region, which in this case is Phoenix. Now, you could do even more advanced policies, conditional policies. So for right now here, you could say allow this particular group to manage virtual network family in tenancy where target.compartment.id. So this is my, the target compartment is this particular OSID. So it means that these guys, these network admins within that particular group would be able to manage virtual network family in this particular compartment. So instead of writing policies specific to compartments. You could write you could write a policy like this where you specify the compartment ID in the condition, and so on and so forth. You can again look up online documentation to see all the different kinds of policies you could write. In this particular policy, you are allowing this group autonomous database admins to manage autonomous database where target workload type is defined here, and the target workload type can be OLTP, can be data warehouse, can be autonomous JSON database, or it could be Apex. So you could again write policies like these, advanced policies using conditions. Let me quickly show this in demo, and it'll make more sense. So right now I'm logged in as OCI admin. As you can see, if I go back to my identity security, go to my policies, you can see that all the policies I have written here are based on a particular compartment. That's the compartment I'm using for most of my demos. If I bring up here and look at my OCI admin group policy, you can see here that I'm allowing access for all the resources in the compartment sandbox. And much of these policies basically lets me manage users, groups, policies, compartments, compartment quota, etc. But resources I can only manage in the sandbox compartment. So if I come here and I go to virtual network, and I want to create, let's say, a virtual cloud network in a compartment other than sandbox, you would see that it doesn't let me create a virtual network in this particular compartment. My request is failing. So let's quickly write a conditional policy to change that. So if I come here, click policies, bring up my set of policies which are there, I can write a new policy altogether, or I could just add a policy here. And let me quickly write this policy here. So what it says is allow OCI admin group, same group, to manage virtual network family in tenancy. So in my account, where target compartment ID is the OSID for this one I copied earlier, and I'll show you. So this is my the OSID for the development compartment. So I'll save changes here. And if I go back now, and if you look at the compartment, this is the OSID I picked up. It's really hard to see because it's a long string. If I click development here, and the last letters were ending in E and Q. Well, it's hard to remember that, but if I go back to networking now and bring up virtual cloud network, you can see that root, I'm still not able to create a virtual cloud network because I don't have access. But if I go to my development compartment, I can now create a test. I can create a virtual cloud network. So let's quickly create a test VCN here. We'll say this is test VCN, and rest I'm happy with all the values here, and I'll click create. And you will see that now my network is created because we wrote that conditional policy, and that let us create a virtual cloud network in this compartment where we didn't have access earlier. So network sources is a mechanism to control access based on originating IP addresses. So how do we do it? It's a two-step process. In the first step, you define a set of IP addresses, and these IP addresses could be addresses coming from your virtual cloud network, as you can see here, or these could be public IP address. And you define an object which is called network sources in this case, and the same object can have either specific VCN addresses, or it could have public IP addresses, or both. So you could have a long list of IP addresses defined here, or you could just keep it to a single IP address or a single VCN range. So that's the first step you have to do. The second step is to write a policy, and this policy would specify what a group of users could do based on kind of the policy you defined, and the additional condition comes from the network sources, the IP addresses defined here. So how do we do it? Well, what you do here is you can scope policies by using this variable in a condition, which is request.networksource.name. So this is a reserved keyword. You have to use this. And what you could do by this policy is you can restrict users of a particular group, like here, to access something. In this case, you could have an object family or a virtual network family or any other resource only when their request originate from this particular IP addresses you specified in this particular corpnet. So corpnet is a name which you defined here for IP addresses. So you scope your policies by using this variable in a condition. And once you do that, basically you can control access based on originating IP address. So this is a nice feature available in OCI IAM to help you further restrict what a group of users could do. So here in incognito window, I'm logged in as a tenancy administrator. And in this particular demo, we are using an identity domain called sandbox. So you can see that I have a single policy here for object storage, which states that the group sandbox group in the sandbox identity domain can manage objects. So can create buckets, can upload objects in a particular compartment called sandbox compartment. So again, just to recap, there is a compartment called sandbox compartment. There is a group called sandbox group, and there is an identity domain called sandbox. So anybody who is a member of this particular group in the sandbox identity domain can manage objects. So just to show you, if I click on identity and security, click on domains, we have had this set up in some of the other demos as well. So if I click on sandbox and click on users, you can see there's a user whose name is John Doe. He is part of this particular identity domain called sandbox. And if I click on groups, you can see that the user John Doe is part of this group called sandbox dash group. So it's a very simple setup, single group, single user in this identity domain called sandbox. So we are keeping it separate than the default domain. This is also a free domain. So with this setup, let me switch over my browser and go to John Doe's console here. So you can see here I'm logged in as John Doe. And if I click on, for example, if I click on compute, I can see that I don't have access to create compute instances. Why? Because I have no policies which give me permissions to create compute instances. But if I click on storage and I click on object storage here, you will see that I can create a bucket in sandbox dash compartment. If I just give a random name and click here, you can see the bucket gets created. But if I go a level up to the root compartment, you can see that I have no access here. And just to prove that I don't have access, if I click create here, it gives me an error message saying that we are not authorized to create a bucket here. So let's now, so just to recap, in the sandbox dash compartment, I can still go ahead and create a bucket. So let's change that using network sources. Remember, network sources, the whole idea is you can control access depending on originating IP address. So we will simulate kind of that scenario here. So let me again log in as my tenancy administrator and go to my network sources, and let's create a network source here. It sits outside domain, and let's give it a name. Let's say it's network source for object storage. And now I need to give either a virtual cloud network IP address, a private IP space, or I can give a public IP address. Now let's just give a random IP address 2.2.2.2. So we know for sure that this particular machine where I am logged in doesn't have this particular IP address that we know for sure. So let's just go ahead and create this network source. And now what we would do is we'll go into the policies and we will edit this current policy to add that particular network source. So we will say request dot network source dot name equal to, and I think it's network source. All right. So this has gone through, right? And I can see here that I added this variable here, request.network source name, and now I'm qualifying, I'm making this a conditional statement saying that only allow this particular group and users within this particular group to manage object family if this condition is true, meaning if the originating IP address is 2.2.2.2. If it is not, don't let me create a bucket. So now if I go back and log in as John Doe. And in the same compartment, I just refresh this compartment and pick this compartment. I can see that my access is now changed. And even in this compartment, it says that I am not authorized to perform this request. So if I click here and I click create a bucket, it would give me an error message saying we are not authorized to create a bucket here. So let's quickly again change it. So let's get what's my IP address. Take this IP address here. This is my machine's IP address. Let's log back to my network source and let's add this network, public network. I will give this IP address. I'll update it, and I can delete the old one also. Delete the old one if you don't need it. So now what I have done is I have said that I have changed my network source to my IP address for this particular machine, and now I'm saying let this user create an object storage bucket if the originating IP address is this one. And of course we know that because I'm logged in as John Doe from this particular IP address. So now if I switch back to John Doe's profile, I should be able to create a bucket here. So refresh my browser here and pick up the sandbox compartment, and you can see that I can view the bucket again. And if I click on create bucket here, just give a random name and click create, now you can see that I'm able to create a bucket. So one of the common challenges you would face when you have many compartments is how do you write policies that span multiple compartments or even multiple groups and resources. It's not a best practice to duplicate policies for every single compartment or resource or group. Well, you could do that, but there's an easier way to manage these, and that's basically enabled by tag-based access control. As you can see here, you can write policies with tags that span compartment, groups and resources. So you can scope access based on the tags which are applied to a resource. So how does it work? Well, tag-based access control literally boils down to conditions you define and a set of tag variables you use in these conditions. And we'll look into these in the subsequent slides. Now, access can be controlled based on a tag, as we talked earlier. Either you could do access control on the requesting resource, whether that's a group, a dynamic group, or a compartment, or it could be on the target of the resource, whether it's a resource or a compartment. So let's look at how this really works. And we'll look at some examples. So let's say we are applying the tags on the requester, meaning whosoever is making the request. So in this case, the requester can be a group, users within that group. It could be a dynamic group. So it could be instances, databases, functions within the dynamic group, or it could be a compartment, the resources within that compartment. So for example, instances within that compartment. So the variable we would use would be request.principal.group.tag, and you provide a tag namespace here, and you provide a value for the particular and a tag key definition, and you provide a value here, and so on and so forth. You can read these variables, what they will look like. And on the right hand side, if you see the examples, let me just quickly go through a couple of these examples. The first one is saying allow any user to manage instances in HR compartment where the tag is production. So in this case, any user who belongs to a group, so you're tagging the group here that has been tagged with this particular tag namespace. So operations is the tag namespace and project is the actual tag key. So remember, tags have key and value, and namespace basically means you have more structured tagging. So you encapsulate that key and value within a namespace like a logical entity. So any group that has been tagged with this particular tag, and the users who are in that group can manage instances in HR compartment. You could do the same thing with a dynamic group. So in this case, the dynamic group has been tagged, and all the instances which belong within that dynamic group can actually manage objects in HR compartment. In the third case, the compartment has been tagged, and if the compartment has been tagged with this particular tag, all the instances which are in that compartment which has been tagged with this particular key value pair can manage objects. So you can start seeing that it really lets you write these advanced policies and gives you that extra power to write policies which can span multiple users, resources, and compartments. And it will become clear. We'll look at one of the examples. And the same thing happens if it's a target. The same kind of approach. You could apply tag to a target, whether it's a resource or a compartment, and you would write policies accordingly. So let's quickly look at an example because it will make it much clearer why we use tag-based access control. So in this case, let's look at three compartments: project A, project B, project C. And there are three different admins: A admins, B admins, and C admins. And you can see the policies written here. Basically, these admins are admins for their respective compartments, and they have the ability to manage all resources, right? Pretty straightforward. Now, each of these admins have also been tagged with a tag value which is shown here, the value of admin, and there is a tag namespace which is in this case employee group, and the tag key definition is role. So this is a namespace here, group, and the key value pair is role is admin. So basically these admins might have many users, and these groups have been tagged with this particular key value pair here. Now what happens is, if you want to create another compartment, let's say a test compartment, but you don't want to create another group here specifically for this test compartment because people might be leaving and joining these groups, and so it's a painful thing to manage a separate group here because you have to constantly make sure these groups are not dynamic. So you'll have to make sure to remove and add users as they get added in these admin groups. So the way you would write this policy, and you want, why you create this test compartment is to have these admins share this test compartment for some testing purposes. So the way you would write this policy is you would say allow any group, that's another reserved keyword, like any user, you could do any group, to manage all resources in compartment test where request.principal.group.tag, and this is the namespace and the value, is equal to admin. So what this does now is all these three groups here, it gives access to the members of these groups to this test compartment because they have been tagged with the same key. And any new group tag, if you suppose you create a new group tagged with this particular tag, now we'll have access to this compartment without updating or writing a new policy statements. So that's the power of tag-based access control. You put tags on either the requesting resource or the target of the request, and then you could write policies accordingly, and that policy gives them access. You can scope access based on the tags applied to the resource, groups, or compartments. In this particular demo, we are going to look at how dynamic groups work. So before we get into the demo, let's do a setup here. So as you can see in the setup, we have a single instance, DG_instance1, running in a specific availability domain in a specific OCI region. And what we want to do now is, from within the instance, we want to call OCI object storage and create a bucket. Now remember, this is not a human doing it. It's an application running on the instance calling object storage and creating a bucket. In this case, to make it things easier, we are using OCI CLI. But think about that as an application. You could replace that with an application running on the instance. So how do we make this happen? As you recall from some of the lessons, if you're calling object storage, you need authentication to prove, to say who you say you are, and then also have a policy to give you the authorization, granular permission in order to create buckets. You need those two things, right? So to do those two things, first what we are going to do is we are going to create a dynamic group. And as you recall from the theory lesson, we would create a dynamic group on a compartment. All the instances which are part of that compartment will be included in the dynamic group. And then so that's your authentication. And then we do authorization on that by writing a policy against that dynamic group, giving it permissions to manage object family in a specific compartment, in this case, the sandbox dash compartment. So that's the scenario, that's the setup. Let's get started. Let me switch over to the console. All right, I'm in the console here, and let me just change to my specific compartment. You can see there is a VCN dash DG dynamic group VCN, which is already created. If I just click on it, I can see it has a single public subnet. It has a route table and all. It's just a very simple setup where there's public subnet, which has connectivity to the internet, and we're going to spin up a compute instance within this particular VCN using this VCN. And if I click instance here, I have already done that just to save some time. And you can see DG underscore instance one. If I click here, you can see it's an Oracle Linux developer image which we are using. And then this is spun up in the public subnet, and there is a public IP here. So we can SSH into this instance, and we can try to create an object storage bucket. So let's do that. So to do that, let me just bring up Cloud Shell here. And this is the Cloud Shell using which I don't need to install any SSH tools on my machine. I'm using a Windows machine, and I can just SSH into this particular instance. Now to SSH here, I would just use the ID underscore RSA, the private key file here. And let's just give the public IP. And you can see I'm logged onto this instance now, right? So first thing I'm going to do here is I'm going to show you how you can authenticate using the auth principle. To do that, let's say if I want to get my object storage namespace, if I just do this, you would see that it returns me an error saying that I'm not authenticated because it needs some kind of configuration. To change that, I can just simplify this and say that my authentication for this particular command is using the instance principle. And when I do that, you would see that it will authenticate using the instance principle. And now it's returning me a namespace for the object storage buckets, right? So let's create a bucket here. And this is the CLI command. It's pretty straightforward. We are using the OCI CLI, and let me make it a little bigger here. And we are creating a bucket which is named as sandbox dash bucket. And this is the particular compartment which we are using, which is the sandbox dash compartment. And as we showed earlier, we are using instance principle for the authentication. So if I just hit enter here, you will see that this returns an error because right now I haven't created a dynamic group. I haven't created written any policies. So this command is not going to work. And so we're going to change that, and we're going to come back here and run this command again, right? It says, see, either the bucket exists or you're not authorized to create it. And this is basically the reason you're not authorized. So you cannot run it. So let's minimize it. Go back to my identity and domain section, click on domains here. And we have been using the sandbox domain. So let me bring it up. And actually the sandbox domain, the scope is root. So that's why you didn't see in a particular compartment I was clicking. So click on sandbox here. And if I click on dynamic groups, you can see there is nothing in a dynamic group right now. So let's go ahead and change that. So we'll say this is dynamic group for the demo. Right. And the membership in a dynamic group is a dynamic. So it's based on matching rules. And we have this rule builder, which helps us create, it's a handy tool to create these matching rules. So you can define a rule based very granularly on an instance OSID, or in this case, we are going to do it on a compartment OSID. And the idea here is any instance, all the instances which are part of this compartment will be included in this particular dynamic group. You could do all, you could do any, and you could exclude certain instances. You could write conditional rules here. So it's quite powerful. One thing to keep in mind is just make sure this OSID is the right one, because it doesn't do a validation here. So if you provide wrong values, later on you'll have to troubleshoot and your dynamic group should not work. So I feel good here, click create, and my dynamic group is now created. Now this is the first part, which is the authentication. Now I also need to do authorization for it. So as you recall from the other lessons, policies reside outside the domains. So I click on policies here, and let's go ahead and create a policy for the dynamic group. So we'll call it dynamic group policy. And I want to show you this policy builder. So I'll click on I think object storage might not be here. That doesn't look like. So we'll do network management and I'll change it and I'll show you how it works. So in the policy builder, you can see that it gives me a nice handy kind of representation of domains. I'm going to pick my sandbox domain here, and it also picks groups and dynamic groups for me. So it's picking the dg-demo dynamic group, and then it's picking also a scope, whether I want this to apply to the root or I want it to apply to a particular compartment. In this case, I say sandbox-compartment, and this is the handy kind of, it builds this policy for me, so I don't have to do this myself. Now, one thing to keep in mind here is we are going to create a bucket. So this policy is against the virtual network family. We don't need that. Let's just quickly change that to object family. And that's pretty much quite easy to do. And click save change here. And now what this policy is saying is this dynamic group can manage object family. So it can create buckets, it can upload objects, etc. So let's switch over to my compute instance. So bring up the Cloud Shell from here. And let's run this command again. And if everything has gone well, we should be able to create this particular bucket. Just let's give it a few seconds. And as you can see here, the bucket is created, right? It gives the name here, and it gives me some metadata saying the bucket has been created. And if and you can see that it's a private bucket, etc. So if I go here, if I go to my object storage and click on buckets, let's minimize it and bring it to the sandbox compartment. You can see that sandbox dash bucket is created, and I can upload objects, etc. And it's a private bucket because that's the default behavior. So that was just a quick demo of how you could use dynamic groups. It's pretty straightforward. Again, just to recap, you need to create first you need to create a dynamic group, and a dynamic group you can create from within the domains. In this case, we had the sandbox domain, so we created a dynamic group here. All the instances, we scoped it at the scope of a compartment. So all the instances within that compartment are part of this dynamic groups. And then what we did is we wrote a policy against that particular dynamic group to make sure to give it specific permissions. And just one thing to final reminder here is, as you are doing this, just make sure you put the domain name, you prefix the domain name against the dynamic group name with the dynamic group name, so that it's qualified and your policy work. If you miss this, it goes to the default domain. So it's just a quick demo on how you can call services. In this case, compute is calling object storage, but you could have multiple other services call each other. And dynamic groups, as we saw, works with databases, works with functions, and several other services, right? So it's kind of a very simple demo showing object storage getting called from within the compute instance, but you could do this for other services as well. In this lesson, let us look at what dynamic groups are. Well, before we do that, let's quickly recap some of the key terms. Principal is identity of the caller trying to access, operate on a resource. We looked at it in the authentication lesson. User represents a human in an organization. Instance represents a unique compute VM host in any OCI tenancy. Service, in case of OCI, is an application developed and operated by OCI, like a compute service, networking service, etc., that offers functionality to end customers. And resources are unit or instances of an entity exposed by a service. So resource can be a database, a load balancer, anything you create in OCI or in cloud is a cloud resource. We looked at some of these earlier, but just wanted to quickly recap. Now, principals, there are many different kinds of principals which are there, and there are different patterns. Let's quickly go through them. So there are infrastructure principals, there are stacked principals, and there are ephemeral principals. Let's look at what each of these are. Infrastructure principals, the analogy here is, think about a birth certificate. And the key idea is OCI Identity Access Management Service has a capability that enables instances to be authorized actors. So instances become principal. And when they become principal, they can perform actions on service resources. So instances and applications running on instances can actually call object storage service. And that's an example. In OCI, an example is instance principal. So again, instance principal is nothing but the instance acting as an authorized actor or as a principal to perform certain actions on service resources. So that's the first pattern. The second pattern is a stacked principle. So think about someone has a birth certificate, but now they can get a passport. So they request a passport, they get a passport from an issuing authority. Now the key idea is you're projecting one principle on top of another. So you have a birth certificate, you get a passport. A service controls a resource, not the infrastructure, and that specifies the intention of the resource. It requires the infrastructure to be hosting one resource. Multiple infrastructure might host same resources for redundancy purposes. So you can have many copies of a database, for example, or file storage, for example. So a good example in this case in OCI would be Oracle database, which would be making calls to the object storage service to manage to keep the backups, for example, right? Because the backups are kept in the object storage. So in this case, the database, the service running is an example of a stacked principle. Basically, the infrastructure, your database is running on top of infrastructure, and so you are stacking one principle on top of another, and that controls, that specifies the access. The third kind of principle are ephemeral principles. Now think about analogy here is a building temporary badge which gets issued and it's valid for just one day. So these are temporary credentials which are given for a specific purpose and then they expire. So the key idea is using injected identifiers. A service defines who the holder of a particular credential is for a short period of time. Good example in this case is Oracle functions. When you create these functions, and let's say the function has to call object storage service, it basically gets these credentials for a specific period of time, and then it can make call to the object storage service. So what are these dynamic groups then, right? We looked at the different resource principle patterns. Now dynamic groups allow these infrastructure stacked ephemeral resource principles to be grouped as principal actors, similar to how you would group your users, like your human beings. So you would group these together as in what is called as a dynamic group. And then what you would do is you would write policies on the dynamic group, and these policies would permit the dynamic group principles to make API calls against OCI services. So instance calling object storage, database calling object storage, function calling object storage. That's all example. You write policies which would let specific resources or specific principles make API calls against other OCI services. When the difference here, the reason it's called dynamic is when you create a dynamic group, rather than adding members explicitly to the group, instead define a set of matching rules to define the group members. Why do we do that? Well, for example, a rule could specify that all instances in a particular compartment are members of the dynamic group. When you do that, the members can change dynamically as instances are launched and terminated in that compartment. The membership changes. So it's just a way for us to manage it more effectively. If it was fixed, then you would have to come in and manage every single time you create an instance or delete an instance. You'll have to change that. Because it's a matching rule, the membership is dynamic rather than static, as it happens with humans, which are part of the other groups. So the way it works is, let's look at a couple of quick examples. Is you could say that create a dynamic group where a particular instance, you provide a dynamic group for a particular instance, and you provide the instance OCID here, or you could say that in this particular compartment, all instances which are there with that particular OCID are part of my dynamic group. You could also create a dynamic group where you could specify the resource type. You could say the resource type is DBAS, and the particular compartment is the compartment here. Or you could say the resource type is function, and it's the function available in a particular compartment. So you could write the first dynamic group you're writing on a compartment. The second one you're writing on a particular instance. The third one is a DBAS, a database service. The fourth one is a function. And these two are available in a specific compartment. You could even specify that. The way you would write these policies then, so first thing you would do is you would create this dynamic group, and then you would write a policy. So for example, you would write a policy saying allow dynamic group. See, now the keyword here is dynamic group. It's no more group. And this is the group name. To manage objects in tenancy, where you could specify a condition where bucket name is this and region name is this. But now you're writing this policy on a dynamic group, so it would allow all the members of this dynamic group to manage object storage buckets in this particular region and for a specific bucket name. Similarly, for the database example we saw earlier, you could write a policy which would allow that particular group to manage objects for backup purposes, where the bucket name is this and the region name is this. So this is a way for the resource principals to make calls against other OCI services. Remember, you first write that dynamic group, the membership is dynamic there, and then you write these policies. If you don't write these policies, the dynamic group, the principal actors would not be able to do anything. So you write these policies, gives them the authorization, and then they can make calls to specific OCI services.
Introduction to Virtual Cloud Network, or to VCN. Today, we're seeing an introduction to regions, availability domains, fault domains, and of course, to the VCN. So what is a region? So a region is a localized geographic area that is composed of one or more availability domains. So what's an availability domain? An availability domain is one or more fault-tolerant and isolated data centers that are very close to each other. There's proximity among them, and this allows for high availability, low latency, and high throughput. And now there's a third component, and that third component is the fault domain. So what is a fault domain? A fault domain is a grouping of hardware and infrastructure within an availability domain. And regardless of how many availability domains you have in a region, each availability domain has 3 fault domains. So there's high availability within the availability domain and within the region when you have more than one availability domains. Now let's go ahead and take a look at the virtual cloud network. As you can see, a virtual cloud network is a virtual representation of a physical network, similar to the one that you find on premises. You have addressing for your network. You have subnets. You have routers, firewalls, route tables, and connectivity. The routers, we call them gateways, and each one of them has a different functionality. And we'll take a look at them, but the internet gateway provides access to your resources in a public subnet to the internet. And resources in the open internet can reach your resources on the public subnet, provided that you have the permissions and a route to them. Now, the NAT gateway provides access to the internet to your resources in a private subnet, but not the other way around. Resources in the open internet cannot use the NAT gateway nor any other gateway to access your resources in a private subnet. And now the service gateway allows connectivity to the Oracle Service Network. And we'll take a deeper dive later on. There's another gateway that is not here. It is called the Local Peering Gateway. And that one communicates virtual cloud networks. And then as you can see, we have connectivity to on-premises. This is done through what we call the Dynamic Routing Gateway, which is an isolated component. So the virtual network comes with firewalls, security lists or network security groups, route tables, and communication gateways. And you can also provide it with several IPv4 CIDR blocks. Now let's take a note that the VCN resides in a single region. We already saw what a region is. And now these IPv4 needs to be non-overlapping. And you can choose the CIDR block of your choice. We do recommend RFC 1918, but you can choose any CIDR block that you wish to. And once you create your VCN and assign it a CIDR block or a prefix, you can later on come and modify it. For example, here we have a /16. You can modify this to a /17 if you want. That is permitted. This lesson is actually beyond Oracle Cloud Infrastructure. This one is a networking lesson. A very important one because you need to properly design your virtual cloud networks in order to properly support your resources that you have on OCI. So let's go ahead and start by defining what CIDR is. CIDR stands for Classless Inter-Domain Routing. And routing is the keyword. You might need to communicate your resources outside of the virtual cloud network, maybe to another VCN, maybe to a resource in the open internet, or maybe to a resource on your on-premises network. So let's take a look at how an IP address or CIDR prefix looks. So you can see we have 4 bytes here. This letters represents a byte. And from a previous life experience, you might know that a byte contains 8 bits. And here, because we have 8 bytes, that means that we have 32 bits. And the address is represented by the bytes in this way, a.b.c.d/x. So what is the X? X represents the network prefix. And these are the components. The network address is the a.b.c.d portion, and then the network prefix or the network mask is by /x. And the X are representing the number of bits from the total of 32, the number of bits that are reserved for the network address. So subnetting, and this is what we call this with the /x, allows to divide a network into smaller portions. When you launch a virtual cloud network, typically it's a /16. And when you create subnets within the virtual cloud network, they're typically /24. And I emphasize the word typically because it's not mandatory. You can have a /16, a /17 for the VCN, even a /24, and then have smaller subnets within the virtual cloud network. The larger the number, the raw number of X is, that means that the amount of hosts that you will have on your subnet will be smaller. That's why the VCN is /16 and the subnet is /24 with the typical values that I just mentioned. So 24 is larger than 16 as the raw number, but it's a smaller subnet. Now let's take a look at the CIDR notation. As you can see, I highlighted the a.b.c portion of this address and left the .b out. The reason why is because here we have 24 bits out of the 32. So 8 plus 8 plus 8 is 24. That means that 192.168.1 is the network. And then the .0 will be reserved for the host. Here it indicates that the last 8 bits are the host address. Let's see some examples. Again, 192.168.1 is the network, and the network ID is 192.168.1.0. The first host is going to be 192.168.1.1. The second host is going to be 192.168.1.2. The last host is going to be 192.168.1.254, and the broadcast address is 255. Now in OCI, we reserve the network ID, the first host address, and the broadcast address. So therefore, in this example, you will be able to have hosts going from .2 all the way to 254. This is again for the /24, specifically for a /24. Now let's go ahead and take a deeper look. And this is where it gets really interesting because each byte has 8 bits, as we previously indicated, and each bit in the byte has a position, and that position has a value. So if we go from right to left, the first byte, the value of that position is 1. The second one is 2. The third one is 4. And how do you get 1, 2, 4, 8, 16? Well, it's 2 to the power of 0 is 1. Remember that we're dealing with the binary notation, so we only have 2 digits, 0 and 1. And these are values. So 2 to the power of 0 is 1, 2 to the power of 1 is 2 to the power of 2 is 4, and so on and so forth, all the way to you get to 2 to the power of 7, which is 128. Now, in an address, here, 192 is represented as 1, 1. This is the binary portion. You only have ones and zeros. And 1 means that it's on, or that you can utilize that value. In this case, the position is 128 and it's on. The one to the right is 64 and it's on as well. So we add 128 plus 64 and that comes to 192. Now let's see a whole address. 192.168.1.2. Remember that this is the first host that is valid in the /24, which is this one in OCI. So we already saw how 192 was calculated. Now, how about 168? So it's 128 plus 32, that's 160, plus 8, 168. Now, this one is the easiest one. It's 1. So that means that the first bit going from right to left, 2 to the power of 0, is 1, and it's turned on. So that means that the value is 1. It's here. And then this one is also easy, 2. So the second is the one that is on, 2 to the power of 1 is 2. So that's why we have a 2 here. Now, the subnet mask is utilized to determine where this IP address and what subnet does it belong to. This one is really easy because it's a /24. So we know already that it's going to be 192.168.1. But let's go ahead and do the logical AND operation. This is a Boolean value, and we need to perform this operation to the IP address and the subnet mask. And the subnet mask is because it's a /24. That means that the first 24 bits going from left to right are on, all 24 of them, leaving the ones reserved for the host are as off because they're not part of the subnet. Then when you perform the logical AND operation, that means that 1 and 1 gives you 1. 1 and 1 gives you 1. So these two are on. Now 0 and 1, it gives you 0. And 1, let's see, 1 and 0 also give you 0. And 0 and 0 also give you 0. So in order for you to get a 1, both need to be true. If one of them is false, or if both are false, then that means that you don't get to, with the logical AND operation, result in a 1. So again, this one is really easy. Let's try a more complicated one. How about when we have 27 bits, a /27? So here it means that we are reserving the first 27 bits going from left to right for the subnet mask. And in this case, the network is a /24, and the subnet is going to be the rest of the bits that are being robbed from the last byte going from left to right. So here, remember that the /27 represents the number of bits that we have from the total of 32. In this case, let's go ahead and focus before we do the logical operation, the AND, to better understand this. Again, remember, we have an address and then we have the mask. In this case, the address is 192.168.1.44. What the operation, the logical AND will give us is to see in what subnet this address belongs to. And because we have a /27, here the first subnet is going to go from 192.168.1.0 all the way to 192.168.1.31. So why is this? Why only 31? Because remember, for the host address, we're only working with whatever is left from the subnet mask. So we have a total of 5 bits from the byte to work with the host because these 3 are being robbed. But before we do anything else, let's concentrate on these 3 bits. Only those 3. Remember that these ones are the network. These ones are the hosts. The subnet is the /27. So if we concentrate on these ones, we only have 3 bits to work on. And because we only have these 3 bits, if we turn them to 0, that means that that's the first subnet. And then once we have the first subnet, we start working with the hosts. And the first host is going to be the .1. The second host is going to be the .2. The third host is going to be the .3. That's the fourth host, and so on, all the way to we exhaust this, that we can no longer change this value here because we already exhausted all values. And this is the value comes to 31. So 2 to the power of 0 is 1, 2 to the power 1 is 2. And then if we add 1 plus 2 plus 4 plus 8 plus 16 comes to 31. And this is the 31 that we're talking about. So what happens next? So this one is going to turn into a 1, as you can see there. And then we start all over again. This is the second subnet, and it's a /32. It starts with /32. So it's going to be 192.168.1/32 because we're using these bit as part of the subnet. And there we go, all the way to we exhaust this. And then we move on to the next bit. And we start all over again until we reach the 1.1.1. Now we can go ahead and perform the logical AND and find where the .44 to what subnet it belongs to. Right. Just by looking at it, obviously 44 is greater than 31, so it doesn't belong to the .0. It's got to belong to somewhere else. So that's why we perform this operation. And it belongs to the 192.168.1.32/27. Because when we perform the operation, 1 and 1 gives us 1, 1 and 1 gives us 1, and the rest are false, so that's 0. The same here, it's 168. The same here, we only have 1, so that's 1. However, this is different. Here, we have 1 and 1, and it's in the 32 position, so that means that this host belongs to the 192.168.1.32/27 subnet. I hope this is clear to you. I do encourage you to go beyond this presentation and study CIDR notation because this is a really complex topic and it takes practice to master it. Feel free to hit the Ask the Instructor a question if you have one. We'll gladly address it. Introduction to RFC 1918. This is a very important networking concept that is beyond Oracle Cloud Infrastructure. This is a standard that we recommend utilizing for assigning the IPv4 addresses to your virtual cloud network. Again, these are private IPv4 addresses that we recommend applying to your virtual cloud network and obviously to your subnets. And if you do so, the resources are going to be pulling addresses from this range. So what is RFC 1918? This is a directive from the Internet Assigned Numbers Authority. These reserved addresses are not routable over the open internet. It means that no resource in the open internet will ever have an IP address from this range publicly. And this range are 10.0.0.0/8, 172.16.0.0/12, and 192.168.0.0/16. Now, I want you to pay attention to this /8 and /12. The reason why is because we do recommend using the RFC 1918 from these ranges. However, you cannot use a /8 or a /12 on the virtual cloud network because the specification indicates that the range should be from /16 all the way through /30. So that means that from the RFC recommendation 10.0.0.0/8, you can only utilize those that go from /16 all the way to 30. So this is what we recommend as a 16 will give you all the way to 65,536 IP addresses. However, on a VCN, the most addresses that you can get is 64,000. The RFC 1918 address is assigned to internal hosts inside the private virtual cloud network in the subnet. You can utilize any range that you want, even those that are routable. Remember, this is a recommendation from OCI. You can use any range that you want, even those that are outside of the RFC 1918. However, we do not recommend this because it might create a routing conflict if you use an address that has already been implemented in the internet and you want to reach that resource from that VCN. It will not be possible. It will create a conflict. Resources on a virtual cloud network that is private cannot be reached over the public internet directly. You might have a batching server. You might have a load balancer. You might have a firewall that will allow access to it on special situations that you pre-configured. However, a public IP address is reachable over the internet, while a private one is not directly. Any public routable range can be used. Again, I reemphasize, but however, we recommend sticking with RFC 1918. This is a recommendation. And from the previous lesson, I want to highlight that the first two IP addresses and the last one in each CIDR are reserved. So by OCI, if you have a /24, the .0, the .1, the 255 are going to be reserved. And we do recommend avoiding overlaps. And what we're doing right now is creating a virtual cloud network. And we are doing that manually. So what does manually means? As we log into our tenancy, and here you can see that I'm already logged in. If you click here in the top left hamburger icon menu, you will find networking in the drop-down pick list. And under pick list, these are all the topics of networking, and we eventually will cover all of them. Right now, let's go ahead and click on virtual cloud networks, and then you are going to find that you can create a VCN two ways. So this demo is for create VCN, the button. This one is the manual one. And we call this manual because the VCN that you create comes with no additional resources other than the default route table, which is empty, and the default security list. No subnets and no gateways whatsoever. With the wizard, and we will be creating another VCN shortly, it comes with additional resources. So let's go ahead and create our VCN. It's really easy. Make sure that you are in the right compartment and you are in the region that you want. So let's go ahead and start. And the first thing to do is to give it a name. But before I do that, I want to point here to this field. We highly recommend that you don't have overlapping CIDR blocks. Even if you're not going to connect the two VCNs, do not have overlapping CIDR blocks is our recommendation. So I'm not going to be using that one. And I'm going to be calling this manual VCN. That's the name. Now here you enter the CIDR block. So 10.1.0.0/16, my CIDR block. Make sure that you press enter. Otherwise it will not take the input that you provide. And I'm going to use the default DNS resolution. And we're not dealing with IPv6 at this moment. And that's all you need. You go ahead and click create VCN, and then your VCN is going to be created. And as easy as that. So as you can see, it comes with 0 subnets. It comes with a default route table, but if you open it, no rules in it whatsoever. It does not come with a dynamic routing gateway attachment. It does not come with local peering gateways, NAT gateways, service gateways, nor the internet gateway. It comes with nothing. You have to create everything from scratch. And we are going to be doing that later on. So this was the demo. I hope that it was of value to you, and I'm looking forward to seeing you in the next demo, which is creating the virtual cloud network through the wizard. This time, we're creating a virtual cloud network utilizing the VCN wizard. And as we saw from the previous lesson, in order to find your VCNs, you log into your tenancy, and in the top left, you have what we call the hamburger icon menu. You click on it and you scroll down all the way to networking, and then you will find your virtual cloud networks to the right. And as you can see, here's the VCN that we previously created in the previous demo, the one that already existed. And as you can see, they don't have overlapping IPv4 CIDR blocks. And that's a good thing. That's what Oracle Cloud Infrastructure recommends. And in order for you to create a VCN with the wizard, you click the VCN wizard button. And then it will offer you two options. One of it is creating a VCN with internet connectivity, and the other one is site-to-site VPN. And we'll see this later on. Now, when you create a VCN with the wizard, it comes with additional resources, as we previously explained. And these resources are a public subnet, a private subnet, and three gateways: the internet gateway, the NAT gateway, and the services gateway. The internet gateway will provide you with connectivity to the internet and from the internet. The NAT gateway provides connectivity to the internet. And the service gateway provides connectivity to the Oracle Services Network. Let's go ahead and create our VCN. It's also really simple. You give it a name, and this one is going to be called Wizard VCN. We make sure that we are in the right compartment, and then we have three fields for CIDR blocks. Remember that we're creating two subnets, so you have to specify the CIDR block as well for the subnets and for the VCN. And obviously, the subnets needs to be part of the VCN block. And because this block is already taken, we are going to be changing this to a .2. And that's all we need right now. With the wizard, it does not provide you with IPv6 connectivity options. You can add that later on manually. And then the next button will basically confirm your options. And if there's something that you don't agree with or that you mistakenly type it, you can go back and change that. For example, here we can change the CIDR block or give it a different name, but we don't want that. We are perfectly fine with the options that we selected. And you can scroll down, see the route table rules, see the security list rules, but you can only see them. You cannot edit them. And then you can go ahead and create. And just like that, the process of creating your virtual cloud network begins. And it takes like about 30 seconds to 45 seconds to create. And once the VCN is created successfully, you click on this button so you can view all the details. And that's what we're doing right now. You can see the CIDR block prefix that you selected. And if you want, you can add more here. Now the route table, we have two. We have the default one. And as you can see, this one is populated. Let's go ahead and see the route. And you will see that the quad 0, this is the destination to the open internet. And the target is the internet gateway. Now let's go ahead and check the other route table. We created one specifically for the private subnet. And you can see it comes with two rules. Remember that we have two additional gateways on top of the internet gateway. One will provide access to the NAT gateway. Now, why will this conflict with the other route table? We're using a quad 0. No, it won't, because the other route table is applied to the public subnet, as we will see shortly. And this one is applied to the private subnets. Now, this rule looks a little bit different, and we'll explain what this is when we get to the services gateway. Now, let's go ahead and take a look at the security list. The security list looks exactly as the one that we get when we create the VCN manually. And here it comes with 3 default rules. It always comes with this set of rules. This will enable access to any compute instance that you create through port 22. And then we mentioned that these ICMP rules are not for pinging. These are for troubleshooting. Let's go ahead and take a look at the security list that we created, or that it was created when we create our manual VCN. It's exactly the same set of rules. Port 22 and our 2 ICMP set of rules. Now, the other thing that I want to highlight from the Wizard VCN are the subnets that we created, or that the VCN Wizard created. So we have one that is the public subnet. And if we open it, you will see that the security list is the default security list that is applied to it. Now, if we see the other security lists, or if we see the other subnet, we will see that it's using the security list for private subnets. And it's also the same set of rules, but the difference here is that this is not the quad 0. This is being very specific and allowing access only or from within the VCN, not the subnet. And finally, what I want to highlight here are the additional gateways. It did create a NAT gateway for connectivity to the internet, initiating from within your virtual cloud network and specifically from your private subnet, and another one for your service gateway. And that's basically what I wanted to cover in this demo. Introduction to subnets. Today, we're taking a deep dive into subnets. We already seen a little bit of subnets when we saw introductions to VCN. Right now, we're taking a deep dive into subnets. We'll see an overview of them, and we will see the types of subnets that we have. As you recall from the introduction to OCI or to networking, we have regions and availability domains. And inside them, you can build your virtual cloud network. And the VCN in regions where you have 3 availability domains, it spans all 3 of them. That's the way a VCN is designed. If you were to have 4 or 5 availability domains, it will span all of them. A subnet, on the other hand, we have 2 configurations for them. Either they can be availability domain specific, or they can be a regional subnet. Now, an availability domain specific subnet will have all of these resources in it inside that availability domain that the subnet belongs to. For example, here in availability domain 3, we have a subnet, subnet C. If we were to build a load balancer or a virtual machine or a bare metal instance in it, it will forcibly reside in availability domain 3 because this is an availability domain specific subnet. Here we have subnet D. And as you can see, it's a region-wide or regional subnet. It spans, like the VCN, all 3 availability domains. So if you were to create a compute instance in subnet D, you get to decide in what availability domain that instance is going to be. If you create a load balancer and place it in availability domain 2, you can do that. Or a compute node in availability domain 1, you can also do that. So if availability domain was to go down, all the resources in subnet C are going to go down with it. However, subnet D, only those resources that are in availability domain 3, like the compute instance, is going to go down. But the load balancer and the compute node for the database, they will remain because these 2 were not affected by this availability domain going down. So that's the category of our subnets. Again, the VCN is divided into subnets. This means that you cannot have a resource in a VCN itself you definitely need a subnet if you want to build a compute instance on BCN. It cannot be on the BCN itself. Now, each subnet has a continuous range of IPv4 CIDR. In this case, subnets cannot have overlapping CIDRs. For example, subnet A is 10.0.1.0. That means that if you first create subnet A, subnet B will never ever have the availability of having this CIDR range as long as subnet A has it. They cannot overlap. If you try to configure 10.0.1.0/24 for subnet B, you're going to get an error message. They cannot overlap. Now, a subnet can grow or shrink after creation. Let's say that you change your mind, and here in subnet D, you don't want it to be a /24. Now you want it to be a /25. That means that you're making it smaller. And you can go ahead and do that. You have to be very careful when you're doing that and make sure that it's not going to overlap with something that you already created. Now, each subnet, as we previously explained, can be contained in a single availability domain, or it can be regional like the virtual cloud network. This is very important because we have regions where we only have one availability domain. If you create a regional subnet rather than an availability specific subnet, if we add a second availability domain and or a third availability domain to that region, your subnet is already configured to span all of the availability domains. Any resource that you place in a subnet will get its IP address from that subnet, the private IP address from that subnet. Now, the VNIC will determine how you route. Any resource that you have here in this virtual cloud network will be able to communicate with a resource, even if it's another subnet. You don't need any routing for it because that's the way the VCN is designed. However, you do need to establish permissions on either the security list or the network security groups. Now, these are the categories for the subnets. We also have types. You can have a private subnet or you can have a public subnet. Now, the difference is that a private subnet, all the resources that you have in that private subnet will only have private IPs. They will not be able to have public IP addresses. On the public subnet, however, you have the option. They will not necessarily have a public IP address unless you specify it. So you can go ahead and create a resource that will never have a public IP address. And you can create another resource. That resource will be having a public IP address. So you have the option. In a private, you don't. Not only are we creating a public subnet, but we're also creating an internet gateway because they go hand in hand. In order to enjoy the resources that you have on a public subnet, you need to have a path to them, and that's through the internet gateway. If you recall from the manually created BCN, it does not come with any resources. If we go back into our virtual cloud networks and we click on our manual BCN, you will see that it does not have any subnet, no internet gateway. The route table is empty. So let's go ahead and fix that. We are going to be creating a public subnet, an internet gateway. We're going to be adding that internet gateway to the route table. So let's go ahead and do that. It's really easy. You click on subnets, click the create subnet button, give it a name. Here, I'm going to call this manual subnet. The compartment, you can change the compartment if you want to do that. We are going to leave it in the same compartment as the VCN is. Now, if you recall from the actual lesson on the public subnet, we have two types, regional subnet and availability domain specific subnet. This will take advantage of all three availability domains within this region. And this one will use the one that we create. Here we get to select what availability domain we want. We're going to go with regional. Now the IPv4 CIDR block, you need to make sure that it belongs to the same CIDR block, or that is a subset of the CIDR block that you selected for your virtual cloud network. In this case, it's not. If you recall, and here it is, you can see it. It's grayed out, but you can still see it, 10.1.0.0/16. The example does not correspond. So if I use this, it's going to give me an error message. So it needs to be within, and it makes sense, correct? Now, we are not dealing with IPv6 in this lesson. And now regarding the security list, we only have the default security list. So if we leave this empty, and this is what we're doing, is going to select by default the default security list. So it's as easy as that. You create your subnet. Now, if I was to create a resource in this subnet, like a compute instance or a load balancer, I will not have access to it because I don't have an internet gateway. So while this is being created, and it's already completed, but let's go ahead and create an internet gateway. It's also really easy. You just give it a name, and I'm going to call this manual IG for internet gateway, and leave it in the same compartment as the virtual cloud network is. And as easy as that. But we're still not done. We need to add this internet gateway to the route table. So let's go ahead and do that. We don't need to create another one. We're going to be using the default route table. And let's go ahead and add a route rule to it. And now it's going to ask me to select what's my target type. In this case, we do want an internet gateway. And by the way, we don't have any one of these right now. Those are future lessons or future demos. Now I'm going to enter the quad 0 for everywhere, so I can access it from my workstation at my office. And then you get to select your only internet gateway that you have. And optional description goes here. And that's all you need. So now I should be able to SSH into any compute instance that I add into this subnet. So we don't have a compute instance. The ones that we previously created are in another virtual cloud network. And I'm actually going to rename these ones to Wizard VMs. And the new one that I'm creating is going to be Manual VM1. As you can see, I created 2 additional virtual machines. And the reason why I created 2 instead of 1, like I said I would, is I want to highlight one of the features of the subnets. And remember that our type was a regional subnet, and therefore you can see that here the availability domain for Manual VM1 is availability domain 3. And the Manual VM2, which is still in the same subnet, as you can see right here in the third octet, we only have one subnet in that virtual cloud network. It's an availability domain 2. So they're in different availability domains. That means that they're in completely different data centers, and they're independent from each other in terms of resources, but they still belong to the same subnet, these 2 virtual machines. And as you can see, I renamed these ones so it's clear that these ones belong to the manually created virtual cloud network. And you can see that in this octet right here that is different from the Wizard one. So let's go ahead and take a look. Here you can see that it does belong to the manual BCN and that we created all of those resources, the subnet, internet gateway, and our route rule in the route table. So now I should be able to copy this address right here and SSH into it. So let me see, because only one has a key. So make sure that I'm in VM1, and I am. So I'm going to up arrow here, and I'm going to change the IP address to the one that we just copied. Paste it, and I should be able to SSH. And yes, this is the first time I'm logging in. So there it is. I'm in Manual VM1 through the internet gateway that we just created. So let's go ahead and remove that internet gateway. First, I'm going to exit out of here. So I'm out, and now I'm going to go into my virtual cloud network and remove the internet gateway. I actually cannot delete the internet gateway because it is part of a rule. So I need to remove it from the rule itself. Otherwise, I'm going to get this error. So I'm going to remove it from this route table. And I can click here on it and remove. And I'll say, yes, I confirm. So now we don't have the internet gateway, so we don't have access into that virtual machine. And this should time out. And it's doing that as well as timing out of an Oracle Cloud Infrastructure Service. The objective is to create a private subnet, but we additionally are going to be testing a feature of the security list in that subnet. So let's go ahead and log in into our tenancy. And we are going to be going to networking, virtual cloud networks. We already know how to get there. So let's go ahead and do that. In our previous demo, we created a public subnet. Now we are creating a private one, and we are going to be doing this one differently. As you recall, this is a regional subnet. Our private subnet is going to be availability domain specific. So it's really easy to create. You give it a name. So I'm going to call this private. Manual subnet. And I mentioned that it's going to be availability domain specific. And here I need to specify an availability domain because my virtual machines on my public subnet are in availability domain 2 and availability domain 3. I'm going to force this one to go to availability domain 1. And again, the CIDR block needs to be in the same range as that of the virtual cloud network. So remember that we fix it here by entering 1. Oh, why is it not working now? Because this octet is already taken, the .0, this third one. So we're going to change this into a .1, and this will fix the problem. There we go. And that's all we need, except that here we need to indicate that it's going to be in the private space. Now, it's as easy as that. We created our public subnet. Now, I did mention that we are going to be modifying the security list. Why is that? That is because if I log into the computer instance that I have for my manual subnet, in order to prove that the resources in my private subnet are reachable, I should be able to ping to them. Remember that there's no need for a route when you are within when your resources are within the same virtual cloud network. We removed the internet gateway in the last lesson. Add that internet gateway back, and I'm going to create a compute instance in the private subnet. As you can see, I have not created the virtual machines yet. I did add the internet gateway to the route table on the public subnet. However, the reason why I have not created the manual VM yet is because I want to show you something. When you click on create instance here and you give it a name, I'm going to call this private manual VM. Long name. Now here it's asking me, where is it that I want to place this virtual machine? Remember that I created my private subnet in availability domain 1. So what happens here if I select availability domain 3? Should not be possible, correct? So let's go ahead and test this. So when you're specifying the network, you need to manually select the virtual network that you want. And here's the manual VCN. And then it's going to ask me, so what subnet do I want? And see, it's not giving me the private subnet because it's not in availability domain 3. Our subnet is here. So if I change this to availability domain 1 and then scroll down and click on the subnet, now it's going to allow me. So this is what I wanted to show you. And now, because I'm selecting this private manual subnet, if I select the public one, this is not grayed out. Here I have the option of selecting a public IP or not. Do not assign. Even though I am in a public subnet, assigning a public IP to the instance is optional. It doesn't become optional. It does not become optional when I do have a private subnet. As you see, the radius change from this circle to this one. And here I'm not going to be adding an SSH key because I'm not going to be accessing it. So I can go ahead and create this instance. And yes, create anyway. I don't need the SSH access to it. So now if I go into my instances, you will notice the difference right away. No public IP because I did not assign one. Now the second octet indicates that I'm in my manual virtual cloud network. And the third octet is different from the one below. It means that I'm in my private subnet. So now if I SSH into this compute instance, the public one, and if I try to ping this address, remember that I mentioned that ICMP is not enabled by default. So let's go ahead and test this. So I'm going to SSH and the address remains the same. No, I'm going to be using this one. I don't have a key to this one. I should actually delete this one. I already proven the point. So let me up arrow and I should be accessing and here I am. So now if I ping the IP address of the private IP 10.1.1.87 is not going to work because ICMP is not enabled. And I'm actually going to leave this running and I'm going to go and enable ICMP. So let's go ahead and do that. You go into, and you can do it two ways. You can do that on the network security group or on the security list. So this time we're doing it on the security list. So I'm going to go into my virtual cloud networks and click on my manual VCN, go into the security list right here, default security list, and we need to add a rule for echo. And here I can do the quad 0 as we normally do. But now I'm going to do something different because you might recall from our lesson on RFC 1918 and our lessons on CIDRs, the BCN allows only from /16 to /30 for the BCN CIDR itself. However, for the source, it can be anything that you want, including 10.0.0.0/8. So here the /8 is actually permitted. In this way, I will ensure that any virtual cloud network that I possibly peer in the future against this BCN, if it's in this range, is going to be able to connect. And then I select the protocol, ICMP, and I can either select all types or type 8, which is echo, as you can see right here. And I can type in the description for echo and add the ingress room. And the minute that I add it, ping should start to work. And there it is. It's working. Security lists. This is a very important topic because it defines what permissions you enable on your virtual cloud network or on your subnet. So the focus of this lecture is the security list for your virtual cloud network. So let's go ahead and start by defining what a security list is. It's basically a set of firewall rules associated with a subnet. I mentioned virtual cloud network and subnet. So the virtual cloud network comes with a default security list that you can either use on your subnets or you can create security lists specifically for your subnet and bypass the default security list that the VCN has. Basically, these rules are associated with a subnet, and any resource that you have in that subnet is going to be affected by the security list associated with the subnet. That resource can be a bare metal machine, can be a virtual machine, can be a load balancer, can be any endpoint that you might have on that subnet. And when you're creating your security list, you can define the rules that are in that security list to be either stateful or stateless. And we will be defining this shortly. But first, let's go ahead and pay attention to these three subnets inside the VCN. As you can see, all three of them, they have the same security list. And they're allowing port 80 as an ingress rule. But you can see it's stateful. And we'll define shortly what stateful means. But when I say anybody, is we have here the decider that is quad 0, and that means anybody that has access into this virtual plant network, into the subnets, will have access to port 80. So if you have a web server on subnet A or a web server per subnet, anybody will have access into that web server, in and out, because it's stateful. And again, we'll define that shortly. Now, the other rule, the second rule, port 1521 is the Oracle database port. And we are being very restrictive. We're only allowing an egress going to any node that belongs to subnet B, and only subnet B. So somebody requests access to that database from subnet A is not going to be allowed, because we don't have a rule that is allowing this to go out. The same for subnet C. So nodes here on subnet B, nodes here on subnet A, and nodes here on subnet C, they can attempt to get access, but only those that are from subnet B are going to be permitted into it. And the reason why I'm emphasizing that is because, and we'll see this in routing, when you are inside a subnet, when you are inside a virtual plant network, any node has access from the routing perspective to any other resource in the same VCN. However, the port permission validates that access. In this case, only nodes in subnet B have access into port 1521. And we don't know where the database is. We're not indicating that, but only, again, re-emphasizing, nodes on subnet B have access to port 1521. So again, this is open. This is very restrictive. Moving on, the security list is applied at the VNIC level. Any compute instance, any database compute node, every resource has a VNIC, and the security list is applied at the VNIC level from the subnet. So basically, the VNIC is the one attaching to the subnet. That's what that means. And the rules are for ingress or egress, coming in or out of the subnet. Now, when you create a subnet, you need to specify what security lists will be affecting that subnet. It can either be the default VCN security list or one that you previously created. If you later on decide that subnet will have a different security list, you can remove the one that was attached to it at the subnet creation and modify it with a brand new one. Actually, every subnet can have up to 5 security lists, and you have to be very careful when designing your security lists and associating them to the subnet. When you launch a virtual cloud network, it comes with a default security list, and that default security list has 3 rules in it. By default, comes with SSH enabled for quad 0. That means anybody can access port 22 SSH. And then it comes with 2 ICMP rules. By the way, those ICMP rules are for troubleshooting. They're not echo. They're not for pinging. If you want to enable pinging on your security list, you have to manually go in and add it. By default, everything else is closed. Nothing is allowed. So in this case, if you want to enable port 80, you have to manually add port 80. If you want to enable port 443, you have to come in and manually add it. If you want to enable IPv6 traffic, you have to manually come and add it. Any other service that you want to enable, you have to manually add it. Otherwise, it's declined. Now, this applies to the security list, regardless of who's talking to that instance. Here, it's outside of the VCN. This one is inside of the VCN. Now, we mentioned stateful. So what stateful means? It means that if you have a service that you want to enable, by defining it as a stateful, it means that you are only configuring one of the directions, either coming in or coming out. So if you allow permission into port 80, then you don't need to define out of port 80. Where is it going to? The same for any other service. So any incoming or ingress rule automatically have the permission enabled for the egress rule or outgoing rule. That's with a stateful. Now, there's some situations where you might need to have a stateless security rule. Here, we're only defining the ingress. If you want to have that securityless rule be stateless, then you have to create two rules. One that is incoming and another one that is outgoing, or ingress and egress. That's the basic difference. Basically here, you have to create this rule and you have to create that other rule going out. If you recall from the previous image, this one was started because it was automatically enabled when you created the stateful. This one is stateless, therefore you have to define both of them. Now, there's some situations with some protocols like ICMP that require an egress rule regardless of the state option. And that's why when you create a virtual cloud network, it comes with all protocols allowed on the egress. Otherwise, ICMP will not work. Now, if you want to enable IPv6, then you have to have a specific port for it. For example, here, ICMP is enabled for quad 0, but this is IPv4 notation. If you enabled on the subnet IPv6, then you have to enable the source in IPv6 notation and specify that the protocol is specific for IPv6. So you have to pay attention for that. Network security groups. This topic is very much in line with the previous one on security list. There's some similarities and there's some fundamental differences. And we are taking a deep dive into network security groups. That's our objective today. And we'll start by defining what a network security group is. Basically, it provides a virtual firewall for a set of cloud resources that all have the same security posture. And this sounds very alike to the definition of a security list. However, these rules apply only to a set of VNICs of your choice in a single VCN. So this is a key difference. Only to a set of VNICs, not all of them like they do with a security list. You get to choose what VNICs are going to be affected by the rules in a network security group. And these resources that can leverage a network security groups are any compute instance, a load balancer, the compute node of a database system, or an endpoint of an autonomous database, or the mount target for a file system. And as a matter of fact, Oracle recommends leveraging network security groups over security lists. And why is this? This is because it provides you with a fine-grained detail of your security permissions. Let's go ahead and take a look at an example. Here, we have two subnets. Now, before we talk about this example, I want you to remember the example that we use on the security list. We had 3 subnets and all of them being affected by the rules in a security list, all 3 of them. Now, imagine if we had 50 nodes on each one of those subnets. All 150 of them will have port 80 enabled on them because port 80 was enabled on the security list. And all 3 subnets, therefore, 150 resources were affected by it. And typically, you don't have 150 web servers. So there's no need to enable port 80 on all the resources if you only have a couple of web servers. In this case, we have 2 subnets. And in subnet A, we are using a web server, as you can see here with network security group A. And in subnet B, we have another web server, network security group A. And port 80 is enabled on them. That's why I'm calling them web servers. The other server that we have, or the other compute instance that we have on subnet A, is not affected by network security group A. It's only leveraging network security group B, and it has port 22 open. So the best definition that I can give to a network security group is that it allows you to create an exception to a security list, like the one that I just described. You don't need to enable port 80, all the resources in the subnet. So therefore, let's say that you have these 3 subnets with the security list, you don't enable port 80 in the security list. You enable it on the network security group, and you apply it only to the actual web servers. Now, the fact that Oracle recommends a network security group over a security list, it doesn't mean that the security list is obsolete. You can actually combine them, or you can use the security list as a standalone security measure, or you can use the network security group as a standalone security measure. But wait a minute. Didn't you say that when you create a subnet, you need to add it to a security list? And yes, I did say that. That's a requirement of the virtual cloud network construct and of the subnet construct. You need to attach the subnet to a security list, but that security list can be empty. And this is how you can work with a network security group alone. You apply the network security group to the individual resources. So therefore, to enforce the security rule for all VNICs in a VCN, put the rules in a security list and then associate the security list with all the subnets that you need. Remember that any given subnet, you can have up to 5 security lists. In this case, in this example, we have 2, and they're being associated with this subnet, and therefore the compute instance in this subnet is affected by these 2 security lists. And in addition to that, you can attach a network security group. In this case, it has 2 of them. So any rule, security list 1, any rule on security list 2, any rule on these 2 network security groups will apply to the VNIC at the same time. And there is no contradiction. I do get a lot of questions, rules contradicting if they're in the network security group and the opposite in the security list. That doesn't exist. In Oracle Cloud Infrastructure, everything's denied by default. You have to enable it. So if you enable port 80 on the security list and also enable it on the network security group A, it's still the security, only one of it will apply. There will be no contradiction. If you remove the permission of port 80 from one of them, it will use the other one. And only those rules that are in those, either the security list or the network security group, will apply to the compute instance concurrently. And actually, you can even play around with these rules. And I'll explain in the upcoming slides. And this is exactly what I explained. If you choose to use both, then both rules apply. So a packet in questions is allowed and only if the rule is in either one of these security measures. Now, there's a key difference. When you create a security list, you have to specify the source and the destination as a CIDR block. With network security group, you can have another network security group be a source or a destination. And this might be a little bit more complicated to manage, but it provides you a finer control of the permissions that you enabled on your resources. So the ability to have a network security group as a source or destination, in order to leverage that, both network security groups need to be on the same virtual cloud network. Now, the stateful security rule for a network security group is exactly the same as in the security list. This is one of the similar aspects between a network security group and a security list. If you have an ingress rule with a stateful status, when you create a permission for ingress, for example, you don't need to create or configure the egress matching rule for it. By default, by design, and stateful rule will allow, in this case, port 80, if you define it as an ingress rule, then the egress rule will be permitted. The stateless security rule also behaves exactly as the security list. When you create the rule for the network security group, the ingress rule, you also have to create the egress matching rule for it. Now, I was mentioning that you can play around with these rules, and I have done this myself. You can go ahead and create a stateless rule in a security list, and then have the matching stateless in a network security group. You can do that, and it will work. Oracle Cloud Infrastructure, the network security group. Not only are we creating one, but we're also using it. And by using it, we are going to be comparing it to a security list. In between demos, I created 2 compute instances. Let me show you these compute instances. I named them BM1 and BM2. And from this address that we're seeing right here, this is the private address. You can figure it out that the second byte from left to right indicates that we are in the wizard BCN that we previously created. Now, the third byte or octet indicates that it's in the public subnet. Let's go ahead and take a look. If that is the case, here's our wizard. And as you can see, this indicates that, in fact, it is the wizard BCN. And if we open it, remember that it comes with 2 subnets, one of them public and the other one private. So the public one is this one right here. The third octet from left to right is 0. And I want to highlight the security list. Here, the default security list is the one that is applicable to the public subnet. And if we open it, you will see that by default, port 22 is enabled in every single security list that is created by default with the BCN, with the wizard, and with the manual creation of a virtual cloud network. Port 22 is always enabled. And we are going to be logging into these compute instances through SSH because that's enabled. And these are the addresses. And I'm going to be logging in from my workstation at my office. So as you can see, this is the public IP address. Remember that it's in a public subnet, so I do have access through the internet gateway to these instances. And we'll see the route table again shortly. But let's go ahead and SSH into these instances. Right now, we are going to be logging in to BM2. Actually, let's go and log into BM1. This is the address. And the access is successful. If I exit out of here, and then I try logging into the second VM, it should also be successful because they are in the same subnet, and therefore the security list applies to the VNIC of these 2 compute instances. Now, if I go back into the virtual cloud networks, and first I want to show you the route table. It's giving me access to the internet gateway from quad 0. That means from anywhere. And I am in the open internet. My workstation is at my office. So I'm logging into Oracle Cloud Infrastructure through this internet gateway. Now, if I go back to the wizard, and let me make sure that I'm out from here, I'm going to exit. And I'm going to clear this. And what I want to do now is go back into the security list and remove port 22. Here, we're going to remove this, and it's gone. No longer I have access, and you can remove it. The fact that the BCN creates this port by default, it doesn't mean that you have to use it. You can always come in and remove it. So because it's gone, I should not be able to log in into any one of these instances. This one should fail. It's going to take like 45 seconds to time out, and access to it is not going to be possible. Let's go ahead and check these compute instances so we can see the address of them. This is BM2, and it's still trying to connect. And there it is. It failed. It timed out. The same thing will happen to the other compute instance. It's going to time out. So what I want to do now is create a network security group that is going to grant me access into one of the virtual machines, but not into the other one. So because I'm trying to access to BM1 right now, this is the one that we are going to create a network security group. And here you can find out that I'm in this public subnet and that I am in this virtual cloud network. So if you open the virtual cloud network, you will see that the network security group link is contains 0. network security groups. One of the differences between a security list and a network security group is that network security groups are not created by default when you create a virtual cloud network. So you have to come in and manually create it. So we are going to do that. And it's really easy. Click on the Create Network Security Group, give it a name, and I'm going to call this Network Security Group, actually, Wizard. Wizard because I want to highlight that it belongs to that virtual cloud network. And then you enter the rules. And this is going to be stateful. That means that I don't have to create both an ingress and an egress, only the ingress one. In this case, my source is going to be a CIDR, and it's going to be from anywhere. That's what quad 0 means, from anywhere. And I want to be very specific to the SSH protocol, port 22, from anywhere. And then this is optional, network security group 1, whatever description you want to add to it. And that's all you need. You create the network security group, but it doesn't stop there. You need to go here and add this network security group to the VNIC of the compute instance. So this is what we are going to be doing right now. You go into the instances, and I'm going to add this to my virtual machine 1. So the VNIC, in order to find the VNIC, you scroll all the way down, and here you will see the attached VNICs. And we have one, the one that was created by default when you create the compute instance. You click on it, and then you edit the network security groups field here, says none, and then you select one. And we only have one, the one that we just created, the Wizard Network Security Group, and then you save the change. Now, this will grant me access into my virtual machine 1. If I up arrow, here it is, and there it is, through the network security group. However, because we only added it to virtual machine 1, virtual machine 2 should fail. This is .13, and this one will still time out. So that's the key difference, and that's how easy it is to deal with network security groups. I encourage you to further investigate on it and play around and try to reproduce this demo if you can. This lesson is about the Bastion service from OCI. So Bastion as a service. You might recall that when you create a virtual cloud network with the Wizard tool, it comes with a NAT gateway. And the NAT gateway, what it does, it allows the resources inside a virtual cloud network in a private subnet to connect to the internet via the NAT gateway. But what if you want to connect resources from the open internet that resides in a private subnet, maybe for managing it, performing some tasks that you need to do? Private means that it's in a secure environment. And there are several ways of accessing those resources. One of them being a Bastion server of your own that you create on a compute instance, and it serves like a jump box from a public subnet into resources in your private subnet. Normally, that's one way of doing it. It's not the most optimal way. You need to create a compute instance, and it always presents danger of being accessed from a remote entity, an external entity. Another way is through Oracle's Bastion service, not your Bastion server, but a Bastion service as a service from Oracle. So let's go ahead and take a look to see specifically what the OCI Bastion is. It is a service that provides ephemeral access into your resources. By ephemeral means that it doesn't sit available all the time. It has a limited amount of period. So customers can access targeted resources via the OCI Bastion. And customers means you, the administrator, in a secure and time-bound manner. And you can restrict the incoming SSH connections to a certain IPv4 CIDR range, or even to a specific IP address, only one address at all. And everything's going to be recorded through the event and audit service. So the key features of the Bastion service from Oracle is that It's integrated with your identity access management. So you can grant permissions or those users accessing your resources in a private subnet. It's free. I mentioned the Bastion server that you can create with a compute instance. Well, you have to pay for that compute instance, or it will take resources from your allocated free tier as well. The Bastion as a service is a free service that you don't have to pay for it. And it's fully managed by Oracle Cloud Infrastructure personnel. It is as a service, so it's always available. We ensure that the resources behind it are in a highly available manner. It will reduce, therefore, the operational overhead to whomever is accessing your resources. If you create a compute instance, you have to manage it. If there's an upgrade needed, you need to do that as well to enforce that upgrade or to patch the operating system. Here, Oracle Cloud Infrastructure personnel takes care of everything. And it has a very simple networking architecture, as you previously saw in the supporting diagram. And what resources can you access? Well, any compute instance, Linux or Windows, over remote desktop protocol for Windows or SSH for Linux. And the supporting compute nodes for all of these databases via port forwarding. And we'll explain what port forwarding is during the demo of the service. In the nodes, obviously, of the Oracle Kubernetes engine. Again, any SSH-able private IPv4 within OCI. So this is key. So far as with IPv4. So anything that works over SSH can work over the OCI Bastion. Now, there's two configurations or two networking architectures. One that you place your Bastion service on the same subnet that you have your resources, or on a different subnet, like this is the case right here. The Bastion service is in a different Bastion-only private subnet, or you can place it in the same subnet where your resources reside. So here we have the BCN, and then we have the two subnets or two private subnets. And in this case, the Bastion service, the agent, resides in the same subnet where your resources are located. Bastion service demo. In anticipation to this demonstration, I went ahead and deleted some of our instances, actually all of them but one, and I renamed this virtual machine to Wizard Public VM1 because we're creating one that is going to be private. Remember that we utilize the Bastion service to gain access into private resources. And I'm going to go ahead and create this instance because I want to highlight something very important that is needed for you to be able to access the resource as a managed service from the Bastion service. So let's go ahead and name this compute instance. I'm going to call it Wizard Private VM1. And I'm going to leave it in availability domain 1. Actually, just for a change, I'll change it to availability domain 2. Here, we need to specify that it's going to be in the public subnet, in the private subnet, I should say. And we need to, as an extra security measure, grant them keys. So these are the keys that I use for my demos. And this is what I want to highlight. Here under Show Advanced Options, you click on it and you go to Oracle Cloud Agent. And these are the agents that are provisioned by default into your compute instances when you create. However, the Bastion is not checked. So you need to go ahead and check this in order to securely provide access through the Bastion service. And in order for this to work, you need to have either a NAT gateway or a service gateway in your private subnet. And the reason why is because it reaches the Oracle Services Network through either the open internet or through the service gateway and retrieve this agent. So this is why I wanted to create this compute instance in front of you. And while this is being created, now we can go ahead and move on into our topic, which is Bastion. So click on the hamburger icon and scroll down to networking for everything regarding networking. And Bastion service is a security feature for our networking resources. However, it is not located here under networking. We also have an item for identity and security. So to work with the Bastion, you have to scroll down all the way to identity and security and click here on Bastion. And as you can see, I don't have a single Bastion service in my networking compartment. So let's go ahead and create one. And this is going to take a little while, but I can pause the recording and come back when it does provision. So the name of it will be Bastion Demo. Now I'm going to select the virtual cloud network. In this case, it's my Wizard VCN, and I'm going to be using the private subnet because that's where my services are, and I want to place the Bastion service endpoint in my private subnet. Now, the CIDR block allow list. This is from where, through the Bastion, I can access my private resources, and I can be very open-ended and enter 0.0.0.0/0, or I can be very specific for additional security and select something that is not that open. In this case, I'm going to select my private IP. That's my IP address. And of course, this needs to be in CIDR format. So I'm going to type /32, indicating that this is the only IP in that subnet. And there we go. I can go ahead and create the Bastion. This allow list means that I am the only one in the whole world that can access the resources in my private subnet. So my Bastion is being created. That's the first step. And like I mentioned, this might take 3 or 4 minutes. So I'm going to pause the recording and come back when it does provision. So as you can see, our Bastion demo is active now. So if you open it, there's another step that we need to take, and that is to create a session. So let's go ahead and do that. We need to create a session, and this session is going to be open for only 3 hours. So that's an extra set of security, only 3 hours. If you compare this to creating a computer instance and using that as a jump box into your private resources, that's open all the time. So it has the possibility of being compromised. So the reason why we highlighted that cloud agent is because you need the agent for the managed SSH session. Now, if you don't have an agent, there's still a possibility, which is SSH port forwarding. Today, we're demoing the managed SSH session. So that's the one that we're going to be selecting. And I'm going to call this demo session. Now, the user is for the compute instance. It can be root. In this case, we're using an OCI compute instance, and the typical user is OPC. Now we need to select an instance. Which instance do we want? Of course, we already have access to the public instance through the internet gateway. So this is the one that we need. Now, the SSH key is for the session itself, and I can use a different one from the one that I selected for my compute instance. But in this case, I'll use the same one for simplicity. But you can use a different one, and I'll show you how to use them once we get there. And that's basically it. You go ahead and create the session. And again, this will take 3 or 4 minutes. So I'm going to pause the recording again and come back when it finished creating. You can see this already completed the creation of the session. And now the next step is to copy a command and use that command from the workstation that you're accessing your resources from. In this case, is my workstation in my office. So you can copy the command and then later on use it. But let's go ahead and view the command because I want to show you the key aspect that I was mentioning. Here, this private key, and this is the one for the actual session. And then this is the second key, and this is the one for the compute instance, and they can be different. I chose to utilize the same. And notice how it even includes the IP address of the compute instance and the user that we typed in. So I don't need to copy this because I already pasted it here. Here it is. This is the command. I obviously filled in the blanks where it says private key. I'm using my key or my keys, and the rest, it's the same command. So let's go ahead and access our system. And there we are. So now that we are in a private VM, what is it that we do? Remember that virtual cloud network, along with the private subnet in it, they were created with the wizard, and the wizard comes with a NAT gateway and a route to the NAT gateway. So let's go ahead and ping this DNS service. And there it is. We can ping. So what happens if we remove the NAT from the route? Should I be able to ping? So it's the wizard BCN, and it's in the route table, and it's our private subnet. So let's go ahead and remove the NAT. So it's gone. So can I still ping? No, I cannot, but I still have access. So the NAT is for the resources to gain access to the outside, and the batch and host, you use it to gain access from the outside into your resources. Now, let me interrupt this. Now, what happens if I remove the internet gateway from the other VCN or from the other route table? So let's go ahead and remove the internet gateway. And it's gone. No more internet gateway. I'm still connected. I'm going to exit out of it, run the command again. And I can still connect. The internet gateway was not used whatsoever. It was not used at all. And the Bastion is a service that is managed by OCI. So you're using OCI resources to gain access to your private resources. You might recall from the introduction to virtual cloud networking, a VCN has several gateways that you can leverage, one of them being the internet gateway. And we'll start by defining what an internet gateway is. Basically, an internet gateway is an optional virtual router that connects the edge of the VCN with the internet. So it will allow connectivity into the open internet. When we say that is optional, that means that you don't have to configure it. You might not even need an internet gateway. However, if you want to provide communication to the internet, to resources in a public subnet and a virtual cloud network, you need several conditions. And one of them is to have an internet gateway. This will support connections that initiate from within the VCN out. That's an egress rule, or from the internet into your VCN. That's an egress connection. You need to have a public IP address on both ends. Obviously, if you're reaching the internet, that a resource in the open internet, that resource needs to have a public IP address. Your internal resource inside the VCN also needs to have a public IP address. Remember that when you create a subnet that is public, when you create a resource inside that subnet, you have the option of giving it a public IP address. In order for that resource to use the internet gateway, it needs to have a public IP. That way, the bidirectional communication can be established. Another requirement that you need to meet in order for leveraging the internet gateway is that you need to have a route rule in a route table that leverages the internet gateway as a target. And on top of that, remember the previous lessons on security lists and network security group. The security lists and the network security rule have rules that control the types of traffic that are allowed in and out of the subnet. So you need the internet gateway, a public IP address, a route, and a permission for the connection to establish. And this is very important. The internet gateway can only be used by resources in the VCN, like a compute instance or like a load balancer or a database that has a public IP. It cannot be used by another VCN that is locally peered to this BCN. It cannot have like a transit routing, for example, nor it cannot be used by a resource that is connected to your BCN from on-premises via the dynamic routing gateway, which we will see later on. So it needs to be a resource in the same subnet. Now, very important, you can only have an internet gateway, one internet gateway per BCN. You cannot have two internet gateways or more. And as I mentioned at the beginning of the presentation, the internet gateway is one of several gateways that you can have on a virtual cloud network, and we will see the rest later on. The network address translation gateway. And by now, you should be familiar with the concept because we have covered NAT gateway indirectly in the other lessons when we created the virtual cloud network with the wizard tool, and NAT gateway was created. And I highlighted the functionality of it. So right now we're taking a deeper dive into the network address translation gateway, and we'll see specifics of it. So we'll start by defining what NATing is, network address translation. This is a networking technique that is used to give an entire private network access to the internet, an entire private network or an entire private subnet, without assigning each one of the hosts a public IPv4 address. Therefore, the host can initiate connections to the internet and receive replies, but it will not receive an inbound connection initiated from the internet. When a host in a private network initiates that internet connection, the NAT device public IP address becomes the source IP address for the outbound traffic. So that's what NATing does. And as you saw from the previous examples, instances in a private subnet do not have public IPv4 addresses. Adding a NAT gateway to your virtual cloud network will give instances in a private subnet access to the internet. And all these protocols are supported: UDP, TCP, and ICMP. The maximum amount of concurrent connections to a single destination address is 20,000. And remember that in a BCN, you can have up to 64 private IP addresses. So there's a limit on the amount of addresses, actually not addresses, but there's a limit on the amount of NAT gateways that you can have on a BCN. And that limit is typically 1. I have not been in a situation where a customer needs more than one NAT gateway, but in case you do, you have 64,000 possible IP addresses in a BCN and only 20,000 concurrent connections with one NAT gateway. So that 20,001 will need a second NAT gateway. If that's the case, all you have to do is submit a service limit increase request to technical support, and it will be granted to you. Now, for the NAT gateway address, you can use ephemeral or a reserved IP address. And the NAT gateway can only be used by resources within the BCN. Peering a BCN to another BCN will not grant that other BCN resources access via your NAT gateway, nor will the DRG when you connect it to on premises. You've seen a demo indirectly of the NAT gateway before. When we demo it, the Bastion service, basically we require the services of the NAT gateway to prove the concept, and we deleted the NAT gateway from the route table of the private subnet. So let's go ahead and take a look at that route table. So we are using the Wizard Virtual Cloud Network. That's the one that comes with the NAT gateway. And as you can see, we already have a NAT gateway here. And if we go to a route table, you will see that there is no NAT gateway. We only have the service gateway in there. I'm actually going to go ahead and remove this one as well. It's gone. So the table is empty, and we are going to log in into the NAT gateway. That's our command, if you recall from a previous lesson. And we are in. So if I ping this DNS address, it's not working, and it's not working for anything. I can also ping this other DNS address, and there's no connectivity. So the minute that we add the NAT gateway to the route table, we should be able to ping. And we can be very specific. Here I can add 1.1.1.1/32. And I have an extra dot right here. So this is why it's not working. So I'm only pinging that gateway. And now we have a NAT gateway. So this is not going to work because obviously I'm only addressing the other service, the other DNS service. So this one should work. And there we go. So this is what the NAT gateway does. Allows connectivity for resources that are in the private subnet to gain connectivity into the open, into resources in the open internet. So that pretty much covers this demo. This is the last of the VCN gateways that we're covering today. Keep in mind that the dynamic routing gateway is external to a virtual cloud network. Actually, a DRG can have more than one virtual cloud network. These gateways, the service gateway, the NAT gateway, the local peering gateway, and the internet gateway are internal to the VCN. You can create them from within the VCN. And that's a difference with the dynamic routing gateway, but we're getting ahead of our time. Let's go ahead and check the details of the service gateway and what is it that it provides. Basically, the service gateway provides a secure path to the Oracle Services Network without leaving Oracle Cloud Infrastructure. Services like object storage and the autonomous data warehouse. These services, they have a public IP address and they're accessed normally through the open internet. So you do not need to be an OCI to access these services. They're open to the world. And with the Oracle service, the OCI service gateway or the VCN service gateway, you bypass the access to the internet. But what is the Oracle service network? So basically, it hosts a set of resources like the ones that I just mentioned, the object storage, Oracle Analytics Cloud. It serves other services like the autonomous database processing, transaction processing. And as I was explaining, they're normally available on the open internet. And there's a saying that nothing speaks more than an image. So let's look at the image and run an example. Let's say that this database right here needs to get access or needs data from this object storage, this bucket. So if we didn't have the service gateway, the access to this, the information contained in this object storage will have to go this way. Through the NAT gateway, go out into the open internet, leaving OCI, coming back into OCI and retrieve the data from the object storage, leaving OCI again and coming back again and getting to the destination, the file or whatever information into the destination in OCI. So the Oracle VCN service gateway bypasses this exit out of OCI and stays within OCI. Now there's a difference with the other gateways that we saw. We were quick to highlight before that the internet gateway and the NAT gateway was only accessible to resources from within the virtual cloud network. The Oracle Service Gateway behaves a little bit different, and it will grant access to the Oracle Service Network to your resources that you have on premise through either Fast Connect or through your VPN, site-to-site VPN. So that means that work at your on-premises network, if you have a Fast Connect into OCI, you can leverage that Fast Connect to reach the Oracle Services Network, bypassing going out to the open internet. Remember that Fast Connect, and we'll see that later, provides you with predictable latency, predictable bandwidth. The open internet does not. So let's go ahead and see the final bullet point that we have here, which is a service gateway is regional and enables access only to supported Oracle services in the same region of your virtual cloud network. Now, in anticipation of this demo, I created an object storage bucket. So let me show to you this object storage bucket, and you will be seeing this service later on in greater detail. But for now, this is my bucket right here. I call it my demo bucket. As you can see, I'm in my networking compartment still on my US West Phoenix region. And if I open the bucket, well, first of all, you'll see that it's a public bucket. And if it was private, then access to it will be limited. But for the demo purpose, public is perfectly fine. And as you can see, I don't have any object in the bucket. Now I want to go into networking because we are still leveraging the private subnet of the Wizard VCN. And if I go to the route tables, the compute instance that I'm going to be utilizing resides in this private subnet. And this is it. And as you can see, I have access to the NAT gateway. I still don't have access into the service gateway yet. I want to prove a point. That's why I don't have that access. Now, the compute instance that we're using is the one that we reach through the Bastion service. And this is the instance. It's the one labeled private VM1. If we click on it, well, let me go back. So you can see it doesn't have a public IP address. And if you click on it, you will see that it belongs to the Wizard VCN, to the private subnet, and the IP address is this one. So I can log in to that instance through the Bastion service that we previously demonstrated. So let's go ahead and log in. And what we're doing right now is we are going to be sending this file that we created called helloworld.txt. So let's go ahead and take a look of what are the contents of that file. It says there are 10 types of people, those that understand binary and those who do not. So that's the message that's the contents of the file. And how is it that we're going to be sending it to that bucket? So through the command line interface, because we're in a private subnet right now and I'm in a Linux system. So I'm going to be using the command line interface, and this is the command. So I'm using my Oracle Cloud Infrastructure command line interface for object storage. And then I'm going to be placing in this bucket, my demo bucket, the file called helloworld.txt, which is this one. So let's go ahead and run this command. And that means that it's been successfully sent. So if we go back into our bucket, and I should open another window, so I can go ahead and open in a new tab. And here it is. So here's my bucket. And now it has a file. Here's the file. So if I go ahead and download this file by seeing the object details and clicking on this link, then here's the file. I can go ahead and open it. And there's the contents. So it got there through the NAT gateway. The NAT gateway, so it didn't use it went out via the internet gateway. I can still ping 1.1.1.1 and it works. Remember that we had a route that was going to 1.1.1.1/32. I changed that to the quad 0 in case you were wondering. And now we are going to go and remove the route from this VCN, the route to the NAT gateway. So, but before I do that, let me go ahead and remove this file from here. More actions, delete it. So it's no longer there. It's empty. Now, if I remove the NAT gateway, I should not be able to send this file. So let's go ahead and do that. So the route table. Now I'm going to leave my route table completely empty. and it's gone. So now if I want to send the file again, there is no route to it. As you can imagine, it's going to time out. So while it's doing that, I'm going to go ahead and add a route table, select my target type, and this time is the service gateway. Select the service. Do I want all services in Oracle Service Network or only those of object storage? You can select either one and both will work because object storage is part of all services in Oracle Services Network. So, but if you only want it to be very specific, you can use object storage. So let's go ahead and do that. Select object storage and now select the service gateway, the only one that we have, and add the route rule. So this by now should have already timed out. I think it did add it once I created this path. So let's go ahead and check because this is the message that it was successful. Let's go ahead and look. And it did the minute that I added that. So it saved me a step. I was actually going to wait for it to time out. But to prove that we are no longer using the internet, now I'm going to ping 1.1.1 and it's not going to work because I'm bypassing the internet. So that pretty much covers this demo. We are seeing the local peering gateway. Not only are we seeing the local peering gateway or a local peering connection, but we're also taking a sneak peek into the dynamic routing gateway BCN attachment. First, let's start by defining what a local peering is. This is the process of connecting two virtual client networks that are in the same region, hence the word local. And the reason for this connection is so that their resources can communicate with each other using their private IP addresses without routing the traffic over the internet or through your on-premises network. Let's go ahead and take a look at what a local peering connection includes. It includes two BCNs with non-overlapping CIDRs. This is crucial, non-overlapping. If they do have overlapping CIDRs, then it's a non-starter. The local connection will error out if you try to establish it. On each BCN, you need a local peering gateway. And once you have a local peering gateway on each BCN, then you can establish the peering relationship that we call connection. And once that's accomplished, then you need to configure a route that takes you to the next hop, which is the local peering gateway that will push the traffic to its peer at the other end of the connection. And obviously, you need to enable the permissions that will allow traffic between those two virtual cloud networks. Let's go ahead and take a look at how it looks visually. As you can see, these two BCNs, they are in the same data center, in the same region, and they have completely different address, not overlapping. And here you can see that each one of the BCNs has its local peering gateway, and then there's the route. Whenever you're trying to go to 192.168.0.0/16 from 10.0.0.0/16, then you will route to the next hop, which is the local peering gateway 1. And the local peering gateway 1 traffic will be pushed to local peering gateway 2 and then terminate at the BCN. And then the other virtual cloud network will do exactly the same in the opposite direction. Now take a look at this slide. This looks quite similar. The only difference is that this is remote peering across regions. This might be Toronto and this might be Montreal, Singapore, Santiago. You are going to be leveraging the Oracle backbone. So why is it that I'm bringing in remote peering if the subject is local peering? The reason why is because since about a year ago, the dynamic routing gateway has a new feature that enables two BCNs to communicate with each other through the dynamic routing gateway remote peering connection feature, even if they are in the same region. That is possible now with the DRG V2. It's a new feature that is supported. So if you take a look, they look very similar. So what is the advantage of having a dynamic routing gateway connection over a local peering connection? Well, there's advantages and there's also disadvantages. Remember that I said that if you have an overlapping CIDR, it's a non-starter with the local peering gateway. Now with the dynamic routing gateway, you can establish the connection. You're not going to be able to route, but remember that a BCN allows you to have more than one CIDR. So for any reason you have overlapping CIDRs, you can add another CIDR to that BCN, and then that non-overlapping CIDR will be able to route to the other connection. With the local peering gateway, that's not possible. One disadvantage of the DRG over the local peering gateway is that this is a more complicated construct, and therefore the latency is longer than a local peering connection. Now, there's a third way of connecting to local virtual cloud networks, and that third gateway is also through the dynamic routing gateway via an attachment. That's why I call this the sneak peek, because the same dynamic routing gateway now can attach one then more virtual cloud network. So you can have two virtual cloud networks attached to the same DRG and then establish the route target as the DRG, the next hop. And then the DRG will push the traffic to the other virtual cloud network. And we are going to be utilizing the resources that we previously created on the other demos. Our two virtual cloud networks, we are going to be peering them together. The one that we created manually and the one that we created via the wizard. So let's log into our tenancy. And again, to go into networking, you click on the hamburger icon and then click on virtual cloud networks right here. And you make sure that you're in the right compartment and you can see your virtual cloud networks. So these are the two that we previously created. So let's start with the .1 at the second octet, the manual BCN. And what we're doing is basically adding a local peering gateway. We have none right here. It's really easy. Just click on it, create the local peering gateway, give it a name, and I'm going to be calling it manual local peering gateway. Then you click on the create local peering gateway. You make sure obviously that you're in the right compartment. And as easy as that, this is your manual local peering gateway. It's available. The status is not peered. Then we have a route table here that you can actually assign when you're dealing with transitive routing. And then in case there's an advertisement, it will be showing here. And then this indicates if you're connecting to another tenancy. In our case, and for the architect associate purpose, we will not be doing cross-tenancy connections. So we have our first step. Now let's go into our next network. And this is the manual one. We are going to address this one. And remember that the wizard creates 3 additional gateways, but the local peering gateway is not one of them. We do have a NAT gateway, a service gateway, the internet gateway, but no local peering gateway. So we also need to create one here. So this will be the wizard LPG, and then you click create. Same concepts, not peered. So the next step, we already have our 2 LPGs. So the next step is to peer them. So establish peering connection is the first option right here on the 3 little dots that you have to the right. You click on it, and then you have 2 options. Either you browse below for it, or you enter the local peering gateway OSID. And OSID, by the way, stands for Oracle Cloud Identifier. Every single resource has an OSID. So we are in the right compartment. Now let's select the virtual cloud network that we're going to be peering to. In this case, it's the manual BCN. It's also the local peering gateway exists in the same compartment. Now we need to find it. And it's this one. And then you establish the peering connection. And then the status will change to peered. And this will take less than a minute. But while it's doing that, you might recall from the lesson that another step is to establish a route in the route table. And we can go ahead and do that and come and check on the status later on. Well, no need. Here it is. So we go to the route table. And in this case, we are going to be leveraging the default route table. And then you add a route rule to it and find the appropriate gateway. the local peering gateway is the appropriate gateway in this case. And then the destination CIDR block, I'm going to be very specific on the traffic. So it's going to be 10.1.0.0/16. So this way it will allow me to reach both the private subnet and the public subnet at the other end. So far, we only have, I believe, a public subnet. No, we did create both of them. We did create a private subnet as well. And this is our local peering gateway locally here. And then the description is optional. Then you add the route. So that's the step that you require here. We need to do the exact same thing at the other end. So we go to our manual BCN, find the route table. Here we only have one. We don't need to create another one. We are going to be adding the rule. Now the destination over there is 10.2.0.0/16. Our next hop is the manual local peering gateway. And again, the description is optional. And that's basically it. That's all we need to do that. So now we can go ahead and log in to a compute instance on our manual BCN. And let's go ahead and check the address for it so I can copy it. So I'm going to be logging in to manual BM1. This is the IP address. I can select it from here. Copy, open my, and the address is going to be 129.146.171.110. And there we are. There we are. So now let's go ahead and ping our compute instances, private IPs at the other end. So let's ping and there we go. Now, I hope that you can figure out why this is not working. The reason why is because if you recall from a previous lesson, we enabled type 8 on ICMP echo, but only on one end. And that was the wizard. No, that was the private IP on the manual BN. And this is where we are. We only enable it here, but it needs to be enabled at the other end as well. So let's go ahead and do that. And you can get to networking either through the hamburger icon here, or if you click on the virtual machine, you click on the network right here, and then you find your security list. And here, remember, we removed the SSH. So all we need to do is add this rule right here, ICMP. The last time we used type A for echo. Now I want to be very specific. So yes, I'll use type 8 as well. And this should get it working. And there it is. You saw it live. So this completes the demo. Hello, welcome to Oracle Cloud Infrastructure. We've seen route tables throughout the lessons in the demos, but this presentation or this lesson specifically for route tables, so we can take a deep dive into them. So our objective is to do exactly that, take a deep dive into our route tables. We have mentioned that a subnet has a single route table, and you can select what route table that is. It can be the default route table that comes with the virtual cloud network, and you can create one specifically for a subnet, like the BCN created by the wizard BCN. That one had a route table specifically for the private subnet. It was not leveraging that was created by default for the VCN like the public subnet was. So all VNICs in that subnet are subject to the rules in the route table. So the rules govern how the traffic leaving the subnet is routed. Traffic within the virtual cloud network, and I mentioned this before, is automatically handled by the VCN local routing. No route rule are required to enable that traffic. That's why you do not need a route rule to go from a private subnet, a resource in a private subnet, to reach a resource in a public subnet, because the traffic within the VCN subnets is automatically handled by the VCN local routing. You, however, do need permission to access those services. The fact that there's no route rule required to reach a database does not mean that any compute node in another subnet can reach that database. The permission needs to be enabled, and it can be very granular. Now, if a route table has overlapping rules, Oracle will use the most specific one. And for that, I would like to remind you about this route rule. This is the one that we created, demonstrated the local peering gateway. This rule, 10.1.0.0/15, is within the quad zero. The quad zero means everything. It covers every single possible rule. But because this one's more specific, whenever we need to go to a resource that is at the other side of this local peering gateway, at the other side of the local peering connection, then it's going to be utilizing this one, because this one is the most specific rule. Now, if there's no route rule that matches that network traffic, or you're not routing from within the VCN, then that traffic is going to be dropped. Simple as that. No matching rule, packet is dropped. Now, IPv6 addressing is supported on all commercial and government regions. IPv6 is supported. So the main purpose of the route table is to send traffic out of the VCN or out of the subnet. Now, each set of route rules has a destination CIDR block and a route target. Why I didn't say CIDR block? Remember the services gateway rule? This one? The destination is not a CIDR, it is object storage. So what I just said, complement this destination CIDR block. In the case of the service gateway, the next hop, you do not need to specify CIDR. That's the special exception that we have for the services gateway. We are seeing connectivity options. How is it that we can connect our Oracle Cloud Infrastructure resources to the external world? And going to on-premises, you can leverage Fast Connect, which is a private connection link, a digital circuit, or site-to-site VPN, which leverages the internet and is an encrypted tunnel that goes from on-premises to Oracle Cloud Infrastructure. And of course, the third one, we already seen plenty of it, is the public internet. And the main difference that you can spot right on is the predictable latency, jitter, and performance, and the bandwidth as well. You can go up to 100 gigabits per second on selected regions. And we also have 1 and 10 gigabits per second. Now with site-to-site VPN, this is variable. As you can see, the little star right there, that means that you can get up to 800 megabits per second of bandwidth, but it depends on many factors because it's going over the public internet. One of these factors is the network provider and the traffic that it has in it, and who this network provider is and where you are located in regards to the network provider. Now let's go ahead and see a little bit of additional details. Obviously, if you can go to 100 gigabits per second, then you have higher data throughput and lower latency because it's a private circuit that goes from on-premises to the Oracle Cloud Infrastructure. Now, site to site, because it rides on top of the internet, so it's a best effort performance. Now, the routing protocols, Fast Connect uses the border gateway protocol, and so does site-to-site VPN, but with this last one, you can establish static routes as well. Now, BGP offers asymmetric routing. It's allowed. If the router for the different paths are the same, then Oracle uses the shortest path, autonomous system path, when sending traffic to your on-premises network, regardless of which path was used to initiate the connection to OCI. What this means is that if you have two Fast Connect links, traffic might originate from one link and return to on-premises via the other link. There are ways where you can manage your border gateway protocol configurations and enforce a path that remains the same going in and returning from on-premises to OCI. Now, for public peering, it requires the public autonomous system number and public registered prefixes. These ones are your CIDR blocks, your public CIDR blocks. Now, these details are very important for you to know, but however, on the certification test, they're not going to be asked. We're not going to go into this level of details for you to memorizing the maximum transmitting unit. The routing protocol, border gateway protocol version 4. Now, the prefix limits for public virtual circuits, 200 against 2000 for private virtual circuits. So what are these, public and private? What does this mean? So private means that your virtual cloud network will have connectivity into on-premises resources. Now, public means, remember, the service gateway that connects to the Oracle Services Network. So if you want to bypass the internet to access those resources that are normally accessible over the internet, you can leverage your fast connect and the service gateway to get to them. And for that, you establish a public virtual circuit. Now, the autonomous system number for the commercial realm of Oracle Cloud Infrastructure is 31898. It's different for the other realms that we offer for OCI. Dynamic Routing Gateway, the DRG. So the DRG offers you the possibility of creating a global network from your one on-premise site. For example, if you have connectivity established through Fast Connect or Site VPN on one of the regions, let's say Phoenix, all of the other OCI regions are available to your on-premise resources throughout that one Fast Connect. So you can establish a global network that way. And you can even further expand the global network if you attach more Fast Connects on other regions. And it can get very interesting because then you will have network scalability. And this network scalability can be greatly aided by the fact that a single DRG can now have up to 300 virtual cloud networks attached to it, to one DRG. And the remote connectivity is a very powerful tool because not only can you connect your own OCI account resources through remote peering connections on different regions, but also you can establish remote peering connections to DRGs that are located in another cloud account. And let's talk about the features, the main features of the Dynamic Routing Gateway. We're talking about remote peering connection. Remote implies in the word that the Dynamic Routing Gateways need to be in different regions. Now you can establish a remote peering connection in a similar way that you leverage a local peering gateway. You can have a remote peering connection within one region and across tenancies as well. Now, I was mentioning that you can attach more than one VCN to a dynamic routing gateway, and this will allow for a simplified routing that I will explain shortly. Assigning different route tables and policies to each network resource, and by network resource, I mean the attachments that you add into the dynamic routing gateway. And this will allow you to have a fine-grained routing mechanism for your networking resources. An equal cost multi-path routing, ECMP, is now available on the DRG. And by default, it comes off, but you can go ahead and turn that on. Now, I was talking about the routing or simplified configuration. The fact that you can attach more than one virtual cloud network to a dynamic routing gateway, if you need to route across these two virtual cloud networks, the next hop is the same DRG that your VCN is attached to. So this allows for a simplified configuration. You don't need to establish local peering connections. And you can bypass as well remote peering connections, local remote peering connections. High availability. I was explaining that you can have connectivity from on-premises to many regions through that one fast connect. But you can also establish two fast connects, one in each region. And one of the fast connects can serve as a backup for the other fast connect. And we'll see that in greater detail graphically shortly. Increased scale. The DRG used to only allow you to have one virtual cloud network attached to it. Now you can attach up to 300. So that's increasing the scale. Complex routing. You can have routing mechanisms, very fine-grained detail that allows you to connect or interconnect all of these resources that you have attached to your dynamic routing gateway. As you can see in this graphic right here, this dynamic routing gateway, this DRG, has two virtual cloud networks attached to it, remote peering connections attached to them, and then we have a fast connect. Not showing on this is VPN, site-to-site VPN, but it's very similar to the fast connect. And as you can see by the names of the VCNs, you don't need a local peering gateway to establish a hub and spoke VCN. And we'll see that in greater detail in the upcoming graphics. Now, remote peering connections, I'm highlighting here again that they can be in the same region and across tenancies as well. So these are the four types of attachments that you can have on a dynamic routing gateway. Multiple virtual cloud networks, multiple remote peering connections, IPsec tunnels as well, and you're not tied to only one. And actually, we do recommend that you have redundancy if you're connecting to on-premises, either two virtual circuits or one virtual circuit and one IPsec tunnel or two IPsec tunnels. It will be up to your needs to decide which mechanism to utilize. Now, these features that I've been speaking about, they were introduced into the dynamic routing gateway about a year ago, and we called that DRG v2 internally. It's still the same DRG. However, there are plenty of DRGs out there that were launched prior to when the DRG v2 was introduced, and we call that the legacy DRG. And how is it that you can know if you have a legacy DRG? Well, you see this message right here. The minute that you open your DRG, if you see this message offering you to upgrade, that means that you have a legacy DRG. And when you consider upgrading, you have to be very careful because the upgrade causes interruption to your services. So if you have redundancy configured on your on-premises connectivity to OCI, then the impact will not be service interruption, because the way the upgrade works is that one of the connectivities will go down as it's being upgraded to the new DRG. And once the upgrade on that connectivity is completed, then it will move on to the next one, but not before making that link up again into that status. And you also need to be very careful, because once you upgrade, you are not going to be able to go back. Okay. And the upgrade is in 2 steps. You have to click here and then you have to confirm. So you will not be able to upgrade by mistake. So as I mentioned, supports connectivity from on-prem to multiple regions within a single fast connect or VPN terminating into a single region. For redundancy, and this is crucial, Oracle recommends deploying multiple fast connect circuits, either multiple fast connect circuits to one region, or you can have one fast connect circuit in one region and another fast connect in another region, or you can have a combination of both. Multiple fast connect circuits in one region and multiple fast connect circuits in the other region as well. Access to Assure from OCI is available in multiple regions, and these regions keep on increasing. So chances are that if you want to connect to Assure, your region will support it. And the ability to see routes received will allow you to further the routes received from on-premises or from Assure or from an SD-WAN provider into your Oracle Cloud Infrastructure DRG will allow you to utilize these routes and configure your VCNs. And as I was mentioning before, the DRG itself is scalable and has many possible connections for you to enjoy when you're working with this resource. As I was mentioning, this is one of my favorite topics. It allows connectivity, remote peering connections from one region to another. And these regions, they don't need to be in the same tenancy. You also have connectivity going from your OCI account into on-premises through Fast Connect or VPN, and you can connect to your Azure account as well. Now, the routing engine is very interesting because you have several attachments into the DRG. Each one of them will have its own routes. So the routing mechanism or the routing engine starts when you have a packet arriving into the DRG from either one of these attachments. In this case, we're seeing a packet arriving from a BCN. So that means that the traffic is originating from within OCI and it reaches the DRG. The table is inspected and then it terminates on the other attachment. In this case, it's going to on-premises. In part one, we left off on the routing engine, the DRG routing engine. Basically, every single packet that arrives to the DRG through an attachment, it is inspected and the routing engine will forward that packet to the other attachment. In this case, it's going from within the OCI. The traffic is originating from a virtual flat network and is terminating on an IPsec or Fast Connect connection that is going to on-premises. Now, as you can imagine, the import of route distributions, the import policies and route tables is a very important topic in the dynamic routing gateway. Import policies are associated with route tables, and route tables are associated with attachments. And this will allow you to a configuration structure that is designed to scale to large tenancies. We mentioned that you can have a very simplified routing with the DRG through attachments, but also a very complex routing if you are going to be scaling and managing all of these attachments through the route tables and the imports of these policies. The DRG, and we mentioned this before, and now we can see it, can be used to remote on-ramp connectivities. So basically, we have here an on-premise location that has one Fast Connect connection going to Ashburn in this case. So Fast Connect or IPsec going from region on-premises to your OCI region. The other OCI region can be virtually available through a remote peering connection leveraging the OCI backbone. So this DRG has three attachments. If you pay attention to it, has a virtual flat network attachments, a remote peering connection attachment, and has a Fast Connect or IPsec connection attachments. And you're able to reach the other region through the OCI backbone. Transitive routing uses similar configuration, and this setup can be leveraged or used or configured to provide redundancy. How so? This way, you add a second Fast Connect. Therefore, if one of the Fast Connects goes down, resources in the OCI region of the Fast Connect that went down are still available through the remote peering connection. So this is how you can leverage your Fast Connect connectivity to establish redundancy. And speaking of active configuration, we talk about ECMP. And ECMP can allow you to increase the capacity of your connectivity. In this case, in the DRG, we have two 10 gigabit Fast Connect connections. They can be combined as an active configuration, and therefore you have 20 gigabit of usable capacity. Now, ECMP supports the bundle of up to 8 IPsec or Fast Connect connections for your active load sharing. And one thing to keep in mind about the ECMP is that it works with either or. So if you have IPsec, then you can enable ECMP for IPsec. If you have Fast Connect, you can enable ECMP for Fast Connect. You cannot mix both of them. And for illustration purposes, the DRG is a construct. Here you will only have, in reality, one connection. The second one is being introduced to highlight the high availability of the dynamic routing gateway for ECMP purposes. Remember, it's a construct, but because it's a managed service, we ensure high availability, by making sure that that construct, if something goes down on the back end, the service is going to keep on working. You enable ICMP on a per route table basis. Another important aspect is the leveraging of a firewall. A route table allows you to terminate into a private IP address. And that private IP address belongs to either a compute instance or a load balancer. And on a compute instance, you can install whatever you want, including layer 3 firewalls. And if that's the case, you can configure your firewall to be a termination point for your dynamic routing gateway. That way, you can establish transitive routing from going from virtual cloud networks to on-premises through Fast Connect or IPsec. And then you have a route table that will inspect all traffic on the layer 3 firewall and make a determination based on the on its own routing scheme. Routing tables are used to direct traffic on your specific virtual cloud networks, and the DRG attached routing table on the third-party or network virtual appliance. That's what NBA stands for, network virtual appliance. Throughout the DRG lessons, we've been saying how important the route tables of the DRG are. So let's go ahead and take a deeper dive into them. So whenever a packet enters the DRG, this is routed using rules in the DRG route table assigned to that attachment. And remember the 4 types of attachments that we have. So when you create a DRG, 2 default routes are created for you. 2 default ones. One is for the BCN attachments, and the other one is for all other attachments. Remember, what are the other attachments? We have a remote pre-connection attachment, we have a Fast Connect attachment, and we have a site-to-site VPN attachment. And you can use the same route table to multiple DRG attachments or create a dedicated route table for each attachment. This depends on the routing policies that you want. So a BCN attachment has 2 route tables, the DRG routing table for traffic entering the DRG, and it also has a BCN routing table for traffic entering the BCN. Now, the dynamic routing gateway export distribution. When an attachment is assigned to a DRG route table, the contents of that table can be dynamically exported to that attachment. However, when a route imported from an IPsec tunnel or a virtual circuit, they're never exported to other IPsec tunnels or virtual circuits. And why is this? This to avoid having OCI be treated as a carrier. Oracle Cloud Infrastructure is not a carrier, and we avoid by design that routes imported from an IPsec tunnel or a circuit to be exported to other IPsec tunnels. Packets will be dropped. Remember the part 2 DRG sample where we had 2 Fast Connect links in an active configuration being a backup for the other Fast Connect in case one of them goes down. That means that the traffic going into OCI from one Fast Connect cannot leave OCI on the other Fast Connect. And this applies to whatever Fast Connect type you have at the other end, what connection you have at the other end. If you go in from on-premises on a Fast Connect link, you cannot leave to a Fast Connect going to Assure on another link. Again, packets will be dropped. We are upgrading a dynamic routing gateway. As you can see, I'm in the main console, main view of the console, and I'm in the Toronto region. So if I click dynamic routing gateways right here, you will see that I have 2 of them. One of them labeled legacy DRG. The other one is a regular DRG. And I'm going to enter into both so you can see the differences. Yes, from the start, you can see that when this DRG was created, the new functionalities to the DRG were not introduced yet. So it's a legacy DRG and it has not been upgraded. If you click on it, you will see immediately that this is the offer for the DRG to get upgraded. And you have to click on this twice, as we saw on the lesson. First, you click on here and then you confirm. However, this can take up to 30 minutes. So when we do start the process, I'm going to pause the recording. In the meantime, I want to highlight the resources. As you can tell, there's many less resources available or being offered to you to work with. And these are the typical regular attachments that you have: IPsec, virtual plant network, virtual circuits, and remote peering connection. You can tell I have a virtual plant network here. Now, if I click on it, you will see that the button is either gray for adding a virtual plant network, and if it's active, if you click on it, it will not allow you to add a second virtual plant network. So let's go ahead and try this. You can see it immediately turned into gray. And if you catch it, it's going to offer you to add a second virtual cloud network. However, when you attempt to do that, it's going to fail, indicating that the maximum limit has been reached. And we can actually see this if we go to our networking section and try to attach a DRG through the virtual cloud network. So let's go ahead and give it a try. As you can see, I properly labeled them. This is the one that is currently attached. This one is the one that we are trying to attach. Now, second VCN for legacy DRG. If we click on it, and if I try to attach a dynamic routing gateway, as you can see, this VCN has no DRG attached to it. So I can go ahead and click here, create attachment, select the DRG. I'm going to try legacy DRG and create the DRG attachment. And it fails. Limit of DRG attachments of 1 is reached. So I cannot attach it. However, if I attach it to the regular DRG that allows me to attach more than one, 300 as we previously saw, I can go ahead and create that DRG attachment. And there it is. So let's go ahead and check our regular DRG. As I mentioned, you have many more resources to work with, not only with the attachments, but also with the route tables and the distribution of the route tables. And there's another attachment that is cross-tenancy when you're connecting to a resource in another tenancy. And here are my 2 virtual plant networks, and I can keep on going, attaching VCNs if I wish to do so. But let's go ahead and do our demonstration. We are upgrading our legacy DRG. And like I said, once you start this process and you complete it, there's no returning. You cannot go back to the state. So let's go ahead and do this. Upgrade. Are you sure you want to upgrade? Once upgraded, the process cannot be reverted. I'll say yes, we are upgrading to the new DRG. And this will take, as indicated, some time. You saw that this took place almost immediately. And as you can see, the reason why is because I didn't have any resources. Normally, if you have 2 IPsec tunnels, 2 remote peering connections, 2 virtual circuits, as the more resources that you have, the longer it's going to take for the DRG to upgrade. So the first thing that we'll do is we're not calling this legacy DRG anymore. I'm just going to call it just DRG. It's like that. DRG. And because it's no longer legacy. And I'm going to go back into my other dynamic routing gateway and detach this virtual cloud network. Basically, the minute that you hit delete, it's going to delete the attachment, not the dynamic routing gateway, not the virtual cloud network. And right now it's being detached. So if I go here, and it's still attached, but we'll see that this, from the VCN perspective, this is being detached. Now I can go ahead and attach it to the former legacy DRG, now labeled DRG. And there we go. This completes the demonstration. I hope that this was of value to you. It's replicating the image or the diagram that we had, that we saw during the remote peering connection lesson. We're going to be creating a virtual plant network in Sydney, region 1, and another one in Melbourne, region 2. And we are actually going to be using these settings, the same CIDR block for VCN 1, the same CIDR block for VCN 2. So let's go ahead and take a look. So here are the resources that we previously created during the other demos. We are going to be working out of these 2 regions, Sydney. And I already pre-created virtual plant network 1. in Sydney and Virtual Cloud Network 2 in Melbourne. And I even added the permission for Echo on the security list. I also created 2 virtual machines with SSH keys so I can log in to them and ping the other resource once the remote peering connection is established. Before we get started, I want to highlight something that I already previously mentioned, and I want to re-emphasize this. The dynamic routing gateway is different from the other gateways in the matter that is independent from the virtual cloud network. They do not exist within the virtual cloud network like the local peering gateway do or does, the NAT gateway does, the service gateway does, or the internet gateway does. The dynamic routing gateway needs to be attached, and you can actually delete the virtual cloud network, and the dynamic routing gateway can outlive. If you delete a virtual cloud network, other resources like the internet gateway and the local peering gateways will be deleted along with the VCN. So that's a key difference. And let's go ahead and get started. So there's 2 ways that you can attach a dynamic routing gateway into a VCN, but first we need to create them. So as I was mentioning, they're individual components. So as you can see here under networking, we don't have all the other gateways, but we do have the dynamic routing gateway. So let's go ahead and create one. And we are in Sydney. This is our region 1. So we are naming our DRG. It's going to be called DRG-1. And as easy as that. And it takes about a minute to create, a little bit less than that. So while it's being created, let's go ahead and create DRG2 in Melbourne. So it's being created. So I was mentioning that there's 2 ways that you can attach a dynamic routing gateway to a virtual cloud network, from the DRG itself or from the VCN itself. So while this is being created, let's go into Sydney. The creation should be complete by now. And yeah, it is available. So you go into the DRG, and here where it says virtual cloud network attachments, we don't have one. So let's go ahead and attach it to VCN1. The name is optional. If you do not customize the name, then OCI will decide for you, and it's going to be today's date down to the hour. So here you select your VCN1, and as easy as that, they're attached. So let's go to Melbourne and do the same thing, but rather than doing the DRG, this time we are going to do networking, click on virtual cloud networks, select our VCN2, and create the dynamic routing gateway attachment. Here, the name again is optional. And notice that we have the option, are we staying in our tenancy? If we were to connect to another tenancy, then we need to provide the DRG OSIT. In this case, we are going to be selecting the DRG and creating it. And there it is. We have our 2 attachments. Now let's go ahead and work on the peering. But while this is being created, we'll go to Sydney, click on the dynamic routing gateway. We have 1. And you click on it. And you will see that you do not have any remote peering connection attachments. Again, the virtual cloud network is one attachment. The remote peering connection is another attachment. So you need to go ahead and create the remote peering connection attachment. And we are going to call this to Melbourne. And you create the attachment. And this is going to take a little while to create. Actually, it even takes a little while to display. So we'll do the same thing in Melbourne. We click on our DRG, find the remote peering connection attachments, create the remote peering connection, and we are going to call this to Sydney. So let's see how Sydney is doing. And you can see that while we're in the DRG, the attachment is attached. So you find your, this is the virtual client network. You need to go ahead and check the remote peering connection, and you can see that it's attached. And here's your remote peering connection. Now, as you can see, there is no peer status, not peered at all. In order to you to peer with the other DRG, you need to get this OSIT right here. You can show or you can copy. So I'm going to copy the OSIT from here and go to Melbourne. Find my DRG, my remote peering connection attachment. And here I establish the connection. And where do I want to connect to? So I want to connect to Sydney. And you find Sydney from this drop-down list. And here it is. And then you enter the OSIT that you just copied and establish the connection. And this will take a little while. While this is being created, remember there's an extra step that we need to take in each one of the regions, and that is to create a route in the route table that will take me to the DRG. So let's go ahead and do that here in Melbourne. I'm going to go into my networking, select my virtual cloud network, click on it, go to my route tables, and this time I'm selecting my default route table and adding a rule. So I'm in Melbourne, so I'm going to 10.0. .0.0/16. And here, because I only have one dynamic routing gateway, our attachment, it already pre-selected it for me, and I can enter a description, optional. And there we go. We have our route. Now we'll do the same thing in Sydney. Open my route table, click on the route table itself, outer rule, dynamic routing gateway. And here we're going to 192.168.0.0/16. So we should be complete by now. Let's go ahead and check the status of our connection, remote peering connection. You can see the status is peered. So we should have connectivity right now. Let's go ahead and check the addresses of those compute instances. And we'll choose one. We're in Sydney. So this is the address that we're pinging from Melbourne. So let me go ahead and, I'll just remember that it's the 164. Now, I need the public IP address of Melbourne. And I'm going to open and here it is. So load, enter the address. Open it, and it opened my other window. So let me drag it into this window right here. And here it is. So I'm in VM2 in Melbourne, and I'm going to ping the address, if I'm not mistaken, was 10.0.0.164. And there it is. Remote peering connection is working. And site-to-site VPN is a free service from OCI. The service is free, and the data transfer coming out, the first 10 terabytes are free. Every incoming data is always free. So site-to-site offers a simple and secure way to connect your corporate network to OCI over an existing internet connection. So you do need to have an internet. And again, the difference of utilizing site-to-site VPN over regular access is the gateway that you utilize. Over the regular internet without encryption, you use the internet gateway. If you want to have a tunnel, a VPN tunnel, then you use the dynamic routing gateway. And site-to-site VPN is an IPsec VPN connection, standard one. So this encrypts your data over the public internet. So the feature, site-to-site VPN, is a secure connection between OCI and your on-premises network or your other end of the connection. And it comes with 2 tunnels for redundant purposes. So on the Oracle side, you have 2 routers. So we do recommend that at your customer side, you also have 2 routers. And of course, the Internet Key Exchange, IKE, V1 and V2. And this is how it looks. Basically, you have your data center, your on-premises, and then at the other end, you have what we call the customer premise equipment, and then you connect to Oracle Cloud Infrastructure. Now, the use cases, there are several of them. Again, this is free, a free service, and you can create as many site-to-site connections as you wish. And that will allow you to connect all of your locations into OCI. Now, remember from the previous lesson, or from a previous lesson, OCI cannot be a telecom carrier. So you cannot use OCI to connect from on-premise site 1 to on-premise site 2 through OCI. But however, you can connect all of these sites to OCI to access your resources from whatever you want. And you can extend your resources, or you can extend your on-premise data center into OCI through VPN Connect. One of the main use cases is to serve as a redundant connection to Fast Connect. So use Fast Connect for production, and in case something goes wrong, the link goes down, you have a VPN connection to keep the lights on while you fix the more faster, more predictable connection, which is Fast Connect. Now, what is it that you have on the other end? Well, you have the customer premise equipment, and Oracle Cloud has validated several vendors, and these are the equipment vendors that we have not only instructions and support for them, but we also have videos that indicate how you configure those vendors' endpoints to connect to OCI. And if your vendor of choice is not there, we also have a generic configuration that you can check in the Verify CPE list. If you're not sure how to get there, click the Ask the Instructor a question and we'll gladly provide you with the link. So static routing is supported as well as BGP. And it supports IKE, V1, and V2 as previously mentioned for your encryptions. Now, the dynamic routing gateway serves as the head end on the OCI side of the IPsec connection. However, the dynamic routing gateway is not the only thing that you need. You also need to create the tunnel itself. And once you create the tunnel itself, then you are going to get the public-facing IP addresses that you need to connect to, one for each tunnel. The custom premise equipment is your actual router that you have on site. On OCI, you need to create a virtual representation of that customer premise equipment. And for it, you need to give it a name and retrieve the actual IP address that you have on your router, the public one, and capture it in the object that represents that CPE. Once these steps are taken, then you can go ahead and create the IPsec connection. And again, static routing and BGP are supported. And this is basically how it looks. I was mentioning that the DRG serves as the head end, but you need to create the tunnels. And these are the ones that have not only the IP address, the external IP address that you're going to be providing to your customer premise equipment, but also the share secret. And then behind you have the resources that are going to connect to your customer premise equipment. And then this NAT, CPE, and CPE, this might be the same equipment. It depends on the vendor that you have of choice. Then you have the default key with the public-facing IP address, and then you have the private IP addresses. So these resources are going to communicate most likely using private IP addressing. Now, the site-to-site VPN supported by Oracle is the tunnel mode, where everything is encrypted, the fully packet, or the fully encrypted packet is what you send across the IPsec site-to-site VPN tunnel of Oracle Cloud Infrastructure. We are doing a VPN Connect demo, and we are connecting from on-premises to OCI. This is the actual setting. These are the actual addresses that we're going to be configuring. Our BCN is 192.168.0.0/16. And the router that we have on premises, this is the actual IP address, the public IP address. This is the private CIDR. And we are going to be configuring the OCI side. What we have right here is Slivers 1. This is the customer premise equipment that we decided to use for this demo. And we are going to retrieve the information that we need to feed the customer premise equipment with. And every customer premise equipment, when you build the VPN connection, the tunnels, you need to create a device on OCI that represents this customer premise equipment. So let's go ahead and access our console so we can create everything from the ground up. We are creating everything from the ground up. We will be building a virtual cloud network. We will create a DRG and attach the VCN to the DRG. Update the routes. So we're creating a table, or actually we're creating a route in the route table that will take us to the DRG. So whenever we want to reach 172.31.0.0/16, we will be using the DRG, the Dynamic Routing Gateway. We need to create the customer premise equipment, as previously mentioned. And then we will create the IPsec tunnel. And with the information that we retrieve from the IPsec tunnel, like the addresses, the counterpart to the CPE, and the shared secrets, we'll collect those so we can configure the CPE. So let's go ahead and proceed. So in order for you to, because we're creating everything from the ground up, we'll create a virtual cloud network. And as you can see, I'm in my testing compartment. I don't have a single VCN in it in the Ashburn region. So we are going to be creating one using the wizard. And even though we have here a wizard for VPN connection, we are going to do everything from scratch. Feel free to, if you decide to do this as a lab, once you complete everything that you need, you can go ahead and then do the VPN connection. This is much easier. So I'm going to call this OCI VCN. The compartment is the correct one. Now the IP addresses, we decided to use 192.168. So that's what we are going to be configuring. Both our VCN and our subnet. And as you recall, this is all we need. This is going to be taking a little while. Normally the private subnet takes a little longer. In the meantime, we can advance and create the dynamic routing gateway. And this is easier. I'm going to call this 2 on-prem, same compartment. And we should have our VCNs by now. So we can go ahead and create an attachment. I'll leave the name to OCI, so they'll fill this for us. This is the VCN that we just created. And while this is being attached, we can go ahead and update the route to the DRG. But in the meantime, we are going to create the CPE, the customer premise equipment. So this is the IP address. It is 54.67.20.17. And I'm going to call this, because this is Livers 1. liver is CPE. So again, this is 54.67.20.17. Now the vendor. As you can see, we have many vendors for you to select from. And here you can see that I have another tab called Verify CPE Devices. These are the devices. So we are using Livers one because that's the one that I downloaded into the compute instance that I have on premises and to the compute server. But if you go into OCI docs, into the documentation for VPN, you will see that we have a list of the verified CPE devices. And today we're only doing the OCI side, but if you decide to go further and learn how to configure the Livers one side, we have everything that you need, all the documentation, the configuration, and we even have a video that covers the OCI side. So feel free to go ahead and do that if you decide to do this demo as a lab. Okay. Again, it's the verified CPE devices. We only have one version right now, so that's what we're selecting, and that's all we need. So again, the CPE is a representation of your router that you have on premises. And the use of it is that you can use the configuration helper. And once you configure your tunnels, this will have all the information that you need that you can take to the router, because you need to inform the router of the OCI side. And currently we don't have any IPsec connection, but that's the next step. We still have pending the route to the virtual, to on-premises on the VCN. So let's go ahead and add that route. So as you can see, by default, the wizard created a route to the internet gateway. So we are going to add a route rule. And right now we're going to the dynamic routing gateway. And our destination can be, it was 172.31.0.0.16. You just want to make sure that's what it is. So the route is there. We have the CPE device. Now let's go ahead and create the IPsec tunnel. We need to select the customer premise equipment that we created, the dynamic routing gateway. Now the static route, in this case, we're using static routes. You can also select to do a BGP for another occasion. So 172.16.0.0/ it was not 16, it was 31. So the previous time that we entered this was in the route table. That was for routing purposes. This is for the VPN itself. So now we're creating the IPsec connection. And it's going to take a couple of minutes. And once these are in the provision state, these will remain down. They're available. They're down because we need to configure the on-prem side, and this is what we were waiting for. So we need to take these IP addresses and let the CPE know that they need to connect to OCI to these IP addresses. But they also need our shared secret. And for you to retrieve the shared secret, you go on each one of the tunnels. This is the long way, by the way. And here's the shared secret. You can show it, or you can go ahead and edit it in case you want to change it. Now, I mentioned that this is the long way. What is the short way? So let's go ahead and find our customer premise equipment. And I was mentioning, so it moved to here. I was mentioning that we can use the configuration helper and we can create the content based on all the information that we have so far. And this is what you will take to your router side. And you can see here we have the public IP address. This is the static IP. And we should have the share secrets, and they're right here. This is one of them. Okay. So I'm going to pause the recording and take this information to the customer premise equipment. And once I do that, then these tunnels should come to the state of up. So see you in a couple of minutes. Bye. Hello, and we are back. And as you can see, the IPsec status now has a state of being up, both tunnels. Fast Connect, the private predictable service from OCI into your on-premises network. So the port speeds that we offer for Fast Connect is 1 gig, 10 gigs, and now in certain regions or certain types of services, we can offer 100 gigs. We offer 2 ways of connecting to OCI through Fast Connect, and that's the private peering. This will allow you to keep everything on the private space without facing the internet at all. So if you have a private network like a database in your on-premises and you need to connect to resources privately on a RFC 1918 address in OCI, you select the private peering option. Now, public peering will allow you to connect from on-premises into OCI public-facing services, but bypassing the internet. Public-facing services like object storage or the autonomous data warehouse. Now, you only pay for the port. There's no charge for you for inbound or outbound data with Fast Connect. And it uses the border gateway protocol for connectivity between OCI and on-premises. So your router will advertise the routes to us, and we will advertise the routes to your router through BGP. Now, we offer 3 scenarios for using Fast Connect. The first one is a direct connection that you have from your Oracle colocation on the data center. So if you're in the same colocation with us, we will issue a letter of authority to you, and the data center staff will create a patch between OCI and your network on that data center. The second option is through an Oracle provider like Cloud Exchange. They already have an agreement with Oracle. And check the region, in the region that you are, and when you're selecting the partners, you see which partners are available. Not all of them are in all the regions. Now, the third option is basically use a third-party provider that will allow you to reach the Oracle data center where we have our Fast Connect links. So let's go ahead and check the use cases that we have for Oracle Cloud Infrastructure Fast Connect. So latency sensitive enterprise applications. So this will allow you to predict latency and the service that you will be getting from Fast Connect between on-premises and data center. You cannot get this with VPN because there's a third party involved and it leverages the internet. So you're basically with VPN, you're connecting over the internet, not with Fast Connect. So big data. This is a very important use case because obviously if you have 100 gigs or 10 gigs, you're going to be able to transfer a lot more data from on-premises into OCI. And bypassing the internet altogether allows you to with more confident transfer sensitive data from on-premise to OCI or vice versa. And this is very similar to lift and shift to the cloud. This is very similar to big data. When you're migrating from on-premises, taking your physical data center into the virtual data center that is OCI, Fast Connect is a great option for this. Now, these are our partners. Again, check your region because not all of them are in all regions. It varies by region. If you're going to select option 2, which is through a partner, go ahead and see the partners and see which one is close to you, and you can leverage that one. So now you can read this slide. You can pause the video. I'm going to touch on some of the points right here. So typical bandwidth dependent, that's on the customer access. We talk about that. Now, Fast Connect, we have 1 gig, 10 gigs, and in some cases, 100 gigs. Now, routing, we have static routing and dynamic routing. We also have now policy-based routing as well. The encryption, by default, you have that on the IPsec. There's no encryption on Fast Connect. However, you can establish your own firewall if you wish to do that. And again, very important, the SLA. There's no SLA, no service level agreement with VPN because there's a third party. There is an SLA with Fast Connect, 99.9 availability. And this demo is a little bit different from the previous demos that we have done, as the Fast Connect circuit is already in place. It's already configured, up and running. And I'm going to demonstrate to you how to create one similar to the one that I'm showcasing. So you can imagine creating a digital circuit from on-premise to Oracle Cloud Infrastructure. It's a little bit more elaborated than creating a VPN connection where you already have the internet connectivity and it's a free service. Fast Connect, you have to pay for the port on the OCI side. And then if you have a vendor, you have to pay that vendor as well, a partner. You need a partner to establish the Fast Connect connection. And then if you have the other end of that partner, it might be another cloud provider. It might be that partner is providing you services in their own data center, or you might have an SD-WAN provider that you're connecting to. So there's many variables involved. And that's why we are demonstrating something that is already in place, but we'll demo how we got there. So let's go ahead and take a look. As you can see, I am in the Ashburn region. And if I go into networking and under customer connectivity, I can find my Fast Connect circuit, and it's located in the compartment properly named as Fast Connect. And I name my link to on-premise because I'm going to, and on-premise, you can see that it's provision. The IPv4 border gateway protocol state is up. So it's IPv6, the state is up. And this is not common. Normally, not a lot of people have IPv6. This was for a troubleshooting purpose. And the access to on-site will use IPv6 to ping the other end because that's what we have so far. So if we click on the name of our Fast Connect circuit, you will see the details of it. Here you will see that the state is up and that is a 10 gigabits per second circuit using the partner Equinix. The virtual circuit is activated. The virtual circuit is private. The other option, it could be public. This is a private circuit. When it was created, and the dynamic routing gateway that is attached to. Remember that the Fast Connect is also an attachment. Virtual circuit is an attachment to the dynamic routing gateway. So let's go ahead and take a look of our dynamic routing gateway. The name of it is Up DRG to On-Prem. Here you can see that I have one VCN attached to this dynamic routing gateway. Here's my virtual circuit attachment. I have two IPsec tunnels and I have two remote peering connections. So as you can see, this is a very active dynamic routing gateway. And if you click on the attachment name, then you can see more details. As you can see, it has a route table that I'm calling two local peering gateways. So this is, just by looking at this, you can tell that this is a hub and spoke. Now let's go back into customer connectivity because I want to show you how is it that we created this Fast Connect. So Fast Connect is right here. And we are going to be clicking here, create a Fast Connect. This is a fictitious one. You have two options. Fictitious because it's not going to complete the circuit all the way to the other end. It's just how is it that you configure one in Oracle Cloud Infrastructure. So you have two options, selecting the Fast Connect partner or Fast Connect direct. Now, a Fast Connect partner means that there's a third party involved that already has an agreement with Oracle Cloud Infrastructure, and you can start the connectivity here at Oracle Cloud Infrastructure, you are going to get an OSIT that you need to take into that partner, and that partner is going to be using it to connect and establish the link, or the link between the Oracle Cloud Infrastructure and them. Then they're the guy in the middle. Normally, you're trying to establish connectivity to on-premises, so they have a way for you as a customer to connect, and you will need to speak with them. So who are these partners? So here we have AT&T Netbond, British Telecom, and a boatload of other partners that you can select from here. And please notice that these are the partners available in the US Ashburn region. If you select another region, let's go into Frankfurt, for example, then you will see that the partner list is different there. It looks pretty much similar, a whole boatload. Let's go into Santiago de Chile. So South America. So it should be, here it is. So as you can see, not all regions have the same amount of partners. Not all regions have the same partners. So it's a little bit more limited over there. And but these are the partners that you have in Santiago de Chile. So let's go ahead and check back to Ashburn. This is where we are. And now I want to point to Fast Connect Direct. So on Fast Connect Direct, you don't have a partner because it's a direct. You need another vendor that is going to help you complete the connection into OCI. OCI is not a carrier, and we only offer the port. That's what we offer. And somebody needs to help you plug in the physical connectivity into our resources. And in this case, basically, you need to go into the data center, and this is what POP means, point of presence. And we will issue a letter of authority once you complete this process. So you give it a name, you select the compartment, and then you have two options: single cross connect. So this in case link aggregation protocol is not supported, or cross connect if you want to support link aggregation. Link aggregation basically allows you to have two physical connections act as one. So let's go ahead with this one. And then you give it a name, select the speed, 100 gigs is supported in Ashburn. Then you fill in the rest of the blanks, hit create. And the minute that you hit create, I will issue a letter of authority that you can download and go into the data center with a partner and finish the connection. If the partner's already in that data center, then it's going to be a patch cable, basically. If the partner's not there, then they'll need to make sure that physical connectivity gets from on-premise into that partner. If I hit create, it's going to fail because I don't have enough service limits. Let me show you. If you don't have service limits, then you'll get a message. So here I'm going to select Equinix again, click create, and I don't have service limits, then I get this message. I was expecting this, but let's go ahead and go to the previous window. Now select Fast Connect Partner, and here we previously, for the connection that we have up, we're using Equinix. Now I can go ahead and click Next. And then I need to provide all of these information. It's going to be a private virtual circuit. The private virtual circuit is the one that we have up and running right now. And basically it is used to connect your private resources on a virtual cloud network into on-premises. The public virtual circuit will help you connect the Oracle services, network services, with your private network that you have on-premises. Then here you specify what dynamic routing gateway you're going to be using and what bandwidth. And here you see that we have these options all the way to 10 gigabits per second. Now here's where you enter the IPv4 address of the routers. And if you want to establish IPv6, you can go ahead and do this. And this is basically what we're creating here is a router in the middle. And you can use these ones. You're perfectly fine. /30 means that you only have 4 possible addresses. And if you enable IPv6, then you have to enter those addresses as well. And then customer border gateway protocol autonomous system number. you need to enter it here. Normally it's a 5 digits. So let me type something, 5, 6, 7, 8, 9. Not sure if that's going to work. And then if you have this information, you go ahead and fill it. And then you click create. And this will start the creating process. And here it will let you know what's next. So you take the OSIT and you take it to the partner, in this case, Equinix. And once this completes, it's going to go into the down state. And once it's in the down state, it's because you also need to go into the customer, into the partner and provision on the partner's portal. And once you complete that, then if there's a third-party portal, then you need to fill that as well. The third-party portal means the third link of the connection. And that's basically it. So once you have your Fast Connect up and running, like this one is up and running right now, you can connect to your VM and test the connectivity. And here it is. I mentioned that I was going to ping an IPv6 address because that's what we have at the other end. And you go ahead and ping, and you can tell that these resources are very close to each other at the other end because it's 1.26, 1.27. So the millisecond or the latency is very small. And if you recall from the remote peering connection between Melbourne and Sydney, it was greater than that because the distance is much greater. These resources are in the same data center, basically, or the same campus. So that's why the latency is so small. So this completes the lab. I hope that it has been of value to you, and I'm looking forward to seeing you in the next lesson. Thank you very much. Load balancer, the load balancing service. What is it that I'm calling it load balancing? If you log into the Oracle Cloud Infrastructure console and you navigate to networking, select load balancer, you will see that we have two options for you to select from. One of them being the load balancer, the plain load balancer offering. And as you can see from this image, it's a layer 7, HTTP and HTTPS, and a layer 4 for TCP. So it's a well-rounded load balancer. Now, the network load balancer, at the other hand, offers you specific layer 4 services. On top of TCP, it also offers you UDP and any protocol listener, ICMP included. So layer 3 is supported as well through ICMP. Now let's go ahead and take a look first at the load balancer service, the first option that we saw. Improves resource utilization, facilitates scaling, and helps ensure high availability. Now, a load balancer by the service, by nature of the service that it provides, it improves resource utilization and ensures high availability. If you have several servers in the backend set, that by definition is high availability. If one of them goes down, the service does not get interrupted. And if you combine your load balancing service with autoscaling, then you can have autoscaling set at a minimum configuration. Let's say that you have 4 servers. If one of them goes down, the autoscaling will replace that server that went down because the load balancer will decommission it. Now you have 3. The configuration is set to have minimum 4. So autoscaling will provision and replace that server that went down. Or if you decide not to combine autoscaling with the load balancer service, then you can replace that server manually, address whatever happened to it, fix it, and put it back in service, or plain replace it. Now, allows you to configure multiple load balancing policies and application-specific health checks. So multiple load balancing policies, policy like IP hash, round robin, least amount of connections, and application-specific health checks. You can have a database running, that's a specific application, and monitor the health of the database port. In Oracle's case, is 1521, or port 22 for SSH, or port 443, or 80 for web server. Now, the network load balancer, this is a non-proxy offering from OCI, and it's also highly available, and you can scale as well. The network load balancer advantage for layer 4 over the regular load balancer is the low latency. If you have an application or a need for low latency, then network load balancer is your option to go with. Now let's go ahead and see where the load balancer sits in the overall configuration that you might have. It sits between the requester and the backend server. So it's the guy in the middle, basically. And what are the tasks performed by a load balancer? So the listener will provide service discovery. If you have a load balancer with multiple services, then it will discover what service you're being targeting. It can be a load balancer that sits in between a database in a storefront. You can have a load balancer for a web server as well. So you define that, and that's a task performed by the load balancer. Also, the health checks that we previously mentioned, and the algorithm that you're going to be using for your policies. The benefits, we already mentioned, high availability and scalability. And naming abstraction, you do not need to release the public IP addresses of servers that you might have behind the load balancer. Releasing only the IP address of the load balancer should be enough. And the public IP of the load balancer is the one that you can use for your DNS service. Now, being a little bit redundant, we already mentioned high availability of one of the features and scalability. Now, the load balancer enables public and private options. So you can have a private load balancer sitting on a private subnet, load balancing requests to databases, transaction processing databases. And these are the protocols that are being supported: HTTP, TCP, and WebSocket. And supports SSL termination. So with the load balancer, you can have SSL termination end-to-end, going from the requester to the load balancer to backend servers, all of them supporting SSL, or SSL tunneling, where the load balancer is the proxy and enables the handshake between the backend server and the service requesting the service to establish the handshake through it. And supports advanced features such as session persistent and path-based routing. So session persistent, if a session is interrupted, then once it's reestablished, it will persist between the client and the backend server. Now, our key differentiators: private or public load balancers. Obviously, the public load balancer will come with a public IP address. Provision bandwidth, flexible load balancer, and we'll address this a little bit deeper in a minute. And single load balancer, we already mentioned that the first option provides with layer 4 and layer 7. Now, going back to the provision bandwidth, the flexible load balancer, this will allow you to configure a load balancer shape with a range for your shape, the range of bandwidth. It can go from 10 megabits all the way to 8 gigs. And there's nothing better to highlight this than to actually show it on the console. So let's go ahead and go into a load balancer. And as you can see here, I'm creating a load balancer, and it's offering me the shape for me to select the shape that I can go from 10 megabits all the way to 8 gigs, provided that I have service limits that allow me to configure load balancers to 8 gigs. As you can see, this one is limited to 5 gigs or 500 megabits per second. And I can select my shape to be anywhere in between. And once I do, then this will be flexible enough to address the service requests coming in. So if I have a low amount of services, then the bandwidth for my shape will be, in this case, 390 megabits per second. And if the traffic increases, then I can go all the way to 4273 megabits per second. Now, the minimum bandwidth provides instance readiness for your load, and the maximum bandwidth provides you with, or helps you control your costs much better. And there's one of the benefits is the faster scaling of your load balancer. So now I mentioned the flexible load balancer. This option is for newer accounts only. This is the only option that you have. You get to select. Older accounts, once they were created like about a year ago, had another option called the dynamic shape. And you can spot a load balancer once you open it that was created with this setting, dynamic shape. The dynamic shape offers you the option to have a fixed bandwidth, either 10, 100, or 400 megabits or 8 gigs. those were the only 4 options available. And I was saying that you can spot a load balancer that was created with that shape, because when you open it, will offer you to upgrade. And if you decide to take the offer to upgrade, you will get a screen that looks like this and update the shape. And then you can select the minimum bandwidth from this pick list and the maximum bandwidth from this other pick list. But once you do, there's no going back. It cannot be reverted. So you need to really consider if you want to do that or not. Now, for your mobile applications or your mobile clients accessing your services, HTTP 2 is supported over HTTP and HTTPS listeners. Let's log into our tenancy. I pre-created 2 web servers. Here they are in these 2 tabs. These 2 web servers will be the backend servers for the backend set of the load balancer. And as you can see, this is web server 1. The last octet of the IP address is 192. And here it is. And the other one is 224. The only difference between them is the server number. This so you can identify in what server you are once we configure the load balancer. Let's go ahead and do that. In order for you to find load balancing, click on the top left hamburger icon menu, scroll down to networking, and find load balancers right here. And click on the create load balancer. We are going to be creating one in our testing compartment. And select the option. In this case, it's the OCI load balancer. Click create load balancer. Now give it a name. I'm going to call this my web servers LB. Now it's a public load balancer. This is a public facing load balancer. So we will be selecting the public type. Now the IP address will be ephemeral. This means that OCI will be giving us the public IP address. Now you can go ahead and reserve one, and this will be another demo. Now pay attention to the shapes right here. As you can see, it's pre-selected the flexible shape. This is the legacy account. That's why there's another option, the dynamic shape. This option is going to be going away the 11th of May, 2023. If you have a newer account, this option is not there. Now the bandwidth, I'm going to select from 10 megabits all the way to 400 megabits per second. That will be our shape. Now the BCN, I pre-created one, and this is the public subnet for our public facing load balancer. Now the backends, I'm going to be selecting the backend servers based on the round robin option. Now let's go ahead and add our backends. These are the ones that we pre-created. And now the health check. I'm going to be using the HTTP protocol, port 80 for the health check. And for the time being, I will skip the secure socket layer. Click on next. Now my listener, you can give it any name that you want. I'm going to call this listener. There we go. Now these web servers are using port 80. So I'm going to be selecting port 80, HTTP, my protocol. And this is it. I'm going to skip the error logs, click submit, and it will take like about 2 minutes for your load balancer to be configured. So the load balancer has been configured successfully. And as you can see, my servers are operating normally. There is no issue with them. The health check is fine. And here's the shape that we selected. And this is the public IP address of the load balancer. So let's copy all 4 bytes of the public IP address. Copy it. Now I'm going to open a web browser and go into my load balancer. And there it is. And it landed on server 1, but if I refresh, it's got to go into server 2, server 1, server 2. Remember that this is round robin. And the load balancer is operating as it should. So this completes our demo. We are seeing public and private load balancers. And we'll start with the public load balancer. When you create a load balancer, you're going to be getting a floating IP address for this load balancer that you're configuring. And why is this? Well, first of all, because it is public, you need a public IP address. And why is it that you're getting a floating IP address? Because when you create a load balancer, by default, it creates one load balancer that is in the active mode, and then you have a backup load balancer. And if there's a situation where the active load balancer fails, then the standby will take over using that same floating IP address. So this is why it's transparent to you. This is load balancer as a service. Now, when you create the load balancer, it is a requirement that you either select a regional subnet or an availability domain specific subnet, and that each one of these two availability domain specific subnets need to be in different availability domains. Not recommend that you create two availability domain specific subnets in the same availability domain. And we'll see this graphically, how it looks in a short minute. Now, the service treats the two load balancers as one, and you will not be able to select which one will be primary. Again, this is completely transparent to you. So when you're configuring your load balancer, and if you are in a multi-availability domain region, then it's going to be, and if you select the regional subnet, then the active load balancer will be in one availability domain, and the standby will be in a second availability domain. We have regions that only have one availability domain, and this is where the fault domain comes into place. The load balancer will be having the active load balancer in one fault domain and the standby in another fault domain. When you set up your backend set, not only does the active load balancer have connection to them, but also the standby will have connection to the servers in the backend set. And this looks very similar. You'll notice that this is the regional subnet spanning two availability domains. When you select the subnets to be availability domain specific, the configuration looks very similar. The only difference is that the subnets themselves. They don't span the two availability domains. They're specific, but you require that the second subnet be in a second availability domain. That's the only requirement. The backend set looks exactly the same as the previous settings. Now, when you configure your public load balancer, you have two ways of connecting or routing the incoming requests to the backend sets. Either this is host-based or path-based. So this is how host-based look. You have two different hosts being served by two different backend sets, but you have your listeners here on this one load balancer. And then the request starts coming in, and this is the way that you configure your settings. You have here your listeners, and then you have here your backend sets. And route is distributed appropriately based on this configuration. The other option is the path-based route, where you specify the backend set and then specify the path where for the service that you're going to provide. In this case, it's access to either an application or to videos. And then you configure the path based on your path route sets. The private load balancer has main difference that you don't have a floating IP address. A private IP address is a sign that serves as the entry point for the incoming traffic. But each one of the load balancers will be getting their own private IP address. And the private load balancer can be accessed from a virtual cloud network in another region or in the same region, but through local peering connection, or from on-premises, either with the Fast Connect private peering or with site-to-site VPN. And again, the main difference between a private load balancer and a public one is that the traffic is local. Here from the local VCN or from another VCN through local peering connection, remote peering connection if that other VCN is in another region, or from on-premises. And the backend set looks exactly the same. Redundant connections from the standby or failover load balancer. And this is the regional subnet. The availability domain specific subnets look very similar to the ones that we saw for the public load balancer. Again, the backend set is identical. We are creating another load balancer, this time using a reserved IP address. This is the previously created load balancer. It's really similar. Click on the create load balancer, select your load balancer option, and I'm going to leave the blank name today. Type remains public. Now, the only difference is here we're selecting the reserved IP address. The minute that you click on it, it will give you more options here, as you can see. So you can either select an existing reserved IP address. This is the only one that I have. As you can see, I properly named it for LB demo. Now you can create a new one right here and then give it a name, select the value, what compartment do you want it, and who's going to be the provider. Besides Oracle, you can add additional providers. In this case, we are going to be selecting a pre-configured IP address. The shape option remains the same. This is going to be smaller, 200 megabits. Here we go. Same VCN. Same subnet. Same policy. Same servers. You can do that. You can have several load balancers with the same backend sets. Also, the same policy. And I'll skip SSL again. Listener will be on HTTP. Then you click on next and you submit. So the same process. The only difference is that you're going with the reserved IP address, and this IP address will outlive the load balancer if you decide to delete the load balancer. Okay, as you can see, everything is up and running as expected, and this is our public IP address, the one that we reserved. Again, if you copy it and open another browser right here, it should work with no issues. And there it is, landed on server 1, server 2, server 1. Now, if we go back and terminate this, there we go. So this is in the process of terminating. Okay, so the load balancer has been deleted. If I refresh here, it's going to keep on searching until it times out. So I can go back and create a new load balancer here and reuse that same IP address. So that's the benefit. Here it is again, 155.248.205.88. This is still trying to search for it, and it will continue to do so until it times out. You can see I'm already in my tenancy, and I have 3 additional tabs here. So the first one, I would like to show you that I have 2 database systems. They are Oracle databases, and here they are. This is the first one, called this first, and the second database is called second database system. So in the first one, if you scroll down, you're going to be able to see the IP address of the compute node, and the same thing with the second database system. Now, these are the nodes that are going to be serving as the backend servers for the backend set of our private load balancer. So let's go ahead and configure our load balancer. So it is very similar. Find your load balancer under networking. And here you will see the previously created one for the first demo. So now we are going to click create the load balancer, select the OCI load balancer. Now I'm going to call this DBLB. Database load balancer. This is private. So make sure that you select the private load balancer. Notice how the IP address fields go away, or the options for public IP address go away once you select private. Now it's going to be flexible. And this time I'm going to go to 300 megabits per second. Now, if you keep scrolling down, you're going to find your virtual cloud network. This time we're selecting the private subnet, and you click on next. Now, here's a little bit different because the The policy is going to be round robin. However, the backends, I'm not going to add them right now because if you click add the backends, it only offers the ones that are from compute instances, not the compute nodes of the database. So this is a little bit different because we are working with the Oracle database. We're going to select the appropriate port, which is 1521. And I previously enabled the permissions on the security list of that virtual cloud network on the private subnet. So now I click next, and this is my DB listener. And it's not any one of these ports, not at the layer 7, but the layer 4 one. And it is 15. I want to make sure that that port is particularly healthy because that's the one that my load balancer is communicating with the database. And the error logs is going to be turned off. And that's basically what you need for creating the load balancer. Remember that we still need to add the backend set. And that's why the health check doesn't have a backend set to check on. So that's why you're going to get this message right here that's indicating that it's not complete. So I'm going to pause the recording and wait for this to come back up. And then we will add the backend set. Hello, we're back. As you can see, the database load balancer is operational. However, this message here persists. So if you scroll down, you will see the backend sets. If you click on it, and if you open your backend set, you will see that there's an option for the backends, and currently it has 0. So you add the backends. And here, rather than selecting a compute instance, you enter the IP address of your backend set. So let's go ahead and read that, and we'll retrieve it from here. So this is the first one. Now remember that this is port 1521. And then the weight is going to be 1. So both of them will have the equal weight. Then you add. And then you add the other one. Also, select the IP address. Go ahead and retrieve it from the node. And also port 1521 with equal weight. You add this. And right now it's still pending. Before it had the incomplete status. So the other backend is in the process of being added. So what I'll do right now is I'm going to pause the recording and come back when this completes. As you can see, the overall health is okay. So the load balancer is communicating with the compute nodes of the database over port 1521 with no issues whatsoever. So now the load balancer can distribute traffic across 2 databases. It's on the load balancer policies and health checks. So the policies consist of round robin, IP hash, and least connections. So let's take a look at round robin. So round robin, let's assume that you have 4 servers on your backend set. You have a set of 4. The first request coming into the load balancer is going to be routed to the first server. The second request is going to go into the second server. So on until you reach the 4th server with the 4 requests that comes in. So the 5th request is going to go back into the first server, the 6th into the second, and it's going to go in rounds. That's the round robin policy. Now we have the IP hash policy. And the IP hash policy utilizes an incoming request source IP address, has the hashing key to route the non-sticky traffic to the same backend server. The load balancer routes requests from the same client to the same backend server as long as that server is available. And then we have the least connection policy. the load balancer will figure out which of the backend set servers has the least active connections. And that's the one getting the incoming request. Now, the load balancer poly decisions apply differently to a TCP load balancer than it does to an HTTP load balancer. A TCP load balancer considers policy and weight criteria, both of them. Now, while the HTTP load balancer, if you have cookie-based sessions, then the persistence for requests using the cookie session information. For non-sticky HTTP requests, then the load balancer applies the policy and weight criteria. Now, the health checks. The health check is a test to confirm the availability of your backend servers. And they're activated for the whole backend. The whole backend set, the individual backend server, and the overall load balancer. Now, the load balancer comes with 16 listeners. You're listening. You can configure up to 16 listeners listening for incoming traffic. Some of those listeners might be listening for HTTP. Another listener might be listening for TCP. And the health API provides a 4-state health status. And this is updated every 3 minutes. So what are these 4 states? So it's the OK state. That means that no attention is required because the resource is functioning as expected. Now there's the warning state, and you will learn that that's the warning state because it will be colored yellow when you open your load balancer. By the way, the OK state is colored green. And the warning state means that some reporting entities require attention. Now there's the critical state, with some or all reporting entities require immediate attention. And that's the color is red. And then we have the gray color, which is the unknown state. The health status cannot be determined. It can either be okay, it can be in red. So you do not know what the status is. And to the network load balancer. So the network load balancer provides an entry point automatically to distribute traffic to multiple servers in a BCN and beyond. We'll take a look of what I mean by beyond within this presentation. We already mentioned before in a previous presentation that one of the differences between the network load balancer and the OCI load balancer is that the network load balancer is much better for latency sensitive workloads, and it can provide a running connection in the order of months. Now we have the possibility of selecting a public and a private load balancer for the network load balancer. And obviously the public one will come with a public IP address, and you can balance loads based on layer 3 or layer 4 data. Now let's go ahead and talk about how traffic is distributed to the backend set. So you have 3 options: the 5-tuple hash, 3-tuple hash, and 2-tuple hash. So the number gives away the amount of criteria that the load balancer will use to distribute traffic. The 5-tuple hash, the criteria is source IP and port. Here's 2, destination IP and port, 4, plus the protocol, TCP, UDP, ICMP. Now the 3-tuple hash does not need the port. And then with the 2-tuple hash, it's only source IP and destination IP. So the key differentiators for the network load balancer, you have the option for a private or public load balancer. Now it scales up and down with no bandwidth configuration. This is different from the OCI load balancer, where you have to configure the bandwidth. On newer accounts, it's flexible. On legacy accounts, you have dynamic and flexible. Now you preserve the source and destination IP. Now some concepts for the network load balancer, very similar to those of the OCI load balancer that we previously saw. You have a backend server, which is the server providing the service to the incoming request. Then you group them, and that's called the backend set. You have a load balancing policy, the one that we just described, that tells the load balancer how to distribute the traffic to the backend set. Then you have session persistent through the 5-tuple hash policy. Use a 3-tuple or 2-tuple network load balancing policy to provide session affinity beyond the lifetime of a given session. And then you have the health checks. And this might be catching your eye. Supports HTTP level. Isn't this a network load balancer? Yes, it is for the service. The health check, you can use a layer 7 health check to determine how the servers are behaving. It's up to you to decide what health check you're going to be configuring, and you can have multiple of them. And then we have the listener, which is the entity that checks for the incoming traffic for the load balancer. Now, the public load balancer is internet facing, and it comes with a public IP address. Now, I was mentioning that you can distribute traffic to the servers in a VCN or beyond. Normally, when you're configuring your network load balancer, you will see a drop-down list for the servers that are in your VCN. There's also an option where you enter the IP address in the specific IP address. And obviously that IP address needs to be reachable from the load balancer in the VCN. And they can be reached through the local peering gateway for local peering connections to the remote to a server in a distant region through the remote peering connection, or even outside of OCI via Fast Connect or site-to-site VPN. So the public load balancer will assign a public IP address to the listener. The load balancer is highly available in a region. And for that reason, it requires public subnets to be regional. And that way, if you're in a multi-availability domain, then it will leverage the multi-availability domains to provide the high availability. Needs one private IP address from the subnet. And this is what I was talking about. Ensures high availability and accessibility, even one of the availability domains outage. Now let's go ahead and look at the use case where you have two load balancers in a private network through what we call the bump in the wire. And we call this bump in the wire because you have a third-party firewall appliance. That means that the backend set will be a firewall, and the load balancer will distribute traffic coming from on-premise through this firewall that will make a determination itself how to route the traffic next. And it's going to be routing it to another load balancer, which in turn then reach the backend servers. And I was mentioning that the backend servers can be outside of the virtual cloud network. The firewall has a unique address to leverage source and destination itself, but the routing is decided within the firewall appliance itself. And normally it's a third-party appliance. This method enables the firewall appliance to inspect the original client packet and apply a security policy to it before it reaches the backend set. And it can be applied vice versa, going from the node, the traffic originating from between these nodes to this network load balancer internal and going to your resources. The firewall will make that determination itself. Now let's go ahead and take the key difference between the network load balancer and the load balancer service. One that will catch your eye is the bottom one. I mentioned before that the load balancer, newer accounts, they're flexible and you configure that. And the network load balancer scales up and down with no bandwidth configuration. Now, legacy accounts have the dynamic configuration where you can select between 10 megabits, 100 megabits per second, 400 megabits per second, or 8 gigs. We are seeing the demo on the network load balancer. Let's go ahead and access our OCI console. And here I am. These are the two previously created load balancers that we did on the other demos. And I also have my database, two of them, Oracle database systems. And if you open them, you will see the compute node for those databases. And as you can see, there's no public IP address, only private IP address. So our listener this time on the network load balancer is going to be port 22. This is the second node. Let's go ahead and create our load balancer. So you select the correct type. This type is network load balancer. And let's go ahead and fill in the blanks and make our selections. So the name will be simply NOB. We are selecting a public load balancer because the listener is going to be port 22. And we're going to use the network load balancer to SSH into the node of the database systems. The address type that we're going to be selecting is the previously created reserved IP address. So here it is. We called it for LB demo. Now notice that in the regards with the shape, there's no option for you to make a selection. And this is by design. The network load balancer is always a flexible shape, and the bandwidth oscillates between 10 megabits and 8 gigs. The values for the networking are the correct ones. This is our virtual flat network, and this is the public subnet. Click on next. And our listener is going to be on port 22, as previously indicated, for TCP. So we are going to be very specific and type port 22 for the listener. And there it is. Now the backend set. We need the compute nodes for the database systems. So if we click here, it only lists the compute instances that you create for virtual machines, not the node for the databases. So we will be adding those later once the network load balancer is created. Now the health check policy, because this is a database, I want to make sure that the database port is operating correctly. So I'm going to be using 1521 and click on next. Validate my results or my options and click create the network load balancer. Now, while this is being created, I want to highlight something here. Notice this banner, always free. So this network load balancer is always free. You don't have to pay a dime for it. Every single trial, every single account comes with one always free network load balancer. Here, the status is indicating that it's in the creating state. Now the IP address is highlighting both of them, the public and the private. Now, I was mentioning that the shape is flexible by design because you don't configure it. It doesn't list here that it's flexible. All of them for the network load balancer are flexible. Now you can see that the status is active, the state is active, and the overall health came as okay. So why is this if we don't have a backend set yet? Well, we do have the backend set, but we don't have the backend servers. This overall health is indicating that what we have so far does not have an alarm. And because we don't have a backend server, it's not generating any alarm. So that's why the status is okay. But if you click on the load balancer, we can go ahead and take a deeper dive. Click on backend set. Here still is indicating that everything's okay. But when you click on the backend set, you will see that the status is unknown. And here it is. So it's unknown because there is no backend server. So let's go ahead and add the backends. As previously indicated, we are going to be using the IP addresses. Let's go ahead and retrieve them. Here's the first one. Port 22 is the correct port that we want, and the weight is going to be 1. So here you click add another backend, retrieve the IP address, copy, and paste right here. Now you add the backends, and this will take a little while. So I'm going to pause the recording and come back when it completes. It completed, and now the overall health for the backend servers is okay. This means that our database compute nodes are working perfectly fine on port 1521 for both of them. Our listener is port 22. So we can go ahead and SSH into our load balancer. But first, let's go ahead and retrieve the IP address. Here it is. Copy. And I'm going to open PuTTY. And here's PuTTY. Load. And it's going to land on one of the compute nodes. Let's see which one it is. And here it is. It landed on the second one. If we try it again, it should land on the first one. The policy is the tuple 5. If we open the backend set, And if you open it, it's the 5-tuple hash. So there it is. Let's go ahead and open PuTTY again. That sound indicates that indeed it's the first one. So this completes the demo. These are the topics that we'll be seeing today. We'll see the OCI DNS management, private DNS, and OCI DNS traffic management and traffic steering. So let's talk about the OCI domain name system. So what is it? If I always like to make an analogy with the contact list that you have on your phone, only that this contact list is not only available to your phone, but it's available to all phones out there. So let's do an example of how it works. Normally computers work with numbers, IP addresses, and we covered IP addresses before, but they are hard to remember. 1.1.1.1 is really easy, but when you have 192.168 and you have many of those, then it gets complicated and they're not easy to remember. So example.com is much easier to remember than 192.168. In this case, we're using 1.1.1.1, which is easy, but let's associate. How does a computer knows that example.com is associated with 1.1.1.1? It doesn't. That's why we have the domain name system. It does. And how it works. So if you go ahead and type example.com the very, very first time, your computer will not know. The second time it will know, and it's not going to go through this process. But let's assume that we're talking about the very first time that you're typing example.com. So because your computer doesn't know, it's going to go ahead and ping your recursive DNS server. So what is a recursive DNS server? That's provided to you by the ISP provider. So that's the server that has information about DNS service and mappings, like the phone book, or not the phone book, but your contact list in your phone in your phone. But if it doesn't have that information, then it's going to ping and request that information to a root server. And a root server is a service provided worldwide by the Internet Authority. And basically, there are 13 root servers out there in the world managed by 12 providers. And if the root server doesn't know where that example.com is matched to a particular address, then it's going to ask the top-level domain server. And what's the top-level domain server? That's the servers that manages all the .coms, .edus, .mil, you name it. The international ones, .nl for the Netherlands, .mx for Mexico, .ca for Canada. So it managed that. So it's going to ping and, hey, do you know how to get to example.com? If it doesn't know, then it's going to ask the authoritative DNS. And Oracle is an authoritative DNS. And in this case, the authoritative DNS does know that example.com is mapped to 1.1.1. So it's going to send that information to the top level domain names. It's going to send that information to the root DNS server so they can catch it. And it's going to let the recursive DNS know and the end user know that example.com is mapped to 1.1.1.1. And this happens in a fraction of a second, and you don't even pay attention. So it's really fast service. And that's how DNS works in general. So now the user, the recursive DNS server, the root DNS server, and the top level domain servers know that example.com is mapped to 1.1.1.1. So now we'll see how OCI manage DNS. There's some concepts that are important to highlight. For example, a domain. What is a domain? Example.com is a domain. So the top level domain is .com, and example is a second level domain, and altogether is a domain. Example.com is a domain. Now, what is a zone? A zone is a portion of a DNS namespace. This is where you get example.com associated to you, and then you create a zone so you can add records to it and you can manage the whole zone. A record can be where you actually map it to a physical IP address, 1.1.1.1. You're mapping it, that's a zone. And then you add the www in front of it or the web in front of it. And when you do that, that's within a zone. And then that creates a label. So www.example.com is a label. for example, or web.example.com is a label and they are managed within a zone. So what is a child zone? So example.com, it's the main zone, and then www can be a child zone of example.com that have completely different information that takes you to another place. For example, we have oracle.com, and it will take you to the main page of Oracle. But if you type cloud.oracle.com, that's the login to OCI. So it has completely different information. Resource records allow you to get domain information for a zone. It's like a metadata. We call this the resource record or our data. In delegation of the name servers is where your DNS is hosted and managed. In this case, OCI. You're delegating the service to OCI, and OCI will keep all of that information. So if you want to bring example.com to OCI from a registrar to OCI, you can do that, and it's being delegated to OCI. And OCI, you're going to be creating a zone within that delegation. So this is how all of these concepts work together. So now let's look at the capabilities of the OCI DNS. It's a DNS service under networking that is going to be globally available to you. You can manage your record on DNS, and the service itself is optimized and is highly resilient against outage and attacks. So it's a top level DNS service that you can get from OCI. It's one of the best services in the world. So what are the capabilities that you can do? You can do DNS create and manage zones. Remember, and this is how the example has the zone record. It's associating, it has the name servers. So whenever you're delegating domain into OCI or creating a zone, we'll provide you with these NS servers or name servers that you take to the registrar. In that way, the registrar is delegating to Oracle. You can also create and manage records. So within the zone, you create an A record, and an A record manage your domain and map it to an IP address. You can create on OCI or even elsewhere a compute instance, and then we'll have an IP address, and then you bring in and map it to the A record. If you want to add IPv6, you can also do that and create a quad A record. And you can also create a CNAME record, so you can add an extension like www in front of your record. You can import and upload zone files, so an easy transfer. Rather than creating every single record manually, you can bring the whole file into OCI and migrate zones from elsewhere to OCI and from OCI to elsewhere. And once you do this, you can publish those changes and go live and view all the zones. So next, we'll see private zones. We're creating a DNS zone. We have a domain, and we are going to create a zone for that domain, and then we're going to publish it. So let's get started. We'll start by showing you a compute instance. I created a web server. And this web server is hosted on OCI. It's called OCI Cert, and this is the IP address of it. So if I open another tab of my browser, and if I paste the IP address right here, it should give me this web server that we created. And as you can see, this is not a domain name. This is the actual IP address. So the whole purpose of DNS is to map this IP address to a domain. And let's go ahead and do that. So it's quite easy. You go to networking and find zones. And what we're creating is a zone that will have many records, and we'll create 2 of these records. So let's go ahead and create a public zone. We'll deal with a private later. What do I want to call this zone? There's an actual live domain name that we're using, and we're doing it manually. We don't have any file to import from in this case. So I call this domain name is OCI cert.me. So it's a motivational domain for your certification. And it's in my caster compartment, and it's the primary DNS zone. So it's created, and when we create a zone, it's going to give us some records called the name server records that we need to take these records to the registrar where we purchase our domain name so they can point to Oracle. That's the whole purpose of the name servers. And these are the 4 name servers, 1, 2, 3, and 4. And this is the start of authority record. So we need to add a record because we have an IPv4 address. We're going to select the A record. And this is optional. I will add the www in front of it. And here I'm going to unlock so I can enter 30 seconds for the time to live. And then what is the IP address? So I need this IP address right here. And I'll paste it. And there we go. We have an A record. Nothing will happen unless we publish. So let's go ahead and publish the OCI cert. And we're publishing it. So you will think that if I come right here and enter www.ocicert.me, this will work. Let me close the server. So it's been published. And let's go ahead and click. And as you can see, it's not working. And you already saw the registrar. So what I'll do right now is I'm going to pause the video. I'm going to take these records to the registrar and configure it to completion. And once I do that and it's published, you will see this DNS record working. So I'll pause the video right now. Hello again, we're back. I have introduced that change into the registrar for that domain. And if we open a new tab, and if I type www.ocicert.me, we'll get that page. As you can see, now I'm using the domain name, and ocicert.me is a lot easier to remember than this IP address. So this concludes this lab.
So now let's cover private DNS. It's very similar to public DNS, only that is applicable only to your internal resources, to your virtual cloud network privately. You might only be running the DNS privately in a domain name that is not accessible over the internet, but it is over your private resources. You can also have a split horizon. What is called a split horizon is basically having the same domain or be accessible privately and publicly. You can have a private DNS going to example.com and a public DNS going to example.com, for example. That's what we call split horizon. And the private DNS service will allow you to connect to on-premises resources. With private DNS, you can create what we call a listener and a forwarder. So if you want to tie your DNS that you have on-premise to OCI, the forwarder, if you want to reach on-premises, the forwarder will forward that request to your on-premises DNS. If from on-premises you want to connect to your resources on OCI, then the listener will be listening for these requests coming in. And once they do, they'll match it and send it to your resources. So can interconnect DNS between your on-premises and VCN. So that's basically how it works. So these are the main components. You have private DNS zone, private DNS views, and the private DNS resolver. And you can get to private DNS from the DNS section of networking or from the subnet itself. You have a resolver, you click on resolver, and you get to the private DNS console. So now let's talk about traffic management or traffic steering. Basically, here you set a set of policies that will allow you to manage or steer your traffic based on the answers to those policies. Traffic management is an added service to your DNS service from Oracle Cloud Infrastructure. So when should I use DNS traffic management or traffic steering? So these are some common use cases. Basically, a failover is one of them. If you want to have an active standby, maybe active on-premise, standby on Oracle Cloud Infrastructure. And in case the active one goes down, then DNS will kick in and make your service available through your resources on OCI. Cloud migration, if you're migrating from on-premises to the Oracle Cloud Infrastructure, then you might have traffic steering that slowly steer based on your needs. And you can also have a load balancing service where you have certain percentage on resources elsewhere outside of OCI, and then some services on OCI. Hybrid environments, very similar, except that this is more like a permanent basis. You can have certain percentage of your traffic going to your on-premises infrastructure and a certain percentage going to OCI. Worldwide geolocation steering. This is in case you want to serve content to other countries where they speak a different language. For example, in Germany or in France, if you have users from those regions, then they can, once they go to the same website that your users in the US or Canada, they'll get the content based on their location. They'll be presented with the language that they speak and are more familiar with. Now, canary testing is very important because this will allow you to roll out services and slowly start testing to a percentage of your users. Let's say 5% of your users will get this new content and the 95% will get the approved, tested, and approved service. And once you're satisfied with that 5% comments or output or level of satisfaction, then you slowly start releasing that service to a greater audience. Now, zero rating service, this is where you want to manage your traffic originating from an autonomous system number. So now let's go ahead and check the steering policies that you have available on traffic management. So load balancer will balance the service based on the percentage that you specify. You also have failover in case one of your systems goes down, then it will fail over to or switch over to the service that will remain active. Geolocation steering based on the location of your users. And this is one steering policy that you can implement for those services that we spoke about. The ASN steering based on the originating autonomous system number from the service provider or based on the IP prefix steering. We're doing traffic management. And as you can see, I'm in my San Jose region and I'm in my Castro compartment. So if I go to networking, you will see that under DNS management, we have traffic management and steering policies. Before I go there, let me go into my Frankfurt region. And I want to show you that on my compute instances, I have two of them. I created a server, pretty much a web server that is a replica of what I have here in the US. This is certification this is my web server that says hello OCI certification candidate. The German version says the same thing, but in German. And what we're doing with this lab is we're steering traffic based on geolocation. That's what we're doing. And the other compute instance that I have here, this is a Windows machine that we can log in and basically open a browser and go to the same URL that we allocated for this. So if you go to the URL on Germany, it's going to be displaying this information. If you go to the same URL in the US, it's going to be displaying information in English. So let's go ahead and get started. So go to networking, traffic management, steering policies. And let me go back into San Jose. I want to create my rules in the San Jose region. So we'll click on create traffic management. And these are the options that you can steer traffic by load balancer, failover in case one goes down. Geolocation is the one that we're using. And I'm going to call it a name. I'm just going to call it Geo URL. I'll stick with the recommended time to lift. This one is hard-coded, so we'll leave it as it is. Now here, I'm going to call this one USA.
And the answer will be the same, USA. Now, what type of record am I going to be using? I'm going to use my A record. So I need this address right here. And I'll enter it in the appropriate field. Now, in case this one fails for any reason, rather than having the fail version, probably this is optional. You don't have to do this. In this case, I decided that I'd rather have them seeing something in German, that failed version. So I'm going to enter this one, enter pool 2, and I'm going to call this Germany as well. Germany. And also an A record. So now I am creating the policy, but before that, I need to provide the location. So this is what I have right here are the settings, and this is the geolocation of the user. So I want anybody in North America to select, and then my pool is going to be USA, first option. Second option is going to be Germany. And I'm going to add another rule. And now this time my geolocation is going to be Germany. And because we have many countries, let me start typing. So here it is. So this case, my geolocation option 1 is going to be Germany and option 2 is going to be USA. I do want to create a health check. I don't have one, so I'll create a new one. And I'm going to call it Keep Alive. So every 30 seconds, it's going to be doing an HTTP request to those servers. And if they reply, then they're fine. If they don't, then it will indicate that there's problems, and it's going to switch over and apply that second option that we have over there. Attached domain. So remember that on the DNS, we created a customized domain. That domain is ocicert.me. So I'm going to be creating a subdomain on top of it. So it's going to be world. So what this means, if you click here on this little I, rather than if I'm using example.com, in this case, I have ocicert.me. So if I use the subdomain, it will be subdomain.example.com. So in this case, it's going to be world.ocicert.me. This resides in the caster compartment, and this is the zone that we're creating. So every time that anybody types world.ocicert.me, if they're in the US, then it will display the English content. If they're in Germany, it will display the German content. So let's go ahead and create the policy. Means I don't have anything global. So outside of those two regions, it's going to be select based, my first option. So now that the policy is created, before I go and test it out, I want to show you something. We went to networking to start managing our traffic management and steering policies. We created a health check, and that doesn't reside within the networking. It resides here under identity and security. Remember that we call it Keep Alive. So here, not identity and security, I'm sorry, observability and management. If I go and look for health checks, you should see the Keep Alive health check that we just created, located right here. So now let's go ahead and test this out. I'm here in the US, so I'm going to type world.ocicert.me, and there it is. So it's detecting that I'm in the US. I'm physically located in the US. If we go back into my compute instances right here, and if I select instances, and then if I change this to Frankfurt, Germany, you will see the IP address of my Windows machine. So 166.203 is the last octet. I'm already logged in. And here it is. You see that this is that compute instance. If I open my browser, and let me open a new tab, or actually let me highlight this, and here we go. So I'm going to type world.ocicert.me, OCI cert.me, and you should see the German content. And there it is. So this concludes this lab.
So now we'll see the inter-region latency, and this is a live demo. We're actually going to go into tenancy and show this. But before we do that, I wanted to show you how you can retrieve the latency that you have from one region to the other. We publish this and make this available to you every 2 minutes, I should say. But what you're seeing is the average of the last 5 minutes that went by. And these numbers doesn't represent your actual tenancy. This is for the overall Oracle Cloud infrastructure. So this is intended for planning purposes only. And the whole purpose of the lab is so you can see how close these numbers are if you test the latency from resources in your own tenancy going to another region and you're also in your own tenancy, or into another tenancy, someone else's tenancy. You can do a ping for those resources. And this is exactly what we're going to be doing. Now you can see that right now in the sample that we have, we're using the 2 regions in Australia, Sydney and Melbourne. And you can see that latency is sub 15 milliseconds if you ping that from Melbourne to Sydney yourself. And you see that we use the keys, and these keys represent the airport of that city. So whenever you see an acronym that probably doesn't make sense, for example, Brazil, we have GRU, and that's the airport code for the Sao Paulo region. Right now, we're going to get our hands dirty. We're going to go into the OCI console and do exactly what we have on the screen. We're going to do a remote ping connection that goes from Melbourne to Phoenix, and we're going to ping resources that are sitting in Melbourne, ping resources that are sitting in Phoenix. So to wrap up, let's go ahead and do this right now on the console.
This is the console, and we're doing the inter-region latency testing. And let's go ahead and find where that is. So you click on the main menu, you go down to networking, and select here the last option under networking, inter-region latency. And remember that we're testing resources going from Melbourne to our Phoenix area. So in order to find that, you can either click here. Actually, it's better to do it in the top row. So I find Phoenix right here. And then I search for Melbourne. And as you can see, here it is right here. So it's 181 milliseconds. And it will give you all the results for every single region, connecting either to Phoenix in this case. Right here, you can see the latency to Amsterdam. This is Brazil. And here's Melbourne, which is the one that we want. And the same thing for Melbourne. Here you can see the sample was going to Sydney. So Sydney should be around here. So you find it in Sydney, and then you find Melbourne. And it should be right here, and it makes sense. It's going within the same country, 13 milliseconds. But when you're going from Phoenix to Melbourne, then it's a little bit longer, the distance. So it's 181 milliseconds. So let's see if that's real. What I did is create resources in both regions, and we can view these resources with the network visualizer. Let me change this is the correct compartment, the training compartment. And you should see the Melbourne going to Phoenix. If I change this to Phoenix, then you will see that from Phoenix, we're going to Melbourne. And that connection is already established. I already created the routes. And as you can see in Phoenix, I have another VCN that is completely isolated, but this is the one that we care about, Phoenix VCN, going all the way to Melbourne. So I created 2 compute instances. Let's go ahead and take a look. One in each region. So I'm going to ping from Melbourne into the private IP address of my Phoenix compute instance. So let's go ahead and copy this. So it's 172.29.0.62. In the compute instance in Melbourne, I actually need the public IP address of it. So I can SSH into it. Let's open this. Brand new connection. And now, I don't know if you remember the IP address of my San Jose one, but not San Jose, but Phoenix. And it's 172.29.0.62. And the reason why we're doing this is so we can verify that those numbers are accurate. And you can see it's very close, within 5 milliseconds of it at 176. So again, that's for the numbers that you get from the inter-region latency. They represent the overall backbone infrastructure. They're not specific to your own account, your own tenancy. So here it is, 180. That's the published ones, but when you actually test them, it's a little bit better on your own environment. So this concludes the lab.
Oracle recently introduced a network visualizer that allows you to see your resources in a particular region in your tenancy. You can segment those resources by subcompartment, or you can see the whole tenancy, the whole networks that you have in all of your tenancy. And this is how it looks like. We'll do a demo, but this is how it looks like. So you can see that we have a VCN to the left, and we'll go to each one of these items and what it represents. But what we have to the right are two VCNs, and you see these little circles on the VCN. Those are the gateways, and they're all connected to a DRG that has remote peering connections, and it has a fast connect. So this is a broad view of your connectivity resources that you have, but you can also dig a little bit deeper. And as you can see, we have a highlighted VCN. So when you do that, that means that you're going to go in and see more resources. And we'll see that shortly on a slide and also on a demo. So we'll cover all of these. The other resources can be a load balancer. It can be a VPN going into on-premises. So the visualizer provides you a diagram of your implemented technology of all the VCNs in a selected region of your tenancy. And what you can see are DRGs, VCNs, customer premise equipments, and all the gateways that we have. And also what we call the cloud network topology is the subnets, the VLANs, and actually even the routes. So these are the symbols that I was talking about. You see the big circle is the DRG. The hexagon is the VCN itself. And we also have our gateways to the right, the remote peering connection, NAT gateway, the service gateway, internet gateway, and all the gateways. And resources outside of the region, for example, when you're doing a remote peering connection, because it's only tied to one tenancy, you're not going to see the other end unless you go into that region and apply the network visualizer to it. So this is an example. This is the network view, but if you want to get the cloud view, if you click and select a resource, then to the right, you're going to see more information, and it's going to provide you with links. So if you want to see the default route table for this actual VCN, you just click on the link. If you want to see the subnet of this VCN, click on the link. If you're going to get additional resources, so you have these two options. Open the additional details, or if you want to visualize what you have inside the VCN, then click on the go to the VCN map. And it's going to give you something like this. In this case, you can see the routes, that particular subnet that we have right there. It has a route to the internet gateway, and it's the 0.0.0.0/0. And then we also have a route that takes you to the dynamic routing gateway. And this subnet doesn't have a route to the local peering gateway. It's the other subnet down below. Now you see button right now or a switch that is turned off. It's not turned on. It says the persist is the permit the persistent of the information. So if you turn this on and if you switch to the other subnet, this route will persist and you are going to be able to see it. So let's go ahead and get our hands dirty and do a demo.
Network visualizer, we're doing a hands-on lab. And because this is a lab, this is the only deck that I have. Let's go ahead and get our hands dirty. Here is the console, the OCI console. And as you can see, I'm in the US East Ashburn. And in order to find the network visualizer, you click here on the main menu, go to networking, and immediately right there, one of the options, the main options, the third one is the network visualizer. If you click on it, if you were previously on a previous session on a particular compartment, it's going to open the visualizer for that compartment itself. Notice how we have the include child compartments, and I did in the checkbox. The checkbox is going to include not only this resource that I have on my main compartment, but also other resource that I have in the child compartment. So let's go ahead and click on that. And it's going to take a little while, but it's going to leave that network that we saw, plus the ones that I have in other compartments. And I believe I only have resources in a compartment called interconnect. And as you can see, if you recall from the lecture, the orange circles represents DRG, dynamic routing gateways. I have 2 dynamic routing gateways and 3 virtual plat networks. One of the virtual plat networks has connections to 2 of the DRGs. And this DRG has 3 remote peering connections going to other regions. This is Phoenix, this is London, and this is Amsterdam. And I also have a virtual circuit. This DRG has a VPN connection. And if you had a greater network layout, more networks, more VCNs, and you were looking for a particular resource, actually here we can do it here. If I start typing, for example, CPE, it will list all the CPEs that you have, so you can go ahead and select, and it's going to zoom in into the particular resource that you click on it, and you can see details on it. You can go ahead and further take a deep dive. You can also go ahead and refresh, and the refresh will basically reload everything from the start. So it's basically bringing the compartment, all the resources in that compartment plus the child resources, because I'm doing a refresh. So this was hard coded. I can go ahead and uncheck it right now, but I don't want to do that. And here it is. So what I want to highlight right now is that if you click on a particular resource, you can immediately take a deeper dive into the resource belonging to this particular virtual plat network. Here I can go ahead and see the VCN itself. I can go ahead and see the route table so let's go ahead and do that. And it opened another tab. So you still have your visualizer on the first tab, on the main tab. And then the second tab, it brings the resources. So as you can see, I have route tables going to, this is going to the internet gateway. And this is going to, remember those remote peering connections? It's going to those 3 remote peering connections. This one doesn't have a description. This one's going to London, and I call this is the one. So that might be one of, I don't recall why I name it this way. So it is very important that you put something that is descriptive. At least I know that this is the one going to London. And if I want to go back, I just go back into my second tab, and this will remain open unless I close it myself. But I want to highlight here is that if you keep scrolling down, you can go ahead and open a subnet map. So because I was in that particular virtual plat network, now I'm taking a deep dive into the VCN itself from the visualizer perspective. I'm going to see the subnets in that VCN. And as you can see, I have 2 subnets, one that I call the lone subnet. So it was supposed to be the one and only subnet in this VCN. I have a second one, and I call it delete me. So because the whole purpose is that this is the one that is going to be the lone subnet. But what I want to show you now is that this one, you can zoom in with your mouse. This one, zoom in and zoom out. This one is going to the service gateway. And if I click on it, the route to the service gateway is going to be highlighted, and it gives you details, all IaaS services in Oracle Service Network. So it's not only going to object storage, but to all the services that the Oracle Service Network presents. And remember the persistent button here? I don't have it on. So if I go into this other subnet, this route is going to not be highlighted anymore. Now I'm only seeing the routes from this subnet, and one of it is going to the internet gateway, remember? And the other route is going to the dynamic routing gateway, the DRG. So if let me go back to the subnet, and if I click on the persist routing information, and now if I go to the second subnet, the route will remain highlighted. So this is what this button does. So go ahead and play with your own resources. And this concludes the lab. I think it was helpful, and it will serve as an introduction to your Oracle Cloud Infrastructure, Virtual Cloud Network resources from the visualizer perspective. We are seeing version 6 of the Internet Protocol. We're seeing an introduction to IPv6. So what is IPv6? Why do we need IPv6? What consideration should I take while I plan IPv6 in Oracle Cloud Infrastructure? So IPv6 is a new addressing scheme, not so new, but it's a new addressing scheme that has been implemented on Oracle Cloud Infrastructure. And we need that because basically we have run out of IPv4 addresses. And when we say we, I mean the whole infrastructure, not Oracle Cloud Infrastructure. The whole internet has run out of fresh IPv4 addresses. So when you launch a compute instance or a load balancer on Oracle Cloud Infrastructure, you get an IPv4 address, one that is new to you. So what does that mean that we have run out of IPv4 addresses if I'm getting one for my compute instance or my load balancer or basically any new service that we launch with Oracle Cloud Infrastructure? And it means that that IPv4 address has been assigned to Oracle for Oracle to distribute among its customers. A new entity out there will not be able to get a fresh batch of IPv4 addresses. Basically, the Internet Corporation for Assigned Names and Numbers, the ICANN, will assign an IPv6 prefix to a new entity requesting addresses. There are no more IPv4 addresses. So that's the reason why we need IPv6. Think about it. We have many compute instances, many mobile phones, many SIP phones, IP phones, many IP cameras, many medical devices. All of these devices are requiring IP addresses for them to reach out to existing services or for them to launch new services as well. If somebody needs to send you a message on mobile network where you're leveraging the internet, then you need an IP address for that mobile device. And there are many devices out there that require IP addresses, and IPv4 has simply run out. And because of this, new governments or governments throughout the world are requesting that any new service is compliance with IPv6. So because of compliance and because of the need is that we're launching or that we launch IPv6. And the benefits, basically you have lots and lots of IPv6 addresses. Because of that, you are going to get more efficient routing. How is that so? If you think about it, when you're launching, let's say, a subnet and you put that in a private subnet, if you need to go out into the internet to retrieve a patch or upgrade the software of that private subnet, you need a NAT gateway. And you're translating, basically, because you're translating, you're taking of compute resources, and a router right there will need to translate from the private IPv4 to the public IPv4. And that will take longer than if you didn't have to do that. With IPv6, because we have more than enough IPv6 addresses, then you don't need to place a resource on a private subnet anymore. You can do that for security purposes, but it doesn't have to have two addresses, one private and one public. Think about it. At home, you have a network, a local area network. Your own provider provides you only with one IP address. That's a one public IP address. That's all you get. Most of us do. One public IP address. But you have many computers. You have mobile devices. You have printers. Maybe you have a SIP phone. Maybe you have cameras. All of those are in the private space. And when they translate to the public space, they use that one IP address. That's network address translation. With IPv6, you no longer need that. And that provides you with more efficient routing. And then that will allow you to enforce better security. And we'll see that in closer detail shortly. So the IPv4 uses a 32-bit address. Remember that we have 4 octets, 4 bytes, each one of them being 8 bits. Because you have 4, that comes to 32. With the IPv6, you have 128-bit addresses. And they're not decimal, they're hex. So remember when we were doing the DNS lecture and how we were saying that it's easier to remember an alphabet-based domain name other than a 4-bit, not a 4-bit, a 4-byte address space? Now we have more complicated one, and it's a whole lot harder to remember that long string than it is to remember an IPv4. So it's much easier to remember a DNS, which will remain. It will remain unchanged regardless if you have an IPv4. Remember, we have the A record for that, or not, or an IPv6. We have the quad 8 record for that. Now, going back to IPv6, the address on top and the address at the bottom, they're the exact same address. Basically, we're trying to simplify the reading of it because we have too many zeros in between. And we represent those zeros with these 2 columns right there. Now, an IPv6 address consists of different parts. We have the site prefix, the subnet ID, and we also have the interface ID. But don't worry, we will not quiz you on the tests. You don't have to identify from an IPv6 the subnet ID or the site prefix. Now, the IPv6 addressing model, it has a specific scope in which the device is defined. A scope is a topological area within the IPv6 address, and this can be used as a unique identifier for an interface or a set of interfaces. The scopes are global, site local, and link local. Now, considering IPv6 planning in the cloud, the best practice is don't rely on NAT. You're not going to be needing NAT for IPv6. Now, in this case, in Oracle Cloud Infrastructure, you're going to get the best of both worlds. You are going to get IPv4 and IPv6. Actually, when you launch a subnet, or a virtual cloud network, you will have the availability to select if you want to get or provide to the resources in that subnet IPv6 capabilities. Now, because we don't need NAT, whenever you get IPv6 on a virtual cloud network, you will always get public facing IP addresses. Your prefix that you select will always be public. But if you make a subnet, if you label it private, it will not allow you or will not allow any resource in that subnet to go out into the open internet, nor any resource in the open internet to reach your private subnet, regardless of the fact that the IP addresses are public. Think about it. Normally we use in a private subnet, we use the RFC 1918 address space, the 10.0.0.0/8, the 172.16.0.0/12, or the 192.168.0.0/16. By the way, the /8 and the /12, that's the RFC 1918 compliance. We only use /16. But there's nothing stopping you from using a non-RFC 1918 in your private subnet. You can use a public CIDR if you want. The only drawback from doing that is that if a compute resource in that private subnet wants to reach a public resource in the internet that has the same IP address, it will not be able to do that. That's why we encourage you to use the RFC 1918 all the time. But there's nothing stopping you from doing that. There's a customer actually that uses, for their own reason, in a private subnet, their assigned public CIDRs. So in the same way, when you get an IPv6, it's going to be public by nature, but the label that you put on your subnet will determine if the resource in that subnet will be able to reach the open internet or not. And again, we leverage the best of both worlds. Having a dual stack IPv4, IPv6 will enable us to continue offering IPv4 services, even if the resource in our virtual client network is leveraging IPv6. And we'll see an example of that when we go and explain the routing mechanisms or the deployment mechanisms. Right now, we're seeing the east-west. East-west means within the Oracle Cloud Infrastructure, going from VCN to VCN, or going east-west means not accessing the internet, basically. Yes, communicating only within resources. And as you can see, right now we have a virtual cloud network that has a /16 IPv4 CIDR and a /56 IPv6 prefix. And then on the subnet level, it's optional if you want to provide IPv6 support for a subnet or not. As you can see, subnet A, subnet D, they both support IPv6, but the other two do not. Then you place your resources on your subnets. And as you can see, the load balancer has an IPv6, but the subnets do not in subnet C. And the load balancer is going to be balancing between those virtual machines. And whenever you try to reach the resources, the load balancer, you're going to be reaching it through IPv6. However, the load balancer will be communicating with those subnets through IPv4. And that's what we call east-west. And now the virtual machine in subnet A will communicate or can communicate with the load balancer through IPv6, like that. Now we can go ahead and implement another virtual client network and use local peering gateway. Now you can use the dynamic routing gateway if you prefer to do so. But in this example, we're using the local peering gateway. And now you can communicate with resources on the other virtual client network, either through IPv4 or IPv6. In this case, is through IPv6 because that's the destination that we have on the route table. Now, remember that the load balancer is IPv6 and the backends are IPv4. And that's the way we support our resources at this point in time. In the future, we will be allowing the load balancer to communicate with the backend servers through IPv6. Now, north-south means that we have access to the internet, and you are going to be able to enable IPv6 on your resources and communicate to the open internet from the internet gateway to any IPv6 supporting service out there in the world outside of Oracle Cloud Infrastructure. As you can see right here with the tables, we have a route specifically for IPv4 and a route specifically for IPv6. We are seeing an IPv6 demo. So you can see I'm logged into my tenancy and I have 3 different views. Right now we're seeing an OCI compute instance. And immediately you can see 2 IPv4 addresses, one of which is public and the other one is private. Now let's go into the other tab. And on this view, we have a virtual cloud network. And here you can also have some addressing information, one of which is an IPv4 CIDR block. You can see it right here, a /16. And then to the right, you will see an IPv6 prefix, /56. So that means that this virtual cloud network is enabled for IPv6 addressing. Now, on the third view, you see that I'm in my DNS zones, and I have a zone with a record that we've been using all along. We used this one way back when we were doing the Cloud Architect Associate training. So let's go ahead and take a look. If we open it, and you might recall from previous lessons, I mentioned that this record, this domain name, is mapped to an IPv6 IP address. We have a quad A record against an IPv6. And as you see right here, if you see there's no A record, there's no IPv4. So if we open another tab and go to OCI cert.me, let's go ahead and do that. .me, and you will see that the domain is mapped to a compute instance that has an IPv6 IP address, and it is this compute instance right here. If I open it and I navigate on all the details that it will display for us, you will see that we have the public IP address, the private IP address, along with other information like the image and the virtual cloud network that it belongs to. And we even have the fully qualified domain name. Here's the virtual cloud network. Here's the public IP. This is the private IP. And the IPv6 address is nowhere to be seen. Not in this view, but if you scroll down, you will find the VNIX section. And if you click on this link, you will see all the VNIX that are attached to this compute instance. So far, I only have one, which is the default one. And if I open it, you will see that I have two sections for IP addressing, one of which is IPv4, and the other one is IPv6, which is the one that we're addressing right now. So if you click on it, you will see the IPv6 address. And as you can tell by this button, it was manually assigned. Now pay attention to this last block, 7F48. If we go back into my zones, you will see that this is the block, 7F48. So let's go ahead and take a look at the virtual cloud network first. This is a compute instance. So the virtual cloud network, here you can tell we have, again, the IPv4 and the IPv6 addresses. So if I click on the VCN itself, you will see here it is, the /56 prefix. And then we have the subnet. And the subnet is a /64. If you open it, I want to show you something. Once you open this, you will see the security list. And this is what I want to show you with detail. Let's scroll down and see all the rules that we have in it. And notice how I have a TCP pointing and making port 80 available to everybody. But notice that this is a typical IPv4 way of addressing. Now, down below, we have the same port 80 also available to everybody. But now we are specifying this in IPv6 format. So we can leave the IPv4 rule. If we remove this one, this will no longer work. So I'm going to refresh, and you can see that it renders. So if I go back and remove this rule, which I will, is removed, the effect takes place immediately. So now if I do a refresh, it will no longer render. It's going to go searching for it until it times out. So what this means is that whenever you're creating and dealing with IPv6, you have to be very careful with your security list and enable these services that you want for IPv6 as well. So let's go ahead and add an ingress rule. And for port 80, here I specify the source, and it's indicating that you can specify the source in IPv6. And then all you have to do is specify port 80. And it's as easy as that. Now let's go back into the compute instance. And actually, I was going to create a compute instance, but first, let's go ahead and create a virtual cloud network. VCN. So you can see how easy it is to create an IPv6 enabled VCN. So I'm going to call this IPv6 VCN. And it's going to be in this compartment. Now I need to specify you cannot have an IPv6 only resource or subnet or virtual cloud network. It has to have either only IPv4 or both IPv4 and IPv6. So I'm going to specify my IPv4 CIDR. Here it is. And now I'm going to enable this to IPv6. And that's all I need to do. And randomly it's going to allocate for me an IPv6 prefix /56. And you will see it right here. No, actually it is right here. I was looking at the virtual cloud network already from the inside. If I want to create a subnet, I have to specify the same thing. So I'm going to call this IPv6. Now here, I will specify if this is regional or availability domain specific. So that doesn't change. Here, I will paste my CIDR block. In this occasion, it's a /24. And now I'm going to enable my IPv6 CIDR block. And because we already have a /56, obviously the subnets need to fall under that prefix. And here it's giving me the option to specify this range and this block. So the range goes from 00 to FF. And they have an example, 7E. I will select 6E, just to make it a little bit different from the example. And that's all you need to do. Create the subnet. And it's doing it. And now here is the IP information, IPv6. So now let's go ahead and create a compute instance and see how you do that. How you enable the compute instance to have an IPv6 address. So first, it doesn't change. You give it a name. Then you leave everything as you normally do. Here, you don't change anything. You still select your availability domain. You still select your compartment. You still select your image, your shape, your network. In this case, the one that I just created. Same for the subnet. I'm not going to be adding any SSH key as I will not be logging in. And now you go ahead and create. Yes, create the instance anyway. So starting to build your compute instance. And here's the details. It's provisioning. So if you scroll down here, you go back to the VNix. You select the default one. And then you scroll down to the IPv6 link. And assign the IPv6 address. And as you can see, it's giving you the first part of the IPv6. And then if you design your own network and you know the specific address that you want, then you can go ahead and enter it. In this case, I do not. So I'll leave the DHCP server, assign me one. And I'm going to go ahead and click assign. And here it is. This is my IPv6 IP address assigned to this compute instance. And this basically covers demo.
Now you can bring your own IP to OCI, BYOIP. So you can move, it's not an IP address, it's an address space, basically a /24 all the way to a /8. So with a /8, You can have a huge capacity of IP addresses of your own that belongs to you. And IP addresses are applied as reserved IP addresses, not ephemeral, but you're going to be actually, they're yours. So you're going to be reserving them for your own resources, like a load balancer, like a network address translation, a NAT gateway, or obviously your compute resources. So they're managed through IP pools. You can go ahead and create your own pools where we're going to be pulling, your resources are going to be pulling those IP addresses from. And in order to bring your IP to OCI, there's a whole workflow that you need to go through of them. So the first step is to create a customer. You need to create a bring your own IP object. This object is a representation of your IP addresses. And this is the first step that you have to take. And we're going to generate a token for you. And you take this token to your provider of the IP addresses. And once you have that, then you're going to be able to transfer those IP addresses, that CIDR prefix or that CIDR range to OCI. And once you do that, then they're under your responsibility. You're going to be the one managing and administrating and dealing with it. So again, you can assign this to a NAT gateway, to a load balancer, and to any compute resource that you create. And you're going to be managing the prefix and all the advertising. So bring your own IP means that you manage it.
On BCN flow logs, this is actually a demo. Flow logs is a subset of a bigger topic called observability and management. So this is a preview of what you are going to be seeing on that topic. Logs is part of it. When you have, or you want to troubleshoot, the traffic going into your virtual cloud network, you can use flow logs. So each instance in a virtual cloud network has one or more VNICs, virtual network interface cards. And the virtual cloud network service utilizes security rules, meaning security lists or network security groups, to determine what traffic is allowed through a given VNIC. So to help troubleshoot this traffic coming in and out of the VNICs, you can set up the VCN flow logs. So flow logs record details about traffic that has been accepted or rejected based on these security rules for your VCN. So let's go ahead and take a look, the bigger picture. So I'm going to go into the console. And as you can see, as I was explaining, under the main menu, you have observability and management. And we will cover all of these topics or the key ones for security. Right now, this is a preview on logs and log groups, which is the service that you launch for VCN flow logs. Basically, here I have the login preview. And as you can see on the service logs, VCN flow logs is just one of them. This is the complete list of the service logs. And you can have for networking, you can have VCN flow logs, load balancers, and there's a couple of other services coming or that are being considered for future use. So managing your logs, including the VCN logs, you need to work with logs and log groups. So let's go ahead and take a look at the console. So there's two ways of enabling the VCN flow logs on your virtual cloud network. One of them is going here to the logs and enable the service log. Then you select your resources. So from the service logs, you go and scroll all the way down to virtual cloud network. And you will see that is the subnet of the virtual cloud network because the compute instance, the VNIC and the compute instance ties to the subnet that belongs to the virtual cloud network. So this is what we're selecting. Now, what type of resource? In this compartment, I have, I believe, 2 VCNs and several subnets. So in this case, I'm going to be selecting, I do have a fast connect going to on-premise. So I'm going to select this one. And then the log category. Remember that we need to select, in this case for VCN, we have flow logs. And then the log name, I'm going to call this ICMP. Why? Because I'm going to ping resources to see the result of enabling these flow logs. Each log works together with log groups. And here it is. This is the one. Log groups are logical containers for organizing logs. Logs must always be inside a log group. So that's why we're entering a log group. But in this case, you'll see that I don't have a log group created. So let's go ahead and create a new one. I'm going to call this also ICMP. And that's it. So now I have my log group, and this is the logging retention. So I'm going to retain this for 2 months, a little bit beyond the recommended. And then now I can enable my log. And it's going to take a while. So while this is being provisioned, let me go and show you how else you can launch your log and log group. So you go into networking, virtual cloud networks, and then you will see that I have a couple here. I have 3 virtual cloud networks. This one is the one that is currently attached to the dynamic routing gateway that has the fast connect to on-premises. And that's the one that we utilize to enable logging. And here, if I click on logs, you can see that this one already provisioned. This is the one that we just created over the observability and management path. And from here, you can view the logs that we already created, and you can use this path for creating additional logs. For example, you can go ahead and go into the log group. Here you can edit the log, or you can disable it. You can also disable it on this button right here. However, if you want to create additional logs, you can take advantage of this log group ICMP, which is the name that I gave it. And then it will take you back to observability and management. And then you can go ahead and create a new log, enable a service log. So let's go ahead and take a look at the service log that we created and see what has it done since we created it. So immediately you can see that these are some events that have been happening to that compute instance during the last 5 minutes. And these are the events. So if you click on it, you can see that there are some rejects going on for port 443. And it's TCP. And then for further troubleshooting, you can see before and after what was there. So before and after. So here it is. This is the before. And then you can expand it. Now you can get very interesting insights on information that you get from the logs. So here you can go and visualize and create your stack bar. And my preference is Pi. So you can see it's 100%. I don't have much activity, but if I can go ahead and select and group my information by, and I'm going to select source port. No, not the port, but the data protocol name. So what traffic is going through my instance? And you can see that there's some ICMP going on, and UDP and TCP. Now let's log into a compute instance. So I'm going to open one of my compute instances. I need to retrieve the IP address. So this is the one. I'm going to select the private IP. I know it's 10.20.30.40. But this is the one that I want to log into. And let me bring my putty. And going to ping. This is what I have at the other end of the fast connect. And you can see it's really fast because it's 1.2 2 milliseconds. So it is pinging, and within 5 minutes, that ping information should be, if I leave it running, should be greater than the TCP and UDP pi. So I'm going to pause the video shortly so we can give it some time so it continues pinging, and I'll come back in like about 2 or 3 minutes. Hello, we're back. We actually paused the recording for a little bit more than 5 minutes. We went over an hour, but we're back, and we are going to see how our ports are behaving with logging analytics. So here you can see that these are the events that happened during the last hour. So let's go ahead and change this because it's been more than an hour. I'm going to put the last 3 hours. And now I want to visualize this in my Pi. And before we were at 29% ICMP. So as you can see, this is gaining ground. Let's remember that in order for me to ping, I need to SSH into the instance, and that's port 22. So that's been active along with other activity. If we go back into the logs, you'll see that I have, in fact, more TCP activity than I do ICMP. This is an ICMP packet right here, so I can go ahead and expand it. And this one is actually, I have a packet going also from 10.20.30.10. Besides that 40, I also have 10. And so you can get a lot of information from it. And of course, this is only using the tools within BCN flow logs. Logs are part of a larger family that we call observability and management. And you can see logging analytics, so you can get more insights and distribute your logs greater and get more information, not only from BCN flow logs, but also from other resources. So this is a topic that we will cover in greater detail further ahead. Now, the BCN flow logs, let me go back to, want to show you something regarding the BCN flow. You see this service connector right here? So with it, you can go ahead and create connections to other resources that will allow you to retrieve and order your information, not only with the BCN flow logs or observability and management logging analytics, but also with Oracle Management Cloud. You can use Splunk. And basically how it works is we offered a structured JSON format that will power your data for data interchange. And this will allow you to easily integrate your current logs with other platforms.
Hello and welcome. My name is Samvit Mishra and I am a Senior Principal Training Lead. In this lesson, we will discuss the overview of Compute Service. So let's get started. OCI Compute Service lets us provision and manage compute hosts, also known as instances. It serves as a foundation for other OCI services, and OCI offers a variety of shapes that are designed to meet a range of compute and application requirements. A shape is basically a template that defines the number of OCPUs, the amount of memory, and other resources that are allocated to an instance. OCI Compute Service offers both bare metal and virtual machine instances. So a bare metal compute instance gives you the dedicated physical server access, and a virtual machine is an independent computing environment that runs on top of the physical bare metal hardware. If you make any changes to the instance local drives, they are lost when you terminate it. But if you save changes to the volumes attached to the instance, they are retained. In this lesson, we will look at platform and custom images. So let's get started. Let's look at instance images. When you create a compute instance, you need to specify shape and image. Image determines the operating system and other software for an instance, and you can think of an image as a template of a virtual hard drive. Now let's talk about the image sources. So we have platform images and Oracle provided images. Platform images are pre-built operating systems for Oracle Cloud Infrastructure, and Oracle images are Oracle Enterprise images and solutions enabled for OCI. Then we have custom images, using which you can create a custom image from existing instances running in OCI. Next is partner images, which are trusted third-party images published in Marketplace by Oracle partners. And finally, using the custom image feature, we can also import custom images into OCI environment. So you can also bring your own image. Now, as you can see here, Oracle provides several pre-built operating systems for OCI. So Oracle Linux, Ubuntu, CentOS, Microsoft Windows, Oracle Autonomous Linux are some of the platform images provided by Oracle. And you can find the detailed list by visiting the OCI documentation. Now let's talk about custom images. When you create an image of a running instance, the instance shuts down and remains unavailable for several minutes. The instance restarts when the process completes. Instances you launch from your image is going to include the customization, configuration, and software installed when you created the image. The Bring Your Own Image feature also enables you to bring your own versions of operating systems to the cloud as long as the underlying hardware supports it. But be aware of the limitations. For example, the maximum image size that can be imported is 400 GB. When you are creating a Windows custom image, there is support for two kinds of images, generalized and specialized. Generalized images are images that have been cleaned of instance-specific information, and specialized images are point-in-time snapshots of the boot disk of a running instance and are useful for creating backups of an instance. In this lesson, we will discuss import, export, and bring your own image. So let's get started. Let's first look at image import export. You can share custom images across tenancies and regions using image import export. When you replicate an image across a region, you leverage OCI object storage, and importing the image supports different launch modes. The first is emulation mode. For virtual machines that don't support para-virtualized drivers that are created outside of OCI from older on-premise physical or virtual machines, you can go for emulation mode. The second is para-virtualized mode. For virtual machines that support para-virtualized drivers but created outside of OCI environment, you can go for para-virtualized mode. And the third mode is native mode. For images that were exported from Oracle Cloud Infrastructure, you can go for native mode. Now let's look at the steps in case you want to replicate an image across regions. So the very first thing is you have to export the image to an object storage bucket in the same region as the image. Then you need to copy the image to an object storage bucket in the destination. After obtaining the URL path to the image object, you need to import the image in the destination region. Now let's look at bring your own image. As you can see in this image, you can simply export virtual machines from your existing virtualization environment and import directly to OCI as a custom image. So you can import images in either QCOW2 format or VMDK formats. And once you have the image, you can create an instance from a custom image. So bring your own image feature helps with enabling virtual machine cloud migration projects. It supports both old and new operating systems, encourages experimentation, and increases infrastructure flexibility. Please note that you must comply with all the licensing requirements. In this lesson, we will discuss compute shapes. So let's get started. A shape is a template that determines the number of OCPUs, the amount of memory, and other resources that are allocated to an instance. Compute shapes are available with AMD processors, Intel processors, and ARM-based processors. Now there are two options when it comes to shapes. The first is fixed shape, where you cannot customize the number of OCPUs and the amount of memory. And then you can create a bare metal instance or a virtual machine instance using fixed shape. The second option is flexible shape, where you can customize the number of OCPUs and the amount of memory. However, you can only create a virtual machine instance using flexible shapes. And you can see in the slide the maximum number of OCPUs and the maximum amount of memory for the flexible shapes depending on the processor type. In this slide, we will look at the flexible shapes. So as you can see here, these are the flexible shapes. For example, vm.standard.e3.flex. We discussed that flexible shapes lets you customize the number of OCPUs and the amount of memory when launching or resizing your VM. And then the network bandwidth and the number of VNICs scale proportionately with the number of OCPUs. So what is the benefit of flexible shape? The benefit is you can build VMs that match your workload, enabling you to optimize performance and minimize the cost. So as you can see in the slide, I have selected vm.standard3.flex. This is a flexible shape and I can customize the number of OCPUs from 1 to 32 and maximum memory that I can select is 64 GB per OCPU. Therefore, you see that when I have selected 4 OCPUs, the maximum memory that I can select is 256 GB. In this lesson, we are going to discuss bare metal, virtual machines, and dedicated hosts. So let's get started. Let's first look at bare metal instances. Here, you get direct access to the underlying hardware, and it provides you a dedicated physical server for highest performance and strong isolation. And you can use bare metal instances in scenarios where workloads are not virtualized. There is a performance intensive workloads that require bring your own license, and workloads that require a specific hypervisor. Now let's look at virtual machine instances. Virtual machine instances runs on top of bare metal hardware. There is a hypervisor on top of bare metal server to virtualize it in smaller VMs, and virtual machines are ideal for running applications that do not require the performance and resources of an entire physical machine. And lastly, let's talk about dedicated hosts. It is the combination of bare metal and virtual machines. In dedicated hosts, multiple VMs are running on bare metal, and the whole server is dedicated to a single host. This feature lets you meet the compliance and regulatory requirements for isolation that prevent you from using shared infrastructure. In this demonstration, I will show you how you can generate an SSH key pair. So let's get started. So as you can see, I'm logged into the OCI console using the compute admin user, and I am currently in the Ashburn region. So let me go ahead and launch the Cloud Shell. So the very first thing that we are going to do is we will generate an SSH key pair using Cloud Shell. And later in the demonstration, we will use PuttyGen to generate an SSH key pair. So let's first look at how we can use Cloud Shell to generate an SSH key pair. So instances launched using Oracle Linux, CentOS, or Ubuntu images use an SSH key pair instead of a password to authenticate a remote user. Now when we talk about a key pair, it consists of a private key and a public key. So you keep the private key on your computer and you provide the public key when you create an instance. So I'll just maximize it and then I will run the command SSH keygen. So here you can go with the defaults or you can specify where to save the key. And in case you go with the default, you see this is where your keys are saved. .ssh id_rsa. So I am okay with the default. I'll press enter. If you want, you can enter passphrase. So your keys are now generated. And you can also see the message, your public key has been saved in this particular path. So if I go to this particular directory and do an ls, I'm able to see two keys. This is the first one and this is your private key and this is your public key, id_rsa.pub. Now anyone who has access to this private key can connect to the instance, and therefore we should store the private key in a secure location. Now when we create the instance, we can make use of this public key. So this is how you generate a key pair using Cloud Shell. Now let me show you how you can do that using Partigen. So you see here Pati key generator. Now I'll click on generate, and I will generate some randomness by moving the mouse over the blank area. Now you see that the public key is generated. So I can just copy this, and after copying, I can basically save it. I can save it as mykey.pub, and I can also save the private key. So this is my public key, and I can save the private key. I'll click on yes, and here I will give it a name. I'll simply type mykey, and you see that when you save the private key, it is saved in .ppk format. So I'll click on save, and there you go. So if I just go to the downloads, you can see that now I have the public key. This one is the public key, and this one is the private key. So this marks the end of this demonstration where we looked at how to generate an SSH key pair, how you can launch and connect to an Oracle Linux instance. So let's get started. As you can see, I am logged into the OCI console using the compute admin user, and currently I am in the Ashburn region. So how do I get to this page? If you click on the hamburger menu, go to compute. Under compute, click on instances. You get to this page. So let me click on create instance. The very first information I need to provide is the name. Please note that you can change the name later, and the name does not need to be unique because an Oracle Cloud identifier is going to uniquely identify the instance. So I'll just name it demo instance. Then I can select the compartment, and in the placement section, you can select the availability domain, whether you want to go for AD1, AD2 or AD3. Now if you click on show advanced options, you'll get the information on the capacity type. So there are 4 different options here. On demand capacity, where the instance is launched on a shared host, this is going to be the default. Then you have preemptible capacity. Please note that if you go for this option, in case the capacity is needed elsewhere, the capacity is going to be reclaimed and the instances will be terminated. The third option is capacity reservation. So this option lets you count the instance against a capacity reservation that you have created. And then the final option is dedicated host. So this option lets you run your instance in isolation. So meaning the instance is not going to run in a shared infrastructure. Then you have the option to select the fault domain. You can let Oracle choose the best fault domain for you, or you can select the appropriate fault domain. The next option is with respect to image and shape. So image is basically the operating system that runs on top of the shape. Shape is kind of virtual hardware configuration where you define the number of CPUs, the amount of memory, and other resources that you want to allocate to the instance. So if I click on change image, so under the image source, you can see there are different types of images. So platform images are basically pre-built images for Oracle Cloud Infrastructure. Then you have Oracle images. It is pre-built Oracle Enterprise images and solutions that are enabled for OCI. Then you have partner images. So these are the trusted third-party images published by Oracle partners. Then you have the option of custom images. These are the custom images that are created or imported into your OCI environment. Then there is option for community images. So these are the custom images that are created and published by community members for use by other community members. Then there is boot volume. So these are the boot volumes that are available for creating a new instance in your OCI environment. And finally, you have the image OSIT. So you can also create an instance using a specified version of an image by providing the image OSID. So I will select platform images. So for this demonstration, I will select Oracle Linux 8 and I'll click on cancel because it is already selected. Now let me come to the shape and click on change shape. So here under the instance type, you can select either virtual machine or bare metal machine. So if you select bare metal machine, this is going to give you a dedicated physical server, and you can select this for strong isolation and high performance requirements. And as you can see, these are the shapes for your bare metal machine. If you select virtual machine, first you need to select a processor group. You can see there are different options. You can go for AMD, Intel, Ampere, and specialty and previous generation. So once you select a particular shape series, then you can select a shape name. So if I go for this particular shape, so you can see that this is a flexible shape. So I can customize the number of OCPUs and the amount of memory. So let me go with this 7 OCPUs and 38 GB RAM. Select shape. So the next option is networking, where I need to select an existing virtual cloud network, and I also have the option to create a new virtual cloud network. So I'll select an existing VCN. So this is the VCN that I created prior to this demonstration. So I'll select that. I'll also select subnet A, which is a regional and a public subnet. And then you have the option whether to assign a public IPv4 address. Then under this add SSH keys, you have to provide the public key, and you can see the various options that are listed over here. So you can let OCI generate a key pair for you. You can upload the public key files. You can paste the public keys. In case you don't want to connect to the instance, you can also go with no SSH keys. So I'll click on paste public keys. And if you remember, in the previous demonstration, we generated an SSH key pair. So I will use those public keys. So let me click on Cloud Shell. So there you go. Let me go to .ssh and then do an ls. You see this is the public key. So I will just grab the contents. And put it here. Then you have the option of boot volume. So you can specify a custom boot volume size. By default, the volume size is 46.6 GB. But if you select on specify a custom boot size, you can specify any value from 50 GB to 32 TB. So I will go with the default boot volume size. And then you can use the in-transit encryption. This is going to encrypt the data between the instances and the boot volume. You can also encrypt this volume with a key that you manage. And then if I click on show advanced options, I get these 3 tabs: management, availability configuration, and Oracle Cloud Agent. So under management, I see that there are different options. I want to talk about this initialization script. So think of this initialization script as a startup script that is going to run when your instance boots up or restarts. Think of this like an user data that is going to be used by Cloud Init to run custom scripts. And if you select this particular option, require an authorization header, you are basically ensuring that all the requests to the instance metadata service use the version 2 endpoint. And then under the availability configuration, there is an option of live migration. So in case an underlying infrastructure components needs to undergo maintenance, you can select this option to let OCI choose the best option to migrate the instance to a healthy physical VM host. You can also use live migration if possible. And the third option is you can opt out. So in this particular scenario, a notification will be sent out for the maintenance event, and the instance is going to be live migrated if you do not proactively reboot the instance before the due date. And the final option is with respect to Cloud Agent. So here you can see that there are different plugins. So plugins basically collect performance metrics and they perform other instance management tasks. For example, I can go ahead and enable this vulnerability scanning plugin. So these are the options. Let me go ahead and click on create. So So as you can see, this demo instance is currently in the provisioning state. We will return back once this instance is running. Alright, so we see that the demo instance is running, and you can also see the public IP address. This is the public IP, and you can also see that the username is OPC. So now let me connect to this instance. So I'll grab the public IP address, go to the Cloud Shell, fire the command ssh opc@public IP. Are you sure you want to continue connecting? I'll type yes, and there you go. So I am currently inside the demo instance. Now let me very quickly go ahead and install Apache. So this is done. And then I want to display the sample text. So it's done. Let me return back. Let me just go ahead, grab the public IP address, and you see I am able to open this test page. This is a compute demo test page. Now one configuration change that you have to make before you see this is you need to go to the default security list for your VCN, and you need to add this particular rule. So you basically need to allow TCP traffic for port 80. Now before I conclude this demonstration, I also want to show you the policies that you require to launch compute instance. Remember, we performed this demonstration using the compute admin user. Before you can launch any compute instance, you require these all policies. In this demonstration, I will show you how you can launch and connect to a Windows instance. So let's get started. So I am currently inside the OCI console, logged in as the compute admin. Let me go ahead and click on create instance. I'll just give my instance a name. Under placement, we can specify an availability domain, and under advanced options, I can select a capacity type and specify the default domain. And then under image and shape, let me first go ahead and change the image. So this time, instead of Oracle Linux, I will go and use the Windows image. And you can see these are the flavors. These are the operating system versions. So I will go with 2019 standard. So let me click on I have reviewed and accepted the following documents that basically governs the Oracle and Microsoft Windows terms of use. And then I can click on select image. And under networking, I can select the existing virtual cloud network, select the existing subnet, specify the option to assign a public IPv4 address. And you see now you don't get an option of SSH key pair. Rather, you see this login credentials, and it gives a message that an initial password will be generated when you create the instance. It will be available on the details screen for the newly launched instance. And the first time you log in to the instance, you have to reset the password. So we'll see how it looks like. Rest everything I'll keep as default, and I'll click on create. So as you can see, the demo instance Windows is currently in a provisioning state. So once this instance transitions to running state, I will show you how you can connect using RDP and the temporary password. So now we see that the instance is running, and I can also see the public IP address of the instance, and the username is OPC. So this is the initial password that we will use. Let me just copy the public IP address and try to perform an RDP to the instance. And before I do that, let me also show you what are the changes that you need to make in the default security list for the particular subnet. So you need to open 3389 in the security list. So I have done that. Now let me try to perform an RDP to the instance. So this is the public IP address. I'll click on connect. You see that it is asking me for the password. And you also see a message that the user's password must be changed before signing in. So I'll click on OK. Once I provide the new password, I can click on enter and your password has been changed. So now you can see that I have successfully connected to the Windows instance. So this concludes our demonstration on how to launch and connect to a Windows instance. In this demonstration, I will show you how you can create a custom image and use that image to launch an instance. So let's get started. In one of our previous demonstrations, we launched demo instance and we also installed Apache web server on this instance. So if I just copy the public IP address, so you can see that this is a compute demo test page. Now what we are going to do is we'll create an image out of this instance. So let me go to more actions and click on create custom image. You get a message that the instance will be taken offline for several minutes during the imaging process, and the best practice is to manually shut down the instance using the operating system before you create a custom image. So let me specify a name OCI AA custom image and click on create custom image. So as you can see, the state of the instance has now changed to creating image. So now we see that the instance is running. So if I go to compute and click on custom images, I should be able to see the custom image that we created. So this is the original image, Oracle Linux 8.5. So if I go back to my instances, now let me show you how to launch an instance from a custom image. So click on create instance. I will name it instance custom image. I'll select the compartment. Rest everything remains the same. The only change that I will do is I will go to image under image and shape. I'll click on change image. Now instead of using platform images, I will select custom images. If I select arc associate compartment, I should be able to select the custom image that I previously created. Let me select the image. So now under the image, I have the custom image. I am okay with the shape. I am okay with the networking settings. And one thing that I would like to show you is while creating this instance, I am not using any SSH keys. So let me go with the defaults and click on create. So as you can see, the instance that we created with custom image is now provisioning. Alright, so now you can see that the instance with custom image is running. So I'll show you two things. The very first thing is if I copy the public IP address and I just open it in a browser, I will be able to see this is a compute demo test page. And this was expected because we launched the instance from a custom image. Now the other thing that I want to show you is if I try to perform an SSH to this instance. Remember during the creation of the instance, I specified no SSH key pair. So let me try to perform an SSH to this instance and see if it works. So if I try to perform an SSH to this instance, so OPC is the username and this is the public IP address. There you go. So as you can see here, I am successfully able to perform an SSH to this instance. And this is also because we created the instance from a custom image. So this marks the end of this demonstration. In this lesson, we will discuss preemptible instances. So let's get started. So what are preemptible instances? Preemptible instances are the same as on-demand instances with one exception. If compute capacity is needed elsewhere, OCI can terminate those instances. Preemptible instances run on unused on-demand capacity, enabling OCI to offer it to you at 50% discount compared to on-demand instances. Preemptible instances can be terminated at any time. Hence, they are not suitable for long-running workloads. So they are designed for short-term usage. When you edit an instance that uses preemptible capacity, only the name of the instance can be changed. You cannot change the shape of the instance after it is launched. You cannot convert a preemptible instance to an on-demand instance, and the pricing for preemptible instance is simple. It is always 50% cheaper than your on-demand rates. So OCI can terminate preemptible instances if requests for on-demand instances increase. Hence, the capacity can be reclaimed. Preemptible capacity does not support bare metal instances. You cannot use preemptible instances to create instance configurations, and preemptible instances cannot be used in instance pools. OCI sends a termination notice through the event service before terminating a preemptible instance. An instance preemption action event is emitted 30 seconds before the instance termination begins. Now, can you think of any use case for preemptible instances? Well, one example is when you are running batch jobs like video encoding, you can make use of those instances. Now that we know what is a preemptible instance, let's discuss how we create it. I'm also going to show you a demonstration in the next lesson. So preemptible instances use the same management experience as on-demand instances, and in the console, you create a preemptible instance by selecting the preemptible capacity in the placement section. So as you can see here, under the placement, under the capacity type, instead of on-demand capacity, you have to select preemptible capacity. In this demonstration, I will show you how to create a preemptible instance. So let's get started. As you can see, currently I am in the OCI console and I'm logged in as the compute admin. So I'll click on the hamburger menu, click on compute. Under compute, click on instances, click on create instance. I will give it a name. Preemptible demo instance. I am okay with OCI Arc associate compartment. If I go to the placement and click on edit, I can select the availability domain of my choice. Click on show advanced options. Under capacity type, rather than selecting on-demand capacity, I will select preemptible capacity. And then there is also an option whether you want to permanently delete the attached boot volume when the capacity is reclaimed. By default, it is selected. Under fault domain, you can let Oracle choose the best fault domain. Under image and shape, you can select the appropriate image and the shape as per your requirement. Under networking, if I click on edit, I can select an existing virtual network, demo VCN, and I can select an existing subnet, subnet A. I can also choose to assign a public IP address. And with respect to SSH keys, let me very quickly generate one. So I'll use this command to generate a key pair. So here you can see the private and the public key. So let me just copy and I'm going to paste it over here. You can also specify a custom boot volume size. By default, the boot volume size is 46.6 GB, but you can specify any integer between 50 to 32 TB. So let me go ahead and specify 100 GB. You can also choose to use in-transit encryption, and you can also encrypt the volume with a key that you manage, meaning customer managed keys. So let me click on create instance. Currently, the preemptible demo instance is provisioning. Alright, so now you can see that the preemptible demo instance is running, and just want to highlight that some actions are not allowed for preemptible instances. For example, you cannot start, you cannot stop, you cannot reboot the instance. And if the capacity is reclaimed in less than a minute, you are not charged for that time. So if I click on edit, I will just be able to edit the name of the preemptible instance. That's it. Now let me go ahead and connect to this instance. So I'll copy the public IP address. OPC is the username. So there you go. I'm connected to the preemptible demo instance. So if you look at the preemptible demo instance, under instance information, you can see that the capacity type is preemptible. Now let me show you one last thing. For that, I will log out of the compute admin user. So let me sign out. And let me log in as the tenancy administrator. So if I click on the hamburger menu, go to observability and management. Under event service, click on rules. Let me click on create a rule. Let me call it preemptible rule. So I can provide a description, send a notification when a preemptible instance is terminated. So the condition is event type. The service name, select compute. The event type, I can select instance and then preemption action. So this is the rule condition, and under action you can select either streaming, notification, or you may trigger functions. So let me click on notifications. Let me select the compartment and let me select the topic. So let me create the rule. Now when you create this preemptible rule, an instance preemption action event is emitted 30 seconds before the instance termination begins. In this lesson, we will discuss capacity reservations. So what is a capacity reservation? Capacity reservations allow you to reserve compute capacity in advance and use this capacity when you create instances against the reservation. When instances that use the reserved capacity are terminated, the capacity is returned to the reservation. Capacity reservations provide the assurance that you have the capacity necessary to manage your workload. You can create a reservation with as little or as much capacity as you need, so there is no size or time constraints. You can also delete the reservation at any time to stop paying for it. Please note that the reserved capacity incurs charges even when the capacity is unused, as reservations consume resources. Unused reserved capacity is billed at 85%. Instances created against a capacity reservation are billed at 100%. So as you can see in this screenshot, when you create your capacity reservation, you specify the availability domain where you want to reserve the capacity. And in this case, you can see availability domain 1. You can also see the capacity configuration. So I have reserved one vm.standard.e3.flex, and currently the used capacity is 0. Please note that the capacity reservations can have up to 30 capacity configurations, and we are going to see a detailed demonstration of capacity reservations in the next lesson. Now let's look at some of the example scenarios where capacity reservation can benefit us. When you have large capacity requirements for migrations or new project launches, capacity reservations ensure that you will have the capacity that you need. It ensures that capacity is available when you need to fail over to your secondary location. When maintenance or seasonal adjustments cause your usage to vary, capacity reservations provide the needed capacity, and it enables you to reserve capacity as a buffer for unexpected workload spikes. Now let's talk about support and limitations. When you create your capacity reservation, you specify the availability domain where you want to reserve the capacity. They cannot be shared between availability domains. Capacity reservations cannot be moved from one availability domain to another, nor can they be moved from one tenancy to another. Capacity reservations cannot be used with the dedicated virtual machine host feature. Capacity is allocated when reservation is created. If sufficient capacity is not available to complete the request, the capacity reservation is created with as many instances as possible. For example, if you request 20 instances and only 10 are available, a capacity reservation with 10 instances is created. And finally, the shape of the instance is limited to the shape that is defined in the configuration of the capacity. In this demonstration, I will show you how you can work with capacity reservations. So let's get started. As you can see, currently I am in the OCI console and I am logged in using the compute admin user. So to go to the capacity reservations, click on the hamburger menu, click on compute. Under compute, click on capacity reservations. So this is the page from where you can create a capacity reservation. We know that capacity reservations enable us to reserve instances so that capacity is available for your workloads when you need it. So before creating a capacity reservation, let me show you the policies that you need to add. So I am currently logged in as the compute admin user, and the compute admin user is added to the compute admins group, and I have written these two policies. Allow group compute admins to use compute capacity reservations in tenancy, and allow group compute admins to manage compute capacity reservations in tenancy. You need to add these policies in the identity and access management service before using capacity reservations. So now let me create a capacity reservation. So let me call it OCI capacity reservation. I can specify a compartment. I have to select an availability domain. Let me select AD1. I can also make this reservation the default for this particular availability domain. But in order for you to do that, you must be in the root compartment. So currently I am in Arc Associate compartment and hence I will not be able to select this particular option. But if you make this reservation the default, any instance that is launched in this particular availability domain for this particular tenancy, regardless of the compartment, will use the default reservation. Now, if you select this particular option, the capacity from the default reservation is going to be used for all the compatible instances that is going to be launched in AD1, this particular availability domain. So let me click on next. So this is where I can add the capacity configurations. So I can select the fault domain and I can select the shape. Let me select VM standard 1.1 and I can specify the count over here. So let me specify 3. I can also add another shape. I can select the fault domain as FD1 and then I can select standard E4 flex and the count I can specify is 2. Let me click on next. So in this page, you can review the details of capacity reservation. For example, we selected availability domain AD1. The compartment is Architect Associate compartment. And under capacity reservations, you can see that we have selected 2 instance types, standard 1.1 and standard E4.flex. And these are the requested capacity numbers. Let me click on create. So it is currently creating the OCI capacity reservation. And you can now see that it is currently active. Just want to highlight a couple of things here. So under resources, if you go to capacity configurations, you can see the reserved capacity and the used capacity. So currently, these are the numbers when it comes to reserved capacity, standard E4.flex. So I have made the reservation for 2 instances, and standard 1.1, the reserved capacity is 3. Used capacity is 0 for both the instance types. Now let me create an instance. So if I click on created instances, click on create instance. I am okay with the default. And as you can see under the placement, if I click on show advanced options, the capacity type is capacity reservation and not on demand or preemptible. By default, it automatically selects this particular capacity reservation. Now if you come to image and shape, under the shape, if I click on change shape, if I click on AMD, you can see that the shape name is vm.standard.e4.flex, and it says that the capacity reservation you selected has available capacity in the following configurations for this particular shape, and there are 2 remaining. Remember that we created capacity reservation for this particular shape, so we can select this. The other thing that I want to show you is if I go to specialty and previous generation, then you can see this warning message, right? This warning message basically means that this capacity reservation that I have selected doesn't have a configuration for this particular shape. You remember we selected vm.standard 1.1, and hence I can go ahead and launch this particular instance. So let me go ahead and select this shape. And then rest everything remains the same. I'm not going to provide any SSH keys as I will not be connecting to the instance using SSH. So let me click on create. So the instance is currently provisioning. It is using the capacity reservation as the capacity type, and this is the reservation. And if you scroll down, you can see the shape configuration vm.standard 1.1. In the meantime, if I go to compute and click on capacity reservations, click on OCI capacity reservation, this is what I wanted to show you. Now you can see that for this particular instance type, the reserved capacity is 3 and the used capacity is 1. Now let me show you one more thing. First, you need to understand that there is something called capacity reservation that we created. And inside the capacity reservation, we have capacity configurations. So if I try to edit the capacity configuration, you see that I cannot change the fault domain and the shape, right? But what I can do, I can specify a count that is greater than or equal to the number of instances that is currently created in this configuration. So in this configuration, currently there is 1 instance created. So initially the count was 3. So I can make it 2. Initially you see it was 3. Used was 1. And now after this capacity reservation is updated, the reserved capacity would change to 2 and the used capacity will still be 1. So I'll just wait for this operation to complete. And as you can see, the reserved capacity is 2 and the used capacity is 1. Now if I want, I can also edit it and I can make it 4. Now you see that it is again updating, and in some time the reserved capacity for this standard 1.1 instance type is going to be 4. So there you go. Now you see it is 4. Now you can add the capacity configuration at any point of time. For example, I can select fault domain 1. I can select this particular shape. And then I can specify the count. Click on add configuration. So you'll now see that another instance type has been added in the capacity configurations. And currently it is updating. In some time you'll see the reserved capacity. So now you can see that I have added another capacity configuration. So now I have 3 capacity configurations. If I go to the created instances under the resources, I will be able to see all the instances that match the capacity configurations. Now the final thing that I want to show you is, in case I want this particular instance to move out of a capacity reservation. How will I do that? So if I go to the instance, click on Edit, click on Show Advanced Options. Under Placement, I can just remove this Apply a Capacity Reservation and click on Save Changes. Now the moment you do this, if I return back to the capacity reservations, so now you see that the used capacity for all the instance types is 0. And if I again go to the created instances, I will not be able to see any instance. But if I go to the compute, click on instances, you see that this instance is running, but currently the capacity type is on demand. Similarly, if you want to move the instances into the capacity reservation, again you can click on Edit, Show Advanced Options, click on Placement, apply a capacity reservation and select a capacity reservation, click on Save Changes. So that is how you move the instances into and out of a capacity reservation. So just to confirm, if I go to the capacity reservations now, again you see the used capacity becomes 1. So this marks the end of this particular demonstration. In this lesson, we will look at dedicated virtual machine host capacity type. So let's get started. So a dedicated virtual machine host gives you the ability to run compute virtual machine instances on a dedicated server that are a single tenant and not shared with other customers. You are billed for the dedicated virtual machine host as soon as you create it, but you are not billed for any of the individual virtual machine instances that you place on it. When you create a dedicated virtual machine host, you select a shape for the host, and the shape is going to determine how much capacity is available and what type of instances can be launched on the host. Some OCPUs are reserved for virtual machine management, hence there will be a difference between the number listed for build OCPUs compared to available OCPUs. Now let's see some use cases of dedicated virtual machine hosts. It lets you meet the compliance and regulatory isolation requirements as you are not using shared infrastructure. It also helps you meet host-based licensing requirements that require you to license an entire server. So in this slide and the next, you can see the various dedicated virtual machine host shapes. Please note that the usable OCPUs and usable memory depends on the shape that you select. For example, dvh.standard 3.64 is going to provide 60 usable OCPUs and 960 GB usable memory. And you can also see the supported shapes for hosted VMs. For example, dvh.standard 2.52 supports VM.standard2 series. So these are the dedicated virtual machine host shapes. Now there are some limitations of dedicated virtual machine hosts. Most of the compute features for virtual machine instances are supported for instances running on dedicated virtual machine hosts, but the features that you see here are not supported. For example, auto-scaling, capacity reservations, instance configurations, instance pools, burstable instances, and reboot migration. In this demonstration, I will show you how you can work with dedicated virtual machine host. We know that dedicated virtual machine host feature gives us the ability to run compute virtual machine instances on dedicated servers that are a single tenant and not shared with other customers. So let's go ahead and see a demonstration on how you can create a dedicated virtual machine host. So as you can see, I'm currently in the OCI console, logged in as the compute admin. So click on the hamburger menu, click on compute. Under compute, click on dedicated virtual machine hosts. So before you can work with dedicated virtual machine host, you need to add the policy statements in the identity and access management service. So these are the policies that you need to add. So if you want the users to manage compute dedicated virtual machine hosts, so these are the two policies that you require. Allow group compute admins to manage dedicated VM hosts in compartment architect associate compartment, and then allow group compute admins to manage instances in a particular compartment. In case you want the users to launch compute instances on dedicated VM hosts, then you basically require these policies. Allow group compute admins to use dedicated VM hosts in this particular compartment. So I have gone ahead and added these policies in the identity and access management service. So now let me create a dedicated virtual machine host. So click on create. This is where you provide the name, dedicated virtual machine host demo. I can select the compartment. I have to select an availability domain. And as you can see here, these are the dedicated host shapes. And this is the OCPO information. And if you click on this particular arrow, so you can see the compatible virtual machine shapes with this particular dedicated virtual machine host. So if you select dvh.denseio2.52, so you'll be able to launch the virtual machine of these shapes. So the point here is when you create a dedicated virtual machine host, you select a shape for the host. And then this particular shape is going to determine how much capacity is available and what type of instances can be launched on that particular host. For the purposes of this demonstration, I will go ahead and launch dvh.standard2.52 that has got 52 OCPUs. So let me click on create. As you can see, the dedicated virtual machine host is now creating. Now you can see that the DVH demo is active, so it is successfully created. So under the dedicated virtual machine host information, you can see the availability domain, the total OCPUs, the remaining OCPUs, the total memory, and the remaining memory. Now let me show you one thing. While creating this dedicated virtual machine host, remember, this was the shape that we created, dvh.standard.2.52, and you can see the number of OCPUs was 52. When you look at the dedicated virtual machine host information, the total OCPU is 48. Why there is a difference between the number listed for build OCPUs compared to the available OCPUs? This is because some OCPUs, in this case 4 OCPUs, are reserved for virtual machine management, and therefore you are able to see 48 available CPUs. Now with respect to billing, you are billed for this dedicated virtual machine host as soon as you create it, but you are not billed for any of the individual virtual machine instances that you place on it. But keep in mind, you'll still be billed for any image licensing costs. Now the next part in this demonstration is how do you place instances on a dedicated virtual machine host. So for that you have two options. The first option is you can go to the instances, click on create instance. I'm okay with the default name. You can select the compartment, and under placement, if you click on show advanced options, so under capacity type, instead of on-demand capacity, now you have to select dedicated host. So once you select dedicated host, you should be able to select the one that we created. And when you select, you also see the remaining OCPUs and the remaining memory. And depending on the shape that you select, you can basically change the shape. So remember, we discussed that depending on the virtual machine host that you are selecting, that is going to support specific VM shapes. So we can see that if you click here, the selected virtual machine host is not compatible with this shape. So if I scroll down, so these are the ones: VM.standard 2.1, 2.2, 2.4, 2.8, 2.16 and 2.24. So these are the virtual machine shapes that are supported with the dedicated virtual machine host that we have created. So let me go ahead and select VM.standard 2.4. Let me click on select the shape. Rest everything remains the same. Let me click on create. So in the meantime, this instance is getting created. If I return back to the dedicated virtual machine host, so now you can see that the total OCPUs was 48. The remaining OCPUs is 44. The total memory was 736 and the remaining memory is 676. Why? Because this particular instance took 4 OCPUs and 60 GB memory. And hence you are able to see these particular values. The other option to create instances on a dedicated virtual machine host is to go to the hosted instances under resources, right? So as you can see, there is already one instance that we have created. So you can just click on create instance, and that is going to take you to the same page from where we created the compute instance. So this marks the end of this demonstration where we looked at how we can create a dedicated virtual machine host and how we can place an instance on that particular host. In this lesson, we will look at burstable instances. So let's get started. A burstable instance is a virtual machine instance that provides a baseline level of CPU performance with the ability to burst to a higher level to support occasional spikes in usage. Burstable instances are designed for scenarios where an instance is typically idle or has low CPU utilization with occasional spikes in usage. Burstable instances cost less than regular instances with the same total OCPU count. They are charged according to the baseline OCPU. When you create a burstable instance, you specify the total OCPU count and the baseline CPU utilization. The baseline utilization is a fraction of each CPU core, either 12.5% or 50%. Please note that the baseline provides the minimum CPUs that can be used constantly, and there is no guarantee that an instance will be able to burst if the physical virtual machine host is oversubscribed. And now, when will the system allow bursting? Well, only if the average CPU utilization for the instance is below the baseline over the last 24 hours. And one thing that you have to understand is memory doesn't burst, it's only the CPU. Not all the shapes support burstable instances. You can use the ones that you see in the slide to create a burstable instance. For example, you can use vm.standard3.flex, vm.standard.e3.flex, and vm.standard.e4.flex. Burstable instances are able to sustain workloads running at a fraction of CPUs most of the time, and then they can burst up to the full CPUs for a limited amount of time. Hence, they can be used in microservices, dev and test environments, CI/CD tools, static websites, and monitoring systems. So these are some of the example scenarios. Now let's look at how you can create a burstable instance. The process is similar to creating an on-demand instance. The only difference is you have to change the shape to one of the supported shape. And then, as you can see in the slide, you have to provide three things. First, you have to specify the number of OCPUs. That is going to be the maximum OCPU. Then you have to select the burstable option. And then you have to set the baseline. Here I have set it to 12.5%, but you can also set it to 50%. Now, from a pricing standpoint, burstable instances are charged according to the baseline OCPU. So even if your instance bursts above the baseline, you still pay for the baseline OCPU. In this demonstration, I will show you how you can create a burstable instance. So as we know, a burstable instance is a VM instance that provides a baseline level of CPU performance with the ability to burst to a higher level to support occasional spike in usage. As you can see, currently I am inside the OCI console, logged in as the compute admin. So let me go to the compute service. So under compute, I'll click on instances. Let me click on create instance. So I will name it burstable instance demo. I will create it in this particular compartment. Under placement, I will select this particular availability domain. Under image and shape, I am okay with Oracle Linux 8. Under shape, let me click on change the shape. And as you can see here, if I click on AMD, so this is vm.standard.e4.flex. So there are three instance shapes that support burstable instance. And this is one of them, vm.standard.e4.flex. Similarly, if I click on specialty and previous generation, I can see vm.standard.e3.flex. And if I click on Intel, I can see vm.standard.3.flex. Now, just to show you what's the difference, let me first select this vm.optimized 3.flex. And as you can see, if I select this particular option, I can specify the number of OCPUs and the amount of memory. But I don't see any other option. But if I select this particular shape, vm.standard3.flex, apart from selecting the number of OCPUs and the memory, you can also make it burstable. Now, the moment you make it burstable, you will be asked to provide the baseline utilization per OCPU. Now, let me talk about it. What is this all about? So remember, when you create a burstable instance, you specify the total OCPU count. For example, here I specified 1, and then I need to specify the baseline CPU utilization. So this baseline CPU utilization is basically a fraction of each CPU core. So it can be either 12.5% or 50%. So this baseline is going to provide the minimum CPUs that can be used constantly. Now in this particular scenario, as I have selected the instance with one OCPU, a baseline of 12.5% means that 12.5% of the CPU core is available for baseline usage with a maximum burst of 100% of one CPU core. So let me select 12.5% and click on select the shape. Rest everything remains the same. So I can go ahead and click on create. So this is how you create the burstable instances. So as you can see, this burstable instance demo is currently provisioning, and in some time it is going to be available. So under the instance information, if you go to shape configuration, then you can see the shape, OCPU count, and the burstable baseline. Now how does it work? When needed, the instance can use more than the baseline CPU all the way up to the total CPUs. So in this case, the burstable is 12.5%. The total OCPU count is 1. Now you also need to understand one thing. If the average CPU utilization of the instance over the past 24 hours is below the baseline, the system will allow it to burst above the baseline. Now from a pricing standpoint, these burstable instances cost less than regular instances with the same total OCPU count, because the burstable instances are charged according to the baseline OCPU and not total OCPU count. So with this, we are concluding this demonstration. In this lesson, we will look at compute vertical scaling. So let's get started. So what is vertical scaling? Vertical scaling means you add additional resources to an instance so that it meets demand. Sometimes we also refer to vertical scaling as scale up and scale down. So you can change the shape of a virtual machine instance without having to rebuild your instances or redeploy your applications. Now you can perform either scale up, which is going to increase the performance, or scale down, which can help you save costs. And as you can see in the screenshot, there is an option to edit the shape of your instance. However, please note that the shape series and image of the original shape is going to determine which shapes you can select as a target for the new shape. So let's look at some considerations. When you perform vertical scaling, the IP address of the instance, both public and private, remains unchanged. Similarly, the volume attachments and the VNIC attachments are also not affected. And as we discussed in the previous slide, the target shape that you select depends on the current shape series and the image. And if the instance is running when you change the shape, it is rebooted as a part of the change shape operation. Now, what is affected when a vertical scaling is performed? Well, the number of OCPUs and the memory are going to change. Along with that, the network bandwidth and the maximum number of VNICs are also going to be affected. Now, two important callouts before I wrap up this lesson. First, you can use the monitoring service to monitor VM metrics and raise an alarm when a particular metric is met. The alarm notification can then call a function to adjust the shape of the virtual machine as needed. So we can kind of automate this process. And the second callout is scaling a virtual machine will cause a reboot. In this demonstration, I will show you how you can scale cores and memory for an instance. So let's get started. As you can see, I am inside the OCI console and there are a couple of instances that are running. So let me consider this first instance. Now under instance information, you can see that the current shape is vm.standard.e4.flex and the current OCPU count is 1 and the memory is 16 GB. Now, if I would like to change the shape of an instance, I need to click on Edit, and under Edit Instance, I'll click on Edit Shape. You can see that the current shape series is AMD, but I can select Intel, and then I can select VM Optimized 3.flex. And when I select this, I can make the number of OCPUs as 5, and I can make the amount of memory as 16. So let me go ahead and save the changes. Now if the instance is running, it is going to be rebooted. So we can confirm reboot instance. Now you can see that this particular instance is stopping, and if I scroll down and go to the work request under resources, I should be able to see the operation update instance. I will be able to monitor the state and percentage complete. So I will wait for this operation to get completed. So now you can see that this operation is complete and the state is succeeded. So let me go to this instance, and under instance information, now I see that the shape is vm.optimize3.flex. The OCPU count has been scaled from 1 OCPUs to 5 OCPUs, and the memory has also been scaled to 16 GB. Now please note, when you click on Edit and you click on Edit the shape series and image of the original shape is going to determine which shapes you can select as a target for the new shape. So this marks the end of this demonstration, where we looked at how we can perform vertical scaling, basically scale the cores and memory for an instance. In this lesson, we will discuss compute auto-scaling. So let's get started. The first construct we will look at is instance configuration. Instance configuration is a template that defines the settings to use when creating compute instances. You can use instance configuration to create one or more instances in an instance pool. You can also use it to create individual instances. Please note that it does not include the contents of any block volumes that are attached to the instance. So as you can see in the slide, you have the option to launch an instance and create instance pool from the instance configuration. And to modify an existing instance configuration, you have to create a new instance configuration with the desired settings. The next construct is instance pool. Use instance pools to create and manage multiple compute instances within the same region as a group. You can use the same instance configuration for multiple instance pools. However, an instance pool can have only one instance configuration associated with it. After you have created an instance pool, you can update the size of the pool. You can add and remove existing instances from the pool and attach or detach load balancers. And then you can adjust the number of instances running in the instance pool using either metrics or schedule. And as you can see in the slide, I have an instance pool that is created with a target instance count of 2. And you see that initially 2 instances are created and running in the pool. So when you create an instance configuration, you can either use an existing compute instance as a template, or you can provide a list of configuration settings. Here, as you can see, I am creating an instance configuration out of a running instance, and that would contain the operating system image, metadata, shape, VNix, storage, and subnet information. And then I am using that instance configuration to create instances in an instance pool. The instances can be deployed in different availability domains and can also be placed behind a load balancer. The whole point of grouping together multiple instances is to manage it as a group. Now let's discuss about the two types of auto-scaling policies: metric-based auto-scaling and schedule-based auto-scaling. Metric-based auto-scaling is an auto-scaling action that is triggered when a performance metric meets or exceeds a threshold. So what is the benefit? It is going to provide a consistent performance for your end users during periods of high demand, and it is also going to help you reduce the cost during periods of low demand. Now, schedule-based autoscaling is an autoscaling event that takes place at the specific times that you schedule. Now let's look at the steps that we need to perform to configure autoscaling. We have already discussed individual pieces. Now let's do a quick overview. The first step is to create the instance configuration. The second step is creation of the instance pool from the instance configuration. The third step is configuration of the instance pool. Here you perform things like updating the size of the pool, adding and removing existing instances from the pool, and attaching or detaching the load balancer. And the final step is defining a policy or a rule using autoscaling configuration. So as you can see in this architecture, we have defined the initial size of the instance pool as 2. We have also defined a scaling rule that is going to add 2 instances if the CPU or the memory utilization is greater than 70% and is going to remove 2 instances if it is below 70%. We have also defined the minimum size as 1 and the maximum size as 4. So when a scale out event happens, 2 instances will be added to the pool and the instance pool would scale from 2 to 4 instances. Hello and welcome. In this demonstration, I am going to show you how you can work with autoscaling. So we are going to have a look at how we can create an instance configuration, create an instance pool, and finally create an autoscaling configuration. So let's get started. As you can see, currently I am inside the OCI console, logged in as the compute admin user. And if I click on the hamburger menu, click on compute. So under compute, let me show you the different constructs that we'll be working with. So we will be working with instance configurations. We'll first create an instance configuration and then we will create an instance pool and finally we will define an autoscaling configuration. So let's get started. The very first thing that we would do is we'll create an instance configuration. And as you can see, the instance configuration is a template that defines the settings to use when creating compute instances. So before we start the demonstration, let me show you the policies that you require before you can perform these operations. So the first policy is let users manage compute instance configurations, instance pools, and cluster networks. So these are the policies that you need to add. So this is the first policy. And then the second policy is let users manage compute autoscaling configurations. So these are the policies. Now what I have done is I have gone ahead and added these 5 policies to Identity and Access Management Service. So this is the prerequisite. I can return back to the OCI console and create my instance configuration. So let's do that. So let me click on Create Instance Configuration. I can give it a name, Demo Instance Configuration. I can select the compartment. I can specify the availability domain option under placement, and if you click on show advanced options, you can also specify the capacity type. Then you can select the image and the shape. I am fine with Oracle Linux 8 and I am also fine with vm.standard.e4.flex. From a networking standpoint, I can select the existing virtual network. I can select the existing subnet. I may choose to assign a public IPv4 address and then I need to add the SSH keys. So let me very quickly do that. So I'll paste the public keys over here. The rest, all the settings remain the same. As of now, I'm not attaching any block volume. So I can click on create. So you can see that this demo instance configuration is now available and you can find the details of it under instance configuration information. Now the second step is to create an instance pool. Now there are 2 ways in which you can do it. If I return back to the compute, you can go to the instance pool and create the instance pool from here. We know that instance pool is a mechanism to manage multiple compute instances as a group. The second option is to go to the instance configuration, click on demo instance configuration, and then create the instance pool from here. So let me do that. Let me click on create instance pool. I can give it a name, demo instance pool, and then I can select the compartment, and then I have to specify the initial number of instances. So let me make it 2. Let me click on next. Now I have to configure the pool placement. So I can select the availability domain, and then I have to select a virtual cloud network. And then let me select a subnet. You can add another availability domain. So this time let me select AD2 and then select the same VCN and select subnet A. Let me click on next. So let me click on create. So you see that the demo instance pool is getting provisioned. And as we defined, the target instance count is 2. And you can monitor the work request under the resources. Now when this demo instance pool is provisioning, if I scroll down and show you the attached instances, you can see that there are 2 instances that are getting provisioned. Why? Because when we created this demo instance pool, we specified the target instance count as 2, and hence 2 instances are getting provisioned. You also have the option to add a load balancer to an instance pool so that the traffic can be distributed across these attached instances. And now we see that both these instances are running. This first instance is running in availability domain 1, and the second one is running in availability domain 2. And you also see that the demo instance pool is also running. So now if I return back to the compute, let me go ahead and create an auto-scaling configuration. So this is the third construct and the final one. Let me click on create auto-scaling configuration. And I will just give it a name. Demo auto-scaling config. I'll select this compartment and I can select the instance pool that I created. Demo instance pool. Then I can click on next. Now there are 2 types of policies that you can configure. The first is metric based auto-scaling, that is going to use the performance metrics like CPU utilization to trigger auto-scaling events. The second is schedule based auto-scaling, where you are going to define a cron expression, and you can also configure the auto-scaling events to take place at a specific time that you schedule. So I will go with metric based auto-scaling. And you can see the instance pool information and the instance configuration information over here. You can also see the shape configuration. Now let me configure the auto-scaling policy. Let me just give it a name. Demo auto-scaling policy. And I can also define the cooldown timer. So this cooldown timer is the minimum period of time between scaling actions, right? So the minimum value is 300 seconds. So I will define that. And then I can define the performance metric. So I have 2 options here. I can go for CPU utilization or I can go for memory utilization. So in this case, I will select CPU utilization. And then I can define the scale out and the scale in rules. So I can define the scale out if the CPU utilization is greater than, let's say, 85%. I want to add 1 instance. And under the scale in rule, I can define if the CPU utilization is, let's say, less than 60%, remove 1 instance. That means 1 instance will get terminated. And this CPU utilization is going to be the average CPU utilization of all the instances that are running in the instance pool. And you can also define the scaling limits, right? What's the minimum? What is the maximum? So you see the initial number of instances I have already defined as 2. So I can now define the minimum number as 1 and the maximum number as 3. Now let me click on next and click on create. So this is how I create my auto-scaling configuration. So you see that the auto-scaling configuration is now enabled. So now if I return back to compute and I go to the instance pool, initially there were 2 instances running, but if I go to the compute and go to the auto-scaling configuration that I defined. There I had defined a policy that if the CPU utilization is less than 60%, I want to remove one instance, right? And therefore, if I go to the instance pool, you can see the state is scaling. So when I say scaling, it also means scaling in. So that is what we call as horizontal scaling. Both scale out and scale in operations are supported. And now you see that the instance pool is running. But if I look at the attached instances, there is just one. So this instance got terminated. And if I look at the work request, terminate instance in pool. So this operation got succeeded. All right, you see terminating one instance from the instance pool, and you are also able to see the message terminated 1 out of 1 requested instances. So as of now, there is just one instance that is running, and this is the instance. So I have demonstrated how scale-in operation is performed. Now let me demonstrate how you can scale out, how you can add another instance by increasing the CPU utilization. So let me go ahead and connect to this instance. So I'll copy the public IP address. Let me try to do an SSH to this particular instance. So I will do SSH OPC @public IP. Let me go ahead and download the extra packages repository. So now it is installed. So now if I go ahead and install the stress package, yes, so this is done. So now let me fire this command. So this command is going to increase the CPU utilization. So I'll just minimize it. And what I will do is I'll go to the instances. I'll go to the instance pool. So currently you see that in the instance pool, there is just one instance that is running. Now in some time you will see another instance coming up. Alright, now you can see that another instance is getting provisioned. So if I look at the work request, you can see that create instance in pool and create instance from instance configuration. These are the operations that are currently in progress. And why is this instance getting launched? Because we generated the stress. And if you look at the metrics, you see that the CPU utilization actually went up, right? So it's currently 100%. And based on what we have defined in the auto-scaling configuration, if the CPU utilization is greater than 85%, then I define the condition to add an instance. And hence, this instance is now added and the instance count is now back to 2. So this instance is now added. So this marks the end of this demonstration. In this lesson, we will look at Oracle Cloud Agent. So let's get started. Oracle Cloud Agent is a lightweight process that manages plugins running on compute instances. It is installed by default on current platform images, and plugins are installed as a part of Oracle Cloud Agent. Now, what do these plugins do? Plugins collect performance metrics, install operating system updates, and perform other instance management tasks. Now, to use plugins on an instance, the Oracle Cloud Agent software must be installed on the instance, the plugins must be enabled, and the plugins must be running. Now let's look at some of the plugin examples. The first is Bastion. In OCI, there is a service that is known as OCI Bastion, which provides restricted and time-limited secure access to resources that don't have public endpoint. So to use Bastion service, you require the Bastion plugin to be enabled and running on the instance. The second example is OSMS Agent. In order for the operating system management service to manage patches and updates for the operating system environment in an instance, you require the OSMS plugin to be enabled and running. So as you can see here, these are the plugins that are available. We talked about a couple of them in the previous slide, but as you can see, there are other plugins like the compute instance run command, which facilitates running scripts within the instance using the run command feature. You can also see that you can enable or disable a plugin. Now, if you create an instance using a current platform image, then Oracle Cloud Agent is installed by default. However, it is also possible to manually install the Oracle Cloud Agent software on an instance that uses another supported image. In this lesson, we will discuss OS Management Service. So let's get started. OS Management is an Oracle Cloud Infrastructure service that provides automated operating system patch and package management for Oracle Linux and Windows. It is a fully integrated service and is available to you within the OCI console. And it is a free service if you are a subscriber to OCI. As you can see in this slide, operating system service helps you to manage patches and updates on compute instances. So you can see that there are 4 available security updates and 4 updates related to bug, and you can install these updates. In this slide, you can see the list of the Oracle Linux and Windows platform images where operating system management service is supported. The key takeaway from this slide is that it supports only Oracle Linux and Windows operating systems. So you can use operating system management service to manage and monitor updates and patches for the operating system environments. OS Management Service also provides a search facility that you can use to check individual common vulnerabilities and exposures, which are also known as CVEs, to determine the level of exposure in your tenancy. For Linux instances, OS Management also provides a search facility that you can use to check individual packages. Before you can get started with the operating system management service, you need to complete some prerequisites. The very first thing that you need to do is to create a dynamic group. And as you can see in the slide, I have a dynamic group with the name testdg. And now you need to set up IAM policies, and you can see the policy statements that I have added. Allow service OSMS to read instances in tenancy. Allow dynamic group testdg that I created to read instance family in tenancy, and allow dynamic group testdg to use OSMS managed instances in tenancy. You also need to ensure that the Oracle Cloud Agent software is installed and running on the instance and is enabled. In the available package updates section, you can see all available packages for the instance, and then you can select one or more package updates to install, which you can install immediately or you can schedule at a later date. OS Management uses this concept of software sources to provide packages to instances and to track and manage the available updates to those packages. You can think of a software source as a collection of packages, and it allows you to control which packages can be installed on instances without having to manually log in and configure the repositories on each instance. Then there is a concept of managed instance groups. It enables you to group instances together for scheduling updates. You can create managed instance groups for Linux and Windows instances. Managed instance groups must be composed of instances that are of the same operating system family and release. For example, here I am creating a managed instance group for Oracle Linux 7 instances. OS Management Service also provides a common vulnerability and exposure lookup tool, which you can use to search for a CVE and drill down to a specific affected package. And it is also going to provide you the file list and dependency information. The CVE search facility enables you to search for a common vulnerability exposure, to see the packages and instances affected by the CVE, and to push out package updates to instances to patch them. In this demonstration, I am going to show you how you can work with Operating System Management Service. So let's get started. Now, as you can see, I am inside the OCI console and there are 4 instances running. So instance 1 is Oracle Linux 8. Similarly, instance 2 is also Oracle Linux 8. And then I have instances 3 and 4 that are running Windows 2019. So these are the 4 instances that are running. Now, before I go to the operating system management service, let me first take you to the identity and access management service, where I want to show you the dynamic group that I have created. So I have created a dynamic group, OCI demo Sumwit DG, and this dynamic group has some rules that are defined. So you can either include all the instances that are running in a particular compartment, or you can specify the individual instance OSIDs. So in this case, I have specified the individual instance OSIDs of all the 4 instances that are running in my environment. So that is the first thing. Now the second thing is with respect to policies. Before you can work with operating system management service, you need to create a policy. I have created a policy and you can see these are the statements. I am allowing the service operating system management service or OSMS to read instances in tenancy, and then I am allowing the dynamic group, the one that I created, to read instance family in tenancy, allow dynamic group, the one that I created, to use OSMS managed instances in tenancy. So these are the policy statements that you need to write before you can work with the operating system management service. Now let me take you to this particular instance and show you one more thing. So if I go to the Oracle Cloud Agent, I will be able to see that the operating system management service agent is running. Similarly, you can also see that for this instance too. So the plugin is enabled and it is currently running. So this is also a prerequisite. You need to have the OSMS agent running. Now let me go to this particular instance and scroll down. So under resources, you will see the option of operating system management. So let me click on it. And as you can see, you are able to view the available updates, be it with respect to enhancement, security, or bugs. And you can also see the operating system, the kernel, and the effective kernel. So if you click here, you can install all the updates, or you can install security updates. And you also have the option to view operating system management details. So let me go there. So now if I go to this operating system management service, the very first thing I can do is I can create a managed instance group. So let me create one. So you can create managed instance groups for Linux and Windows instances. Please note that the managed instance groups must be composed of instances that are of the same operating system family and release. What it means is you cannot include Oracle Linux 8 instances in a managed instance group that contains Oracle Linux 7 instances. So let me create the instance group for Linux first. Click on create. So once the instance group gets created, I can add managed instances. So this is the group that I created for Linux. So I will add the Linux instances. So now as you can see, I am able to see both the instances, instance 1 OEL8 and instance 2 OEL8. So I will select both and I will click on add managed instances. Similarly, I can create one for Windows. Now if I go back, if I go to the managed instance groups, here if you click on the ellipses, you can install the package, you can remove a package, you can install update, you can install all updates. So let me do that. Let me install all the updates and I want to install it now. This is the scheduled job, install all updates. So if I go inside that, I can find the associated target. This is basically the instance group. Now if I go to the operating system management service, you can go to the packages and you can use the search box to look up packages by name. Similarly, you can also go and look up a specific common vulnerability exposure. Now let me go to the second instance. Go to this operating system management service and view the operating system management details. So here you can see the available package updates. And in case you want to, let's say, update this one. So here you can see the available version, the installed version, and what is the architecture, what is the type of the package update. In this scenario, it is a bug fix. So I can just go ahead and click on install update. I can basically install it now, or I can also define a custom schedule. So the moment you click on install, you will be able to monitor the work request. And as you can see, I am performing a package update. So in some time, you will see that it is completed. So as you can see, the package install or upgrade has successfully completed. So if I return back to this operating system management service, under the schedule jobs, you are able to see install all updates. And this is the associated target. And you can also monitor the associated work request from here. For example, a case splice update. You see that this work request is also completed. Now, if I go to the Windows instance and I go to the operating system management service, here I can also see the available updates in terms of security bug enhancement, install security updates. Currently, this has been scheduled. And you can also have a look at the available updates. For example, this is the cumulative update for .NET Framework. So I can basically go ahead and look at the details. I can also look at the corresponding KB article and the size information, whether reboot is required. So if I want to install it, I'll just select it and click on install updates. So it is giving me a warning. You have selected one or more updates which require a reboot of this Windows instance, and I can just define a custom schedule. For example, I want to install it on 19th and this particular time. Right? So these are the things that you can perform. So this is how, using the operating system management service, you can manage and monitor updates and patches for the operating system environments. In this lesson, we will talk about run command. So let's get started. So what is a run command? Well, using run command, you can remotely configure, manage, and troubleshoot compute instances by running scripts within the instance. You can run commands on an instance even when the instance does not have SSH access or open inbound ports. The run command feature is supported on compute instances that use the platform images. So Oracle Autonomous Linux, Oracle Linux, CentOS, and Windows Server are supported, but Ubuntu is not supported. On Linux instances, the script runs in a bash shell by default, and on Windows instances, the script runs as a batch file. The maximum size for a script file that you can upload directly to an instance in plain text is 4 KB. To provide a larger file, save the file in an object storage location. The output of a script when returned as plain text is limited to last 1 KB. To save a larger response, you can save the output to an object storage location. Now let's look at some of the examples. We can use the run command to automate tasks such as configuring secondary virtual network interface cards. We can also use it to troubleshoot SSH connectivity. In this demonstration, I will show you how you can use run command. So let's get started. As you can see, I am currently inside the OCI console in Phoenix region, and currently I am logged in as my tenancy administrator. So let me first go to identity and security. I'll go to identity. I'll click on domains. Click on default. And if I click on groups, and I should be able to see the compute admins group. Now let me return back to identity. Go to policies. Click on create policy. Give it a name. I'll use the same as the description and select the root compartment. In the policy builder, show manual editor. And now here I'll specify a policy that will allow the users to issue commands, cancel commands, and view the command output for the instances in a particular compartment. So this is basically the policy statement. Allow group compute admins to manage instance agent command family in tenancy. So I'll click on create. So that's done. Now I will return to identity. Click on domains. I'll go to the default domain. Click on dynamic groups. So let me create a dynamic group that is going to include the instance that I want to allow commands to run on. Click on create dynamic group. I will call it demo DG, demo DG, and here I'll open up the rule builder and I'll specify the value of the instance OSID. Now if I just open a duplicate tab, let me show you the instance that is currently running. So this is the instance that I'm going to use, instance run command, for this particular demonstration. So I'll go to this instance, I'll copy the OSID and I will put it here. Click on add rule. Click on create. So the name of the dynamic group is demo DG. Let me just copy this. So now I will return back to identity. Click on policies. Click on run command policy. Click on edit policy statements. Add another statement. So here I am allowing access to the dynamic group. Allow dynamic group demo DG that we created to use instance agent command execution family in tenancy where request.instanceiD equals target.instanceiD. So let me click on save changes. You see that currently I'm logged in as the tenancy administrator. So let me sign out and sign in as the compute admin. So I will use the compute admin user, which is a member of compute admins. So let me sign in. Let me go to the compute instances. So the next thing that I need to do is go to this particular instance, go to Oracle Cloud Agent and ensure that the plugin is running. So the compute instance run command plugin is currently enabled and is running. So now we will go and connect to this particular instance. So I'll just SSH. So there you go. We are now connected. So let me now go ahead and run a particular command. So basically I need to allow the OCA run user to run all commands as sudo. For that, I'm going to add this particular line to the configuration file. And then I'm going to validate that the syntax in the configuration file is correct. So if the syntax is correct, I get to see this particular message passed OK. Now let me add the configuration file to /etc/sudoos.d. Alright, so I'm done. Now let me minimize this and scroll down. Under resources, let me go to run command. Now let me click on create command. I will just give it a name. Run command demo. I'm okay with the default timeout, 3600 seconds. And then when it comes to adding the script, I can paste the script directly here. I can select a file. I can import from an object storage bucket or import from an object storage URL. So I am going to provide a very simple command that is going to install the Apache web server and going to display a test page. So let me just paste the script over here. You see sudo yum install httpd and then I'm starting the service. Now when it comes to output, I can output as text, I can output to an object storage bucket, and I can also output to an object storage URL. So let me click on create command. So you see that currently the delivery status is visible and the execution status is accepted. So now you see that the delivery status is acknowledged and the execution status is accepted. And there you go. You see that the run command demo has now executed successfully. So the delivery status is acknowledged and the execution status is succeeded. So if I just go ahead and open the public IP of this particular instance, I should be able to see the test page. This is a test page. So now I know that it's working correctly. And if I click on view command details, this is the response and you can see the output.
In this lesson, we will look at instance console connection. So let's get started.
The idea of a console connection is to give you a display of what is happening during the boot process. So you can remotely troubleshoot malfunctioning instances using console connections. And this is a special case which you do not use for normal operations, but for troubleshooting. And as you can see here, there are two options. The first is you can launch Cloud Shell connection. The Cloud Shell integration automatically creates the instance console connection and a temporary SSH key. And then you can create a local connection. When you create a local connection, you need to generate an SSH key pair, or you can also upload your own public key. Now let's look at the two types of instance console connections. The first is serial console connection. It is mainly used for Linux servers and other CLI-based operating systems. After you create the console connection for the instance, you can connect to the serial console using a secure shell or SSH connection. The second type is VNC console connection. It is commonly used for connecting to servers that have graphical user interface. Now in this type, you need to set up a secure tunnel to the VNC server on the instance, and then you can connect with a VNC client. Please note that you cannot use Cloud Shell for VNC console connections. You can only use it for serial console connections. So what are the use cases of instance console connection? Once you are connected with an instance console connection, you can perform tasks like editing the system configuration files, adding or resetting the SSH keys for the OPC user. In case you have an imported image or a customized image that is not booting successfully, or you have an instance that was working fine but suddenly stops responding. So in these scenarios, you can make use of the instance console connections for troubleshooting. In this demonstration, I will show you how you can create a console connection. So let's get started. We know that using console connection, we can remotely troubleshoot malfunctioning instances. So let me show you how we can create a console connection. So as you can see, I'm logged into the OCI console. So I have this particular instance running, demo instance console connection. So I'll go to this instance. And if I scroll down under resources, you can see that there is an option of console connection. So let me click here. So there are two options, launch Cloud Shell connection, and then the second option is create local connection. Let me first show you how to launch a Cloud Shell connection. So let me click here. The moment you click here, it is automatically going to make a console connection. So you don't need to enter any username or any password. Waiting for instance console connection to complete transition, current state is creating. And there you go. Now this console connection is as good as you are sitting in front of the machine. So you can basically see all the messages that you see on your computer. Now using this instance console connection, you can perform various tasks such as you can add or reset the SSH keys for the OPC user. You can edit system configuration files. These tasks require you to boot into a bash shell in maintenance mode. So let me click on reboot. Let me click on reboot instance. And then you can see that the instance is stopping and you are able to see all the messages. For example, stopped dynamic system tuning daemon, and you see power down. So I can press escape or F5. You see that currently it is stopping. So now let me maximize it. I currently have the option to go to the boot manager, right? So these are the options, boot manager menu. So what I will do is I will just escape and I can just click on continue. Here it says the instance is running, and here you can see the corresponding messages. Started open as Cassie. So this was the first thing, using Cloud Shell, how you can create an instance console connection. So let me exit. Let me go to the console connection. Now let me show you one more thing. If I try to create a local connection, it is first going to give me a message to delete the existing connection. So you can only have one console connection open at a time. Now if I return here, Last time I created a Cloud Shell connection, so that is now deleted. Now let me create a local connection. When you create a local console connection, you must upload a public key file. So let me do that. This is my public key. I'll click on Create Console Connection. So as you can see, the local console connection is now active. So if I click on the ellipsis, I get all these options. So this time, let me go ahead and copy the VNC connection for Windows. So I'll copy it. So this was the command that I copied. Now the only thing that I will change here is I will change the path for my private key. So here, if you see, this is the home path. Here I will put the path of my private key. So it will appear in two places. So you have to replace that in two places. Yeah, so that's done. Copy this command. Now let me open up the PowerShell, paste the command that I copied. So now you can see that this background job is running and the access has been granted. All right, so I can keep it open. So after the connection is established, open the VNC client and specify localhost as the host and 5900 as the port to use. Click on continue. So there you go. So this time we are not using Cloud Shell, rather we are using VNC Viewer. Alright, so this marks the end of this demonstration where I have shown you how you can launch Cloud Shell console connection as well as create a local connection. In this lesson, we will look at infrastructure maintenance. So let's get started. Maintenance is a necessary part of any environment. Oracle Cloud Infrastructure also performs routine maintenance on the physical infrastructure for virtual machine instances. And Oracle Cloud Infrastructure strives to minimize this inconvenience by offering different options to relocate the virtual machines. The first option is live migration. Then there is reboot migration and finally manual migration. Let's first look at live migration. During an infrastructure maintenance event, OCI live migrates supported virtual machine instances from the physical VM host that needs maintenance to a healthy VM host. Please note that there is a minimal disruption to running instances. When a live migration begins and ends, an infrastructure maintenance event is emitted. And live migration is only supported by Linux operating systems and restricted to specific shapes. Now, if the virtual machine instance does not support live migration, OCI schedules a due date for reboot migration within 14 to 16 days, and it also sends you a notification. If you do not proactively reboot the instance before the due date, the instance is stopped and migrated to a healthy host and restarted. Please note that there is a short downtime that occurs during the migration. You can control when the downtime occurs by proactively reboot migrating the instance before the maintenance due date. One more call out here is that rebooting the operating system is not the same as rebooting the instance from the console, CLI or API. The operating system reboot does not trigger the migration. Despite all efforts, sometimes a manual migration will be required. For instances without a date in the reboot maintenance field, you must move the instance manually. In this scenario, the instance will need to be terminated and recreated. When it is time to terminate, don't forget to preserve the boot volume. Now, when the underlying infrastructure of a virtual machine instance fails, OCI automatically attempts to recover the instance. Standard virtual machine instances are recovered using a reboot migration, which automatically restores the virtual machine on a healthy host. Dense IO VMs are recovered by rebooting the instance on the same physical host. If recovering a dense IO instance on the same physical host is not possible, then OCI notifies you to delete or terminate the instance within 14 days. If you don't delete the instance before the deadline, OCI disables the instance on the deadline and deletes it within the next 7 days. However, the boot volume and the remote attached data volumes are preserved. In this lesson, we will look at shielded instances. So let's get started. Threats like rootkits and bootkits that have kernel-level privileges can infect the firmware and operating system and are very difficult to detect. Shielded instances protect virtual machines and bare metal instances against these low-level threats. Enabling shielded instances is simple. You need to follow the standard instance deployment flow. Images and shapes that support the shielded instances have a shield icon next to the image and shape. When you choose the image and shape that support shielded instances, you can enable secure and measured boot in the advanced options. Enabling measured boot for virtual machines automatically enables Trusted Platform module as well. Now, shielded instance use a combination of secure boot, measured boot, and Trusted Platform module. Secure boot and Trusted Platform module are available on all supported bare metal and virtual machine instances. Measured boot is only available on VM instances. Now, these services are provided for the OCI platform at no charge. Now, let's first look at Secure Boot. Secure Boot is a unified extensible firmware interface feature that prevents unauthorized bootloaders and operating systems from booting. So boot components that are not properly signed are not allowed to run, preventing the system from booting. The next feature is Measured Boot. Measured Boot complements and enhances Secure Boot by storing measurements of boot components such as bootloaders, drivers, and operating systems. And it verifies that these measurements don't change from one boot to the next. The final feature is Trusted Platform module. So Trusted Platform module is a specialized security chip that is used by the measured boot to store the boot measurements securely. Enabling measured boot for virtual machines automatically enables the virtual Trusted Platform module. Measurements taken by measured boot are stored in platform configuration registers, also known as PCRs, inside the Trusted Platform module. And a PCR is basically a memory location in the TPM that is used to hold a value that summarizes all the measurement results. In this demonstration, I will show you how you can create a shielded instance. So let's get started. As you can see, I am currently inside the OCI console. So let me go ahead and create an instance. So I will call it demo instance shielded. And I'm going to create it in this particular compartment. Under the placement, I will select availability domain, and I am fine with the capacity type as on demand. Then under image and shape, let me take you to the Oracle documentation and show you the supported shapes and images for your shielded instance. So these are the supported shapes and images that you can use to create shielded instance, right? So this is the list, and you can also see the supported platform images over here. Now let me return back, and as you can see, if I click on change image, when you browse through all the images, so for example, this Oracle Linux, if you just see here, it says this image supports shielded instances, right? So I'll go with Oracle Linux 8. And then with respect to shape, again, you have to select a shape with the shield icon. So I will go with the specialty and previous generation. And as you can see, these instances, they do not support shielded instance. But if I scroll down, you see this, these are the instances that support shielded instance. And you can also see the list over here. So let me go ahead and select this one, VM.standard 2.1, as it supports shielded instances. So let me click on select shape. So now both my image and shape, they support shielded instance. So now I can click on show advanced options. Let me first enable secure boot. And then in case you want to enable measured boot, please note that this option is available only for VM instances. So if I select this, then the Trusted Platform module is automatically selected because the TPM is required by the measured boot. So rest everything remains the same. I will go with the existing VCN. I don't require any SSH keys. So I'll click on create. So I will wait for the instance provisioning to complete, and then I will show you a couple of things. Alright, so we see that the demo instance is now created, and you can see that this instance is also shielded. Now there are two things. In case you want to download the PCR values, and PCR stands for Platform Configuration Register. So in case you'd like to download that, you can go to the shielded instance tab and just click on copy PCR values, and the PCR values gets copied to the clipboard. Now that is one thing. Please note that this platform configuration register is a memory location in the trusted platform module that stores the golden measurements. Now in case you update your operating system, then you might need to create new golden measurement. So how do we reset the golden measurement? So just click on reset golden measurements. So it is giving me a prompt that the current baseline values will be replaced with new values. So let me click on reset, and there you go. The golden measurements are now updated. In this lesson, we will look at the overview of object storage. So let's get started. This slide provides a summary of OCI storage services. Our focus in this section is going to be on object storage and archive storage. So as you can see, these services provide unlimited capacity with high durability, and you can store objects that are up to 10 TB, and 1 TB equals nearly 1.1 TB. For storing unstructured data like images, videos, we use object storage, and for long-term archival needs, we use archive storage. So object storage is a highly durable, scalable, secure, cost-efficient, internet-scale and high-performance storage platform. It's also highly reliable, and the service is designed for 99.9% availability. You can store unlimited amount of data in Oracle Object Storage. You can create thousands of buckets per account, and each bucket can host an unlimited number of objects. Stored objects can be as small as 0 bytes or as large as 10 TB. It is designed for unstructured data. For example, you can store images, videos, and analytic data. It is a regional service, and you can access the data from anywhere using object storage endpoints. It also supports private access from OCI resources in a VCN through a service gateway. So you can connect to the object storage public endpoints using private IP addresses in a private subnet. And it offers cost and performance flexibility using multiple storage tiers. So there are 3 storage tiers: standard, infrequent access, and archive tier. Now let's look at some of the use cases of object storage. Object storage provides highly available and durable content repository for data, images, logs, and videos. We can use object storage to store application log data for analysis and troubleshooting purposes. It is optimized for unstructured and semi-structured data. We can use it as a primary data repository for big data, and it can also be used to preserve data for longer periods of time. In this lesson, we will talk about object storage resources. So let's get started. The first construct is namespace. Think of it like a top-level container for all buckets and objects. At account creation time, each OCI tenant is assigned one unique object storage namespace. The data that you store in the object storage is stored as an object along with its metadata. And then we have the bucket, which is a logical container for storing objects. The name for a bucket has to be unique in a region within each tenancy. For example, you can create a bucket named Demo Bucket in India West or the Mumbai region. What it means is you cannot create another bucket with the same name Demo Bucket in the Mumbai region, but you can create a bucket with the same name Demo Bucket in India South or the Hyderabad region. Please note that within an object storage namespace, buckets and objects exist in a flat structure or the flat hierarchy. Now let's see how the object storage endpoint looks like. In this example, the object name is oci.jpg, the bucket name is training, and the namespace name is OCI Arc Associate. So this is how we construct the object storage endpoint. So you can see the object name is after the /o, the bucket name is after /b, and /n. After that, we have the namespace name. And you can also see the service name, that is object storage, and the region name in the endpoint. We previously discussed that buckets and objects exist in a flat hierarchy, but we can simulate a directory structure by adding a prefix string that includes one or more forward slashes to an object name. For example, here you can see that oci.jpg is the object name, and we have created a prefix training/OCI. So as you can see here, we have created a prefix training/OCI, and this oci.jpg, this is basically the object name. Can you think of any benefit of using prefixes? Well, using prefixes, we can perform bulk deletes and bulk downloads of all the objects using CLI or API. And we can also use the console to display hierarchical view of objects, as you can see in this screenshot. In this lesson, we will talk about object storage characteristics. So let's get started. When a read request is made, object storage always serves the most recent copy of the data that was written to the system. Hence, it provides strong consistency. Object storage is designed to be highly durable, providing 11 nines durability. It achieves this by storing each object redundantly across 3 different availability domains for regions with multiple availability domains, and in case of a region with single availability domain, it stores the object redundantly across 3 different fault domains. Data integrity is actively monitored using checksums, and corrupt data is detected and automatically repaired. Any loss in data redundancy is detected, and without customer intervention or impact, remediation is performed. From a security standpoint, all the stored data is encrypted by default, and the service is also tightly integrated with OCI Identity and Access Management Service. Data is uploaded and downloaded over SSL endpoints using HTTPS protocol. You can store unlimited amount of data in object storage. You can create thousands of buckets per account, and each bucket can host an unlimited number of objects. The stored objects can be as small as 0 bytes and as large as 10 TB. In this demonstration, I am going to show you how you can create a bucket using OCI Console, Cloud Shell, and OCI CLI. So first things first, let me go ahead and log in to the OCI Console using a tenancy administrator account. So let me go ahead and open cloud.oracle.com. I'll provide my cloud account name. I'm using the default identity domain, so I'll just provide the credentials of a tenancy administrator. And click on sign in. So once I am inside this OCI console, let me quickly show you some of the things that you need to set up as a prerequisite. So the first thing that you see here is I'm logged in as OCI Arc Associate at gmail.com. So this particular user is the tenancy administrator of this particular tenancy, right? And I'm using the default identity domain. So let me go ahead and show you what I have done before I go ahead and show you the creation process of a bucket. So if I go to identity and security and then go to identity, go to the default identity domain, and then if I go to users, I just want to show you one of the users that I have created that is going to act like the storage administrator. And this is the account that I will be using to show you the demonstrations for the storage module, right? So as you can see, storage admin is the user that I have created. This user is a member of storage admins group, right? And then what I have also done is I have gone ahead and assigned a policy to this particular group. So as you can see here, storage admins policy, allow group storage admins to manage buckets in tenancy, and allow group storage admins to manage objects in tenancy. So these are the two policy statements that I have written. And then very quickly, let's do one thing. Let me use another browser and log in to the OCI console using the storage admin. So let me go ahead and log in. So you see that currently I am logged in as storage admin, right? So this is not the tenancy administrator. Rather, think of it like a storage administrator. Now coming to the point, let's first go ahead and create a bucket using the OCI console. So to create a bucket, click on the hamburger menu, go to storage, go to object storage and archive storage. Now you see that I currently don't have a bucket, right? So let me go ahead and click on create a bucket. I will give my bucket a name. So for the sake of consistency, I'm going to follow a particular nomenclature. As I'm creating this bucket using the console, so I have named it OCI Architect Associate AA bucket and console, right? Now you see there is an option of default storage tier. So basically there are two options at bucket creation level. You can go for standard storage tier. Now if you select standard storage tier, it can basically contain a mix of objects with different storage tier assignments. If you go for archive default storage tier, it can only contain objects with an archive storage tier assignment. And once you set this particular property, default storage tier, while creating a bucket, you cannot change this particular thing after the bucket creation. So whatever you specify, if I specify standard, I cannot make it archive at a later point of time. If I specify archive, I cannot make it a standard default storage tier. So I will go with standard default storage tier. Now you also see that there are other options as well with respect to enabling auto tiering, enabling object versioning, creating automation based on object state changes using the OCI event service, and you can also perform an uncommitted multi-part uploads cleanup. So as of now, we are not enabling anything. We are subsequently going to look at each of these options in detail in the upcoming lessons and demonstrations. From an encryption standpoint, I'm using the default option, that is encrypt using Oracle managed keys. And let me go ahead and click on create a bucket. So you see that this bucket is now created. The default storage tier is standard and the visibility is private. Now this was using the console. And remember, we are signed in using the storage admin, right? So let me go ahead and launch the Cloud Shell. But before I do that, let me quickly show you the policy that you require for this. So if I go to identity and security, go to identity, click on policies. So this is basically the policy to access Cloud Shell. As I'm not using a tenancy administrator account, I need to explicitly define a policy to access Cloud Shell. And I have basically done that. If I basically show you how it looks like, you see allow group storage admins to use Cloud Shell in tenancy, right? So this is the policy you require. And I'm showing you all this because in case you are following along with me, you will not face any issues. Now let me return back to the OCI console, and you see that currently I'm signed in using the storage admin account. Let me go ahead and launch the Cloud Shell. As you can see, it is creating your Cloud Shell machine. And once it is available, let me just go ahead and clear it. Now let me just type the command to create a bucket using Cloud Shell, right? And I will talk about what parameters are required when you basically provide this command. So the way it works, and let me first show you. As of now, I just have one bucket, right? So I will go ahead and create another bucket. And the syntax is OCI object storage bucket create. And then you have to specify the name of the bucket. So this is the name that I'm going to use. And apart from this name, I also need to provide another parameter, that is your compartment ID. So I will go ahead and specify this. So let me go ahead and just copy the compartment ID. So I'll go to identity, go to compartments. This is the compartment that I'm using for all the demonstrations. So I will just go ahead and copy the OSID. Yeah, so there we go. So remember, the required parameters are compartment ID and the name of the bucket. So let me go ahead and press enter. So as you can see, the bucket is now created. And if you want to confirm, you can just go ahead and have a look at the list of the buckets. So initially we had one OCI AA bucket console. Now we also have another bucket, OCI AA bucket Cloud Shell. Now the third thing that I quickly want to show you is how you can go ahead and create a bucket using the OCI CLI, right? CLI stands for Command Line Interface. So with respect to CLI, the first thing that you need to do is to install the CLI. I have already gone ahead and installed the CLI, but you can basically go ahead and see the instructions over here, right? Go to this particular URL, and based on the operating system that you are using, you can find the necessary instructions regarding the installation of the CLI. So I am using Windows and I have followed these particular instructions, this 5-6 steps, right? To go ahead and install the CLI. So once the CLI is installed, the next thing that you need to do is to run few commands. So since CLI is already installed, I will go ahead and just fire this command. OCI setup config. Now once you fire this command, it is basically going to ask you a location for your configuration. I am okay with the default location. I will just press enter. Now it is asking you for the user OSID. So remember, we are using storage admin. So I basically need to provide the storage admin OSID. So this is the storage admin, and I will copy the OSID. I will basically provide it here. Now it is asking for the tenancy OSID. Now for the tenancy OSID, you just need to go to this tenancy and you can copy the OSID. So this is basically my tenancy. So here I can provide the tenancy OSID. Now it is asking me for the location. Now remember, all these demonstrations we are performing in US West or Phoenix region. right? So I basically need to provide a code for the Phoenix region. So as you can see here, 40 is the code for US Phoenix 1, right? So I can just enter the name of the region, or I can just enter the index. So that is 40. Now it is asking me whether I need to generate a new API signing RSA key pair. So I will just put Y. And then it is asking me for a directory for my keys to be created, right? So I am okay with the default directory. The name for your key, I'm okay with the default. Just press enter. So now that we are done with the configuration of the OCI CLI, the next thing that I need to do is I need to add the signing key, right? So API signing key. So how do I do that? So let me take you to this particular directory where we have generated the key pair. And as you can see, this is my public key, right? So I'll just open this public key. I'll just copy this public key, and then I will go to the identity and security. Basically, I will go to the user page. Because I will be using the storage admin user to perform all the operations, so I need to add the signing key. Okay, so I am inside the storage admin user. So I'll go to the API keys and I'll click on add API key. And here, because we already have copied the public key, so I'm just going to paste it over here and click on add. So this way we are taking care of the authentication. Now we basically need to go ahead and create the bucket. So I will be firing the command. The command is going to be the same that we fired using the Cloud Shell. OCI object storage bucket create the name of the bucket, right? Remember the nomenclature that we are using. OCI a bucket, and I've specified OCI CLI. Now, the only thing that we need to specify is the compartment ID. I'm using the root compartment, so I'll just go ahead and copy this and just paste it here. Let me press enter. Now, as you can see, this bucket is now successfully created. I can go to my OCI console. And as you can see, initially we had 2 buckets. Now we are also able to see the third bucket. So this marks the end of this demonstration where we looked at how we can create a bucket using the OCI console, Cloud Shell, and OCI CLI. In this demonstration, I am going to show you how you can upload and access the objects. And I am also going to show you the options with respect to bucket visibility. So let's get started. I am inside the OCI console, and as you can see, we have created 3 buckets. So let me go to a particular bucket. And then let me scroll down and go to objects and click on upload. So here the very first option that you see is with respect to the object name prefix, OCI training / so this is the prefix that I'm going to use, right? And then there are 3 different storage tiers: standard, infrequent access, and archive. So the standard tier is meant for objects that are frequently accessed. Infrequent access is a tier that is meant for objects that are accessed infrequently. And then there is a cold tier with the name archive tier, right? That is meant for objects that are rarely accessed. Because we created a bucket of the type standard, and let me very quickly show you that. You see, the bucket, the default storage tier is standard. And that is the reason why we are basically able to see 3 different storage tier options while uploading the objects. Had we created the bucket with the default storage tier as archive, we would have only got the option to see archive storage tier or use that particular tier. Okay, so just wanted to quickly show you this. Let me again specify the prefix. All right. Now I need to choose the files from the computer, right? So I'll just select the files. I have a sample image. So let me go ahead and upload it, right? So let me click on this upload button. Okay, so the upload is finished and let me click on close. So this is the object, right? And because we specified the prefix, you are able to see OCI. Then under the training directory, you are basically able to see the sample.jpg, right? So although this object storage has got a flat hierarchy, but you can simulate a directory-like structure using prefixes. And that is what I have done, right? So if I go to this particular object and I click on view object details, and this is basically the URL path. Now, if I try to access this, you will not be able to access this particular object, right? And can you guess what's the reason? The reason is this visibility of the bucket is private, right? So if the visibility is private, you cannot go ahead and access this using the URL. So what do I need to do? The very first thing that I should configure is edit the visibility. And when you edit the visibility and make it public, what you are facilitating? You are basically facilitating anonymous and unauthenticated users to go ahead and access this particular object that is stored inside this bucket. And remember, we edit the visibility at a bucket level. And this is not the best practice. In the subsequent lectures and demonstrations, we are going to talk about a concept that is known as pre-authenticated request, right? But as of now, just to show you how to access the object, I'm making it public. And you see, it is also giving you a warning to use pre-authenticated requests instead of making the bucket public. So let me go ahead and click on Save Changes. So I have gone ahead and made the bucket as public. Now if I go here and just refresh this page, I should be able to see this Oracle Cloud Infrastructure image, right? So what we did, we used this particular bucket to upload an object inside it. And then we tried to access that object. I also talked about the visibility thing. Now let's do one more thing. Let's use the Cloud Shell to upload an object, right? And I'll also show you the syntax. So let me just open up the Cloud Shell thing. And here I will basically fire a command. Even before that, if you see, I have already uploaded sample.jpg, right? So what I will do is I will just go ahead and fire that command. OCI object storage object put. Now I need to specify the bucket name. So what is the bucket name that we are going to use? We are going to use this particular bucket, this one. And then I need to specify the file name. So I'll just specify a sample. Perfect. So this is how the syntax looks like. Now, if I just press enter, my object will be uploaded. And as you can see, uploading object is now 100%. I can validate the same from inside the console. So let me go to this particular bucket. And as you can see, sample.jpg is now uploaded. But we did not upload it using this upload button. Rather, we used Cloud Shell for that, right? And similar to what we have already demonstrated, you can change the visibility and then you might try to access this particular object, and that should work, right? So this marks the end of this demonstration.
In this lesson, we will talk about multi-part uploads. So let's get started. Multi-part upload uploads data in parallel and are faster and more efficient than uploading a large object in a single upload. If a multi-part upload fails for any reason, instead of restarting the entire object, you will only need to retry uploading the part of the object that failed. The recommendation from Oracle is, if the object size is greater than 100 MB, we should consider using multi-part uploads. An object can be divided into a maximum of 10,000 parts. Each part must be at least 10 MB in size, and the upper limit of an object part is 50 GB. And you have the flexibility to pause uploads of individual parts and resume the upload when schedule and resources allow. Now, as you can see in this slide, you can use object lifecycle policy rules to automatically delete any uncommitted or failed multi-part upload after a specific number of days. And you can perform this operation using the OCI console. Now, in this slide, we will see how multi-part uploads can be performed using the multi-part upload API. The very first thing is, before you initiate an upload, you need to create the parts. And as you can see here, the object size is around 200 MBs, and we are splitting that into 10 parts of 20 MB each. The next step is to initiate an upload. So by making a create multi-part upload REST API call, object storage is going to provide an upload ID, and the upload is marked as active, and it remains active until you commit or abort it. The third step is to upload object parts. So you have to make an upload part request, and the object storage is going to return an entity tag value for each part uploaded. So whenever you will be committing the upload, you require both the part number and the corresponding e-tag value for each part. The final step is to commit the upload. You have to make a commit multi-part upload request, and when you commit the upload, the object storage is going to reconstruct the object from its constituent parts. So these are basically the steps that are required to perform a multi-part upload using multi-part upload API. Now let's look at how we can perform multi-part uploads using the CLI. There are some differences in this approach as compared to using the API. Firstly, there is no need to split the object into parts. We just need to specify the part size, and the object storage is going to split the object into parts. We can choose to set the maximum number of parts to be uploaded in parallel. Secondly, we don't have to perform any commit after the upload is complete. So if you are performing multi-part uploads using CLI, you have to use this particular command. The point that you need to note here is that you have to specify the mandatory part size flag, and the value must be an integer. And this basically denotes the size of each part in megabytes. Optionally, we can also use parallel upload count to set the maximum number of parallel uploads allowed.
In this demonstration, I am going to show you how you can use the OCI CLI to perform multi-part uploads. So let's get started.
We have discussed in the theory lesson that multi-part upload uploads the data in parallel and is faster and more efficient than uploading a large object in a single upload. And the recommendation from Oracle is, if the object size is greater than 100 megabytes, you should consider using multi-part upload. Now, when we use the CLI to perform a multi-part upload, we do not need to split the objects into parts, right? So what we need to do is, we can simply specify the part size and the service is going to split the object into parts. We also have an option to specify the maximum number of parallel uploads that are allowed, right? So I'll talk about the different flags that you can use. So let me go ahead and use the Windows PowerShell. And how does the command look like? OCI, the name of the service, OS, then object, put, what is the name of my bucket? I'm going to use this particular bucket, right? So this is OCI AA bucket and console. So I'll just use this. And what is the file name? Let me quickly show you the file name. This is the file name, ocitest.bin. So I can basically go ahead and specify this. Remember, this is the file name. This is basically the object name, but in case you want to specify a different name that you want to see after the upload, you can specify it here. And for the sake of demonstration, I will specify OCI test file, right? So this is the name and it is different from the file name. And I can specify .bin, OCI test file.bin. And now we are coming to an important option where we specify the part size. So part size basically denotes the size of each part in megabytes. And you also need to understand that the values must be an integer. So in this scenario, I will specify the part size as 20. And there is also an optional flag, which is known as parallel upload count, that you can use. And that basically sets the maximum number of parallel uploads that is allowed, right? So let me quickly set it up. So parallel upload count, and I will specify the number as 10. So let me enter and run this command. So as you can see, because we specified the part size of 20, you can see that the object storage is basically splitting the file into 50 parts for upload because it's a 1 gig file. And you can also see the upload ID over here. And now the uploading object operation is in progress, right? So currently it's around 48%. So currently it is 72%, and you can see the time that's remaining. So there are a couple of things that I need to call out. Because we are using the CLI, we don't need to split the objects into parts, right? We can simply specify the part size, and the service is responsible for splitting the object into parts. And as you can see here, the upload is successful. How do we validate that? So if I go to my OCI console, go inside this particular bucket, I can see that this is basically the file close to around 1 gig that I have uploaded, right? So this is the advantage of multi-part upload. It is really fast and it is more efficient when compared to uploading a large object in a single
upload. So I hope you got an idea of how to perform multi-part upload using OCI CLI. You just need to specify this mandatory flag. This is mandatory and this one is optional. So this concludes our demonstration. In this lesson, we will discuss how to manage buckets and objects. So let's get started. While specifying the bucket name or object name, please note that they are case sensitive. Secondly, you cannot nest buckets, which means a bucket cannot contain other buckets. You can store objects that are up to 10 TB, and you cannot edit or append the data to an object, but you can replace the entire object. You can also enable object versioning to retain previous versions of objects, and then there is a concept of pre-authenticated requests that provide a way to let you access a bucket or an object without having your own credentials. You can apply retention rules at the bucket level to provide immutable object storage options for data that is written to object storage. And what is the use case for that? The use case is governance, regulatory compliance, and legal requirements. Using a replication policy for a bucket, you can automatically replicate the objects in one object storage bucket to another bucket in the same or different region. Security zones ensure that your cloud resources comply with Oracle security principles. For example, the buckets in a security zone must be private. You can copy objects to other buckets in the same region and to buckets in other regions using this object copy feature. And using object lifecycle policies, you can automatically manage the archiving and deletion of objects according to a predefined schedule. We had a look at the overview of different features in this lesson. In this lesson, we will look at object storage tiers. So let's get started. Storage tiers help you maximize access performance where appropriate, as well as minimize storage costs. There are two options at bucket creation level with respect to storage tiers. The first option is standard storage tier bucket, which can contain a mix of objects with different storage tier assignments. And then the second option is archive storage tier bucket. It can only contain objects with an archive storage tier assignment. Now, when set at bucket creation, you cannot change the default storage tier for a bucket. And as you can see in this image, you specify the default storage tier during the creation of a bucket, and you can specify either standard or archive. Now, if the object is being uploaded to a standard default storage tier, you can explicitly assign any storage tier that is standard, infrequent access, or archive to the object. So just to reinforce, as you can see in the image, you can also change the storage tier for an object, but that will be the case only in case of a standard storage tier bucket. Now, every object that is uploaded to object storage is assigned to a storage tier, and that determines its storage cost as well as associated retrieval fees. There are three storage tiers. The first is standard. It is the default storage tier, and it is used for data that you need to access quickly, immediately, and frequently. It has higher storage cost compared to other tiers, and when you choose a standard default storage tier during bucket creation, you can also enable auto tiering. Now, some of the use cases for standard tier are content repository for scalable data, things like images, logs, and videos, and then data repository for Hadoop or big data workloads. The next tier that we have is infrequent access tier or cool tier. This is used for data that you access infrequently, but that must be available immediately when needed. Storage costs are lower than standard, but it also has a minimum storage retention period of 31 days.
You will be charged the prorated cost of storing the data for full 31 days in case you delete or overwrite objects in the infrequent access tier. When you need to access objects in the infrequent access tier, you are charged a per GB data retrieval fees. Use cases for infrequent access tier includes backup for on-premises data. The third tier is archive storage tier. It is meant for data that is rarely accessed but must be retained for long periods of time. Archive storage tier buckets can only contain objects with archive storage tier assignment. One thing that you have to note is that archive storage tier provides the lowest storage cost, and the objects in the archive tier must be restored before they are available for access. The minimum storage retention period for the archive tier is 90 days. And as we discussed, the objects must be restored before they are available for access. And when you restore objects, you are returning those objects to the standard tier for access. The restore time is close to an hour, and some of the use cases for archive tier include compliance and audit mandates and storing historical data. In this lesson, we will talk about auto-tiering. So let's get started. Just to reinforce what we learned in the previous lesson, a standard storage tier is optimized for data that you need to access quickly, immediately, and frequently. There are no retrieval charges and no retention period requirements. And then there is infrequent access storage tier that is ideal for data that is accessed infrequently. Compared to the standard tier, the storage costs are lower, but it also comes with minimum storage retention period requirement of 31 days and data retrieval fees. Now, auto-tiering determines which storage tier your data should be in based on your usage patterns. So the benefit is it saves the time from writing complex lifecycle policy rules or deliberating over which storage tier is best for your data. And as you can see in this diagram, the data was initially in the frequent access or the standard tier. Now, based on the access pattern, the service is going to move it to the infrequent access tier in case it is infrequently accessed, and later, if the objects are accessed more frequently, it is moved back to the standard tier. Now, this feature is enabled at a bucket level. If you enable auto-tiering, data access pattern is going to be monitored, and the feature does not cost you anything. Instead, it helps you reduce the cost by automatically moving objects larger than 1 MB from the standard to more cost-effective infrequent access tier. So it performs the transition of objects based on access patterns, and the best part about this is there are no retrieval charges and the storage costs are also prorated. Now let's look at some of the use cases for auto-tiering. Now, in case you have a new application data storage that has no established access patterns, then you can go for auto-tiering. The second use case is with respect to data storage that has changing access patterns. In this demonstration, I am going to show you how you can update the storage tier manually and how would you go ahead and enable the auto-tiering. So let's get started. So as you can see, I am inside the object storage. I am inside a particular bucket that I created. And inside the bucket, you can also see there are a couple of objects, right? For example, sample.jpg is one object. And the current storage tier is standard. Same is the case for OCI test file.bin. Now, how do I go ahead and update the storage tier manually? So I can just click here, update storage tier, and here you can specify any storage tier of your choice, right? For example, it can be infrequent access. So let me first do infrequent access, save the changes. Now you can see that the current storage tier for the sample.jpg is infrequent access. Now also want to show you one more thing. In case it is infrequent access, you can still go ahead and download the object, right? So you can click on download and the object would get downloaded. Now let me go ahead and update the storage tier from infrequent access to archive. And let me go ahead and click on save changes. So now you will see that the storage tier of sample.jpg is archive. And what is the difference? If I click here and try to download, you can see that the download option is grayed out. That means if an object is in the archive tier, you first need to restore it before you can go ahead and download the object. So let me go ahead and complete the restore operation. So let me click on restore. Now when you click on restore object, it is asking you to specify the time available for download. So the default is going to be 24 hours and you can customize this from 1 to 240 hours, right? So this is the time that you will have to download that particular object once you restore it. So let me specify 1 over here and click on restore object. So this restoration can take some time. So you see the storage tier is currently archive restoring. In the meantime, what I am also going to show you is, because when we created the bucket, we created all the 3 buckets with the type standard. So let me go ahead and create a bucket. I will just name it test bucket. The reason why I am creating this is because I want to demonstrate certain features. So I'll select the default storage tier as archive. Rest everything is default and I will click on create. So you see now I have 4 buckets, right? This was the one that I just now created. The default storage tier is archive. So if I go to this test bucket, one thing that I would like to highlight is once you create the bucket and you specify a default storage tier, you cannot change it. For example, here it is archive. I cannot make it standard, right? So that is one thing. Another thing that I want to talk about is for the archive default storage tier, you cannot edit the auto tiering. So the auto tiering is disabled and you don't have an option of edit, right? So, and you can also see the information here. You cannot enable auto tiering on archive storage tier buckets, but you can do that for a standard default storage tier bucket. For example, if I go here, you basically get an option of edit, right? So you can go ahead and you can enable auto tiering. Remember, the auto tiering is always enabled at the bucket level. And if you enable auto tiering, data access pattern is going to be monitored. And the thing that we already talked about, we can enable auto tiering for any standard storage tier bucket, right? So I can go ahead and enable auto tiering. And this is how you do it. Just click on save changes. Right? So we have enabled auto tiering. And then let's monitor this particular operation. So you see the storage tier is archive and it is currently restoring. So as of now, you don't have the ability to download it as the restore operation is in progress. I'm going to pause the video and I will come back when the storage tier shows restored. All right. So now you can see the storage tier is archive restored. And if I go and view the object details, you can see that it is currently available for download for 56 minutes because if you remember, we specified 1 hour, right, as the time. So I'm accessing it after 4 minutes. So it is showing 56 and you can see the status is restored and the storage tier is archive restored, right? So now I will be able to download this particular object. So if I click here, download, the object will get downloaded. So that is what I wanted to show you. Very quickly, because we talked about auto tiering, I just want to talk about one more aspect. So in case you are enabling auto tiering, you must authorize the service to manage objects on your behalf, right? And that is the reason why in order for auto tiering to work, you need to add a policy statement, just like I have done it here. Allow service object storage and then the region identifier. And I want this service to manage object family in the tenancy. In this lesson, we will talk about object lifecycle management. So let's get started. Object lifecycle management lets you manage the lifecycle of your object storage data through automated archiving and deletion, reducing storage costs and saving time. Object lifecycle management works by taking automated action based on the rules you define. And here you can see the supported lifecycle action includes moving to infrequent access, moving to archive, and delete. So the supported resources include object versions, uncommitted or failed multi-part uploads. Now, object-related rules can also have object name prefix and pattern matching condition to narrow the scope of individual lifecycle policy rules. Now, a rule that deletes an object always takes priority over a rule that would move that same object to another storage tier. And if auto tiering is enabled, you cannot create a rule that moves objects to infrequent access tier. You can create up to 1,000 lifecycle rules per bucket. You can also create lifecycle policies on an archive storage bucket. However, only delete rules are supported. Now, let me ask you a question. What happens to the data uploaded to the bucket before policy creation? Remember that lifecycle policies apply to data uploaded to the object storage bucket before the policy was created. For example, if a lifecycle policy rule is implemented that archives all objects over 30 days old and the bucket contains objects that are 40 days old, those objects are going to be identified immediately by the service as candidates for archiving, and the archiving process is going to begin. Let's talk about object name filters. There are two types of object name filters. The first is prefix matching, where there is an exact matching of the leftmost characters of an object name, but it does not support wildcard characters. For example, training/OCI can serve as a prefix for matching purposes in training/OCI/os.jpg. The second type is pattern matching, where the matching happens on the entire object name, and it also supports wildcard characters. For example, if I specify a pattern matching *.jpg, it can match OCI.jpg. It can also match training/OCI test.jpg. Now that we have talked about prefix matching and pattern matching, let's discuss about the precedence of rules during evaluation of object name filters. And as you can see in this slide, there are three types of filters. The first is include by prefix, the second is include by pattern, and the third is exclude by pattern. So if I talk about the precedence, first comes pattern exclusions, then pattern inclusions, and at the last, prefix inclusions are evaluated. Now let's discuss the supported options in lifecycle policy rules. You can move or delete all the objects in the bucket. That is the first supported option. The second option is you can move or delete objects in the bucket that matches the object name filters that you specify. So here you can use both object name prefixes and pattern matching. The third option is to delete uncommitted or failed multi-part uploads. Now, if object versioning is enabled or suspended on a bucket, you can also create lifecycle rules that moves or deletes the previous versions of all the objects in the bucket and the latest version of objects. In this case, you can also specify the object name filters. So if you look at this slide, We can move standard tier objects to the archive tier 30 days after creation or last update, and then after 180 days, we can automatically delete those archived objects. And just to add, you can create another lifecycle policy rule that deletes uncommitted or failed multi-part upload after 5 days. In this demonstration, I will show you how you can work with lifecycle policy rules. So as you can see, I am inside the OCI console and I am currently logged in as storage admin. What you can also see is there are a number of buckets. So let me consider this particular bucket, OCI AA bucket console. And let me talk about some of the changes that I made prior to this demo. The first change that I made was I disabled auto tiering because I want to show you how to work with lifecycle policy rules, right? And I will talk about why I did it. The second change that I made was I enabled object versioning because I also want to show you how to work with object versions when it comes to lifecycle policy rules. Now let me go ahead and upload a couple of sample images. So let me click on upload and I will specify the object name prefix. And I am going to upload image A and image B here. So I'll click on upload. As you can see, the upload is finished. So I'll click on close. So you can see the uploaded objects here under OCI training, and you can see image A and image B. Now what I'm also going to do is without prefixes, I am going to upload another image, that is image C. So those are the objects that I uploaded for the sake of this particular demonstration. So 3 objects, image A, image B, and image C. Now let me go ahead and talk about lifecycle policy rules. We know that lifecycle policy rules provide automated archiving and deletion capabilities, which ultimately is going to reduce storage cost and is also going to save time for us. And be it a standard bucket or be it an archive bucket, you can have a single lifecycle policy, and that single lifecycle policy can support up to 1,000 rules. So you can see this lifecycle policy rules. Here you can create up to 1,000 rules. Now let me first show you which all resources are supported. So if I click on create rule, so you can have the latest version of object. You can also have the previous versions of object, and you can have uncommitted or failed multi-part uploads. So these are the resources that are supported. Now, what are the actions that are supported? So the supported lifecycle actions are move to archive, move to infrequent access, and delete. In case you do not disable auto tiering, this move to infrequent access option is going to be grayed out. And that is the reason why I disabled that. Now there is also a concept of object name filters, which is optional, but you can basically use object name prefixes and pattern matching conditions to narrow the scope of individual lifecycle policy rules, right? So you can basically use prefixes or you can use patterns. And during the demonstration, I'll show you both prefixes and patterns. So I'll be creating 2 separate rules, one with prefix matching and another with pattern matching filter. And there is another option. You can also specify exclude by pattern. We are also going to talk about the precedence of rules, right? We discussed it in the theory lesson, but I'll very quickly talk about how during the evaluation of object name filters, how the rules are evaluated. Basically, it is the pattern exclusion first, then pattern inclusion, and then at the last, prefix inclusion. So that is the precedence of rules. So these are the various options that I quickly wanted to talk about. Now, for the sake of demonstration, let me first go ahead and create my first lifecycle rule. And I will call it first lifecycle rule. And then as the versioning is enabled on top of the bucket, that is the reason why I am able to see previous versions of object as well as the latest version of object. If I would have not enabled versioning, you would have not seen this previous version. So let me create first lifecycle rule, and then I'm going to select latest version of object. And the lifecycle action that I'm going to select is move to infrequent access after 30 days. Now, what is the object name filter that I'm going to use? I am going to first use include by prefix, and I am going to provide this particular prefix. Remember, this prefix matching, it does not support wildcard, right? So let me go ahead and make it 30 and click on create. So this is how you go ahead and create your lifecycle rule. I mentioned that you can have up to 1,000 rules inside a single lifecycle policy. So this is the single lifecycle policy. We have our first rule, and then we can again go ahead and create another rule. This time I can call it second lifecycle rule. And this time again, I want it to be applied on top of the latest version of objects. The lifecycle action in this case is not move to infrequent access. Rather, I will make it move to archive after 90 days. And what I'm also going to do is I'm going to add a filter this time, but not with respect to prefix, but I am going to apply the filter type include by pattern. And in include by pattern, I am just going to use the wildcard. So this is the wildcard that I am going to use. And then the state is enabled. I will go ahead and create this second lifecycle rule. All right. So I have gone ahead and created two rules. The first lifecycle rule says the target is going to be the latest version of objects. And what is the rule? I want to transition the objects that matches this particular condition, filters, to infrequent access after 30 days. And then move to archive after 90 days. And this is basically include by pattern. To give you a sense of which objects are going to be impacted by these two rules, if we consider the first rule, just make a note of the object name filters that we are using, right? So anything within this prefix path is going to be affected. So OCI/training. So if I go inside this OCI/training, so based on the last modified property, both image A and image B are going to be sent to the infrequent access tier after 30 days. So that is how the first rule applies. And if I talk about the second rule does not specify any prefix. So after 90 days, any object that matches this particular pattern will be moved to the archive tier. And can you guess what are going to be the file names that are going to be affected by this filter? So the second rule is going to affect image A, image B, and image C, right? Because here we talked about the pattern matching.
In this lesson, we will talk about object storage replication. So let's get started. So using a replication policy, you can replicate objects in one bucket to another bucket in the same or different region. So after the replication policy is created, the destination bucket becomes read-only and is updated only by replication from the source bucket. Objects that are uploaded to a source bucket after policy creation are asynchronously replicated to the destination bucket. Please note that objects uploaded to the source bucket before the policy creation are not replicated, and objects deleted from the source bucket after the policy creation are automatically deleted
from the destination bucket. So as you can see in the slide, on the left-hand side, we have the OCI Mumbai region, and on the right, we have Hyderabad region. Now there are two buckets in the Mumbai region. Using replication policy, you can replicate the objects in these bucket to either another bucket in the same region or to a target bucket in a different region. Now let's talk about the benefits of performing object storage replication. Firstly, it aids in disaster recovery efforts. Secondly, it addresses data residency and compliance requirements. Thirdly, it provides protection from regional outages as your data is now copied to another region. Finally, maintaining multiple copies of the data in regional locations closer to user access can also help reduce latency. As you can see in this slide, to create a replication policy, you need to provide a name, select a destination region, and specify a destination bucket. Please note that this replication policy does not automatically create this destination bucket. And as you can see here, there's a small note that says replication is going to overwrite any objects in the destination bucket that has the same name as an object in the source bucket. Another key thing that you need to remember is objects uploaded to the source bucket before policy creation are not replicated. Now let's talk about some limitations and other considerations. Replication policy creation does not automatically create a destination bucket. So you have to create the destination bucket before creating the replication policy on the source bucket. A source or destination bucket can be in the standard or the archive storage tier. Remember that we can have a maximum of one replication policy per source bucket, maximum of one source for each replication destination bucket, and maximum of one destination for each replication source bucket. A destination bucket cannot also be the replication source. What it means is chain replication is not supported. After you create the replication policy, the destination bucket becomes read-only, meaning you cannot upload objects in that bucket directly. The only option you have is to upload objects in the source bucket, and that would then get replicated. You cannot delete a replication destination bucket unless you stop replication and make the bucket writable again. And there are two ways in which you can stop the replication. You can either delete the replication policy from the source, or you can make the destination bucket writable by stopping the replication in the destination.
In this demonstration, I'm going to show you how you can create a replication policy. So as you can see, I am logged into the OCI console as storage admin, and currently I am in the Phoenix region in this particular tab. And in this second tab, I am in the Ashburn region. So let me first go ahead and create a source bucket in the Phoenix region. So I'll click on create bucket. I'll name it source bucket, and rest everything remains the default. I'll click on create. So once this bucket gets created, let me go ahead and upload certain objects. So I'll go ahead and upload image A. And remember, I am doing this upload operation before creating the replication policy. So now I have the source bucket created, and I also have image A uploaded, right? As of now, I don't have any bucket in the destination. Remember that before you create the replication policy, you need to have the bucket created in the destination or the target region. So before I create the replication policy, I will also create this target bucket. So I'll name it target bucket, and I'll click on create. So now the target bucket is created. And currently you will be able to upload objects because currently it is in a read-write state. So let me go back to the source region or Phoenix region where I have the source bucket. So under resources, I will go to the replication policy and I will click on create policy. I will give it a name, OCI replication policy. I'll select the destination region. In my case, it is going to be Ashburn. And I will select the destination bucket. In my case, it is target bucket. And I will click on create. Now, once this replication policy gets created, you can see the changes. For example, in the source bucket, it says replication is enabled and it is the source. If I go to the destination region and just go to this target bucket, you can see that this is a replication destination bucket and you will not be able to upload any new objects here, and the replication is enabled and it is the destination. One more key takeaway from this demonstration is if you go to the target bucket and if you go to object, you will not be able to see the object that we uploaded prior to creating the replication policy on the source region. So if you see here in the source bucket, I already have an object. So this object I uploaded before creating the replication policy, right? And I don't see that particular object getting replicated to my target bucket. So just make a note that existing objects are not copied. Now let me go ahead and upload another object. This time I am going to upload image B. I'll click on upload. And as you can see on the source side, I have two images, image A and image B. If I go to the destination region, this particular target bucket, I can just see image B. So image B got replicated, but not image A. So this is about replication. Now, if I go ahead and delete this image B from the source side, now if I go to the destination region, that is Ashburn, and just click on refresh, now if I go to the objects, I don't see any object. Why? Because I deleted image B from the source bucket. So that is another key takeaway. Now the final thing before I wrap up this demonstration is how do we delete the replication policy from source, or how do we stop the replication from destination? So from the source bucket, if you go to the replication policy, you can just click here and click on delete, right? The moment you delete this replication policy, it is going to stop the replication and you cannot recover the deleted policy. So this is how you do it. On the destination side, if I go to the replication policy, there I don't have the option to delete the policy because it is the destination. But what I can do is I can go ahead and stop the replication. So if you stop the replication, the policy is removed from this destination and it cannot be recovered. One more thing that you need to keep in mind is this bucket, when it was a destination bucket, it was only read-only bucket, right? So I mentioned that you cannot upload objects to the destination bucket manually. The moment you stop the replication, it reverts back to the standard read-write bucket. So you can just click on stop replication. And this bucket now becomes read-write. So this marks the end of this demonstration.